Hello! Welcome to the Web Security and Bug Bounty course. Now, you've already seen the promo video and you kind of know what this course is about, but in this video, we want to do a full course outline so that you know exactly what we're going to learn so that you have a clear path to success and what this course is going to give you. Now, one thing to keep in mind is that this course isn't just for ethical hackers or penetration testers. We've made this course so that anybody that's interested in web security can learn from it. So if you are a web developer that wants to improve their web app security, well, this course is for you as well. And obviously, if you want to become a bug bounty hunter or a penetration tester, well, this course is definitely for you as well. All right, let's get into actually what the course is going to look like for you. Right off the bat, we're going to start off by creating what we call our virtual lab. This is a hacking lab to make sure that we keep our computers safe throughout the course, and we can do different sorts of attacks and experiments on them. And this course is going to work with any type of system that you have. Linux, Windows, Mac OS, everything's going to work because we're going to set up this virtual lab for you. From there, we're going to learn about enumeration and information gathering. This is where we actually start with the bug bounty and website penetration testing. We cover numerous topics and tools that allow us to gather as much information about a certain website as possible. From there, we get into introducing you to Burp Suite. And this is a very important tool of a bug hunter. And it will set us up for a lot of the topics that we cover later in the course. We then get into our first bug. And this first bug on a website, we're going to talk about HTML injection. It's one of the easier bugs to find and use, so this is where we start. But then we get into more complex topics. For example, we're going to talk about command injections and execution. This is an extremely dangerous bug where we can inject commands through an input and affect a server or a system. We then talk about broken authentication. What happens when authentication on a website is not done properly? Well, we can take advantage of it, and we're going to show you how to do that. And we're going to use different examples to things like cookie values, HTTP requests, forgot password page, and a lot more. We then get into brute force attacks. Even if a website is secure, if we as testers have an easy and simple password set, then it's also going to be easy for us to guess it using what we call brute force attacks. And we're going to show you how to prevent brute force attacks as well as show you how they work. We then talk about broken access control. Access control enforces policies such as what user can and cannot do, or intended permissions for a user. When that access control is broken, well, we can take advantage of it. Then we dive into what we call cross-site scripting. This is a very common attack, and we're going to talk about all three main types of cross-site scripting, which are stored, reflected, and DOM-based cross-site scripting. Then we dive into one of the most common ways that you can affect a system, and probably one of the bigger vulnerabilities that always comes up, and that is SQL injection. This is where we're able to access or manipulate the database. This is probably one of the most important sections, and again, we're going to talk about how we can use it and also how to prevent it. I know we have a lot, there's still a few more. In this section, we're going to talk about XML data and how we can use XXC or XML external entity, where it allows an attacker to interfere with a website that processes XML data. Finally, we talk about the idea of insufficient logging and monitoring. You see, to have proper security, you need to have proper logging and monitoring to keep track of all the requests and information that a page might go through, because this can help us determine whether a certain attack is taking place or not. If we don't know an attack is taking place, well, then we're just not going to notice it. So this is another important topic that we left towards the end of the course. But then probably why you're taking this course and the most exciting part is right here, the bug hunting. So we're going to talk about how to monetize bug hunting. How can you become an independent researcher that tests websites and perhaps collects bug bounty? Everything that we've learned in this course, we're going to show you how you can monetize this knowledge. And we're going to talk to you about different platforms that you can use to start a career as a bug hunter, if that's something that you want to do. Finally, this course is meant for anybody with any sort of programming knowledge. As a matter of fact, you can take this course without any programming knowledge. We include bonus material for web developer fundamentals, bonus material on Linux and how to use the Linux terminal, and even networking. The idea is to take you from zero to mastery. Finally, this course, well, you're in good hands because Alexa is a penetration tester with many years of experience, and he's actually worked on discovering vulnerabilities for multiple companies and government systems. He's going to show you from his professional standpoint how all of these work and how you can actually apply these in real life. It's going to be a ton of fun. And the final thing I want to talk about is our community that we have. When you join this course, as always, as part of the Zero to Mastery community, you get to join our private online Discord where we're chatting with people every day, helping each other out, solving problems, doing challenges together, and feeling like you're part of a classroom. You're going to find myself and Alexa on there every day chatting, and we have a dedicated channel just for this course so that you get to meet other classmates. All right. That's enough talk. I think it's time to get started. Let's dive into the course and let's learn all about web security. Hey there, this is Andre. You're about to dive into the course. But here's the truth. Most people won't finish this course. Why? It's because doing a course from the comfort of your home is going to take something away that is one of the most critical parts of doing anything challenging and worthwhile. Accountability. It's a lot harder to stop going to elementary school than to stop watching an online course, right? But here's the thing. There is a way to guarantee right now that you will finish the course and you will get through the ZTM courses no matter how hard they get. And trust me, it's going to get hard because we want to teach you really valuable skills, and they are valuable because they're hard to acquire. And this is why you're here. If you don't finish the course, it's a waste of your money. But if you finish the course, we truly believe it will get you the skills that you want. So this is what you're going to do that might put you outside your comfort zone, but it will be extremely effective in increasing your chances of success. Ready for it? You're going to come join our online classroom. In the next lecture, I'll provide a private link only for ZTM students. In there are 3 things I will ask you to do. 1 is to introduce yourself to the community. You can share as little or as much as you want about yourself. I'm going to finish X course by this date, and put that date in your calendar too. Number 2, go to Accountability Buddy's channel. Oh, that's a mouthful. And find someone who is starting a ZTM course right now at the same time. It doesn't have to be the same course, and you can have multiple partners. You're going to make sure that you each finish the course and the goals you set out to do. Finally, number 3, hang out in the general chat and talk about anything that you want. You will also have course-specific channels that you can chat in. You want to be surrounded by other learners like you to stay motivated and being part of a class. Now in here, we're also going to have virtual hangout sessions with myself, other ZTM instructors, and students. I recommend having the Discord server open as you go through the course and as you are learning. Now, I'm not saying this to sell you something. This is simply a fact of learning. When you learn in a group, when you surround yourself with other learners, when you have accountability, you are more likely to succeed. It's a fact. Finally, throughout the course, as you encounter problems or challenges, don't give up. Come back to our Discord server and ask questions and get help. But most importantly, as you start to learn and grow your skills, come here and help out other students. Teaching and helping others is one of the best ways to retain the information you just learned. If you create this routine around your learning, opening up Discord, start watching the lessons, surround yourself with others that have similar goals to you, you will have the accountability and the support system to finish the course. I promise you. Oh, and another fun bit, when you finish the course, you post your certificate in the alumni channel to become an alumni. And then who knows, the people that really are stars of the community become star mentors. Ooh. Now, this all may sound silly. You may say that you don't need anybody. But trust me, we've been doing this for many years, and there is this consistent trend of those that finish the course, get hired, and find success in their careers. You have to do the things that are uncomfortable sometimes to succeed. So that's it. See you in the next lecture and see you in our community.
Hello and welcome to the course. Now, the best way that we can start this is by explaining what even is penetration testing. Most of you will know this, but let's still cover it as a refresher at least. So, whether we're talking about network penetration testing or website penetration testing or something as simple as a single device penetration testing, all of this has the same part inside of their name: penetration testing. So, what is it? Well, we can refer to it as an action that we apply to enumerate and discover new vulnerabilities, as well as exploit them and take control of our target system. Now, most of you might or might not know, but penetration testing is constructed of a couple of stages. Let's say we have our hacking machine on the left, and the target device that we're trying to gain access to is on the right. This device can be anything, from a PC to a mobile phone to a website application. It doesn't really matter, the process of penetration testing goes the same. We start off with gathering information. We want to know as much about our target as possible. Why? Well, this allows us to better plan out our attack later on. Gathering information can be done both actively and passively. Active information gathering is gathering information by interacting with the target, while passive information gathering means that we get all of our information without ever interacting with the target in any way. For example, we can get information about Facebook by Googling it and reading about it on another site like Wikipedia. That is considered passive information gathering. After this comes scanning. Now, scanning is a deeper form of information gathering, and it's done actively, which means we directly interact with the target in order to find out more information about it. Usually, this will be the information of technical nature, like what technologies does the target run, what is their website made of if they have one, which ports do they have open, and so on and so on. We finish scanning by performing vulnerability analysis. Vulnerability analysis is just us finding security holes in the target system with the help of information that we gathered. After that, we can successfully exploit the target by using different methods and attacks. These are the main steps to penetration testing. There are other steps, of course, that come after, like maintaining access on the target machine and covering tracks, but these steps that we mentioned are crucial. Now that we covered and went through the basic steps of penetration testing and what those steps are, we can also say that penetration testing can be divided into two main groups. We got network penetration testing, which could, for example, be, let's say, a company gives you their IP ranges of their networks, and we're supposed to perform a penetration test on all of their devices to see if there are any security issues. Those devices could be anything from computers, mobile phones, to printers. And for the second group, we can say that it's website application penetration testing. Here we perform various different attacks to determine whether the website that we are attacking is properly coded and secured. And website penetration testing is something that we will put the most focus on inside of this course. This is because this field is becoming bigger and bigger every single day, due to millions and millions of websites that are online and available right now on the internet. The search for people to secure and protect them is rising every day. You might have also heard of a term called bug bounty. This is pretty much the same thing. It's mostly referring to discovering bugs, or also known as vulnerabilities, inside a web page. And bug bounty is something that we'll discuss a little bit more in the next video, but before we get to it, let's mention what are the two main things we need to perform bug bounty, or website penetration testing. So we will need a virtual machine and a vulnerable web page. Now, we will install a virtual machine to create our own hacking lab or environment that we will use to perform all of our attacks. But as you may notice, to be able to perform a penetration test on a website, we will need a website, right? Luckily, there are many vulnerable web pages that we can run within our local network on a virtual machine that are useful for practicing different attacks and discovering different bugs. And that is also why we need to cover virtual machines. Now, don't worry, we will cover installing all of these. From installing our own machine that we will use to hack, to installing machines with a vulnerable web page. And trust me, it's not that hard as it might sound like. Nonetheless, now that we mentioned some basics of penetration testing, let's discuss bug bounty in the next video. See you there. Welcome back. Let's discuss bug bounty a little bit. We mentioned it in the previous video, but what exactly is it? There is one thing that we know. It has nothing to do with the real bugs. Bug bounty or hunting for bugs is mostly referred as discovering vulnerabilities in a web page. Now, you can hunt for bugs in applications and other type of programs, but usually when someone says bug hunting or bug bounty, it's referred to as a website bug or a vulnerability. Now, these vulnerabilities can be anything from password vulnerabilities. Maybe they are not encrypted well and the attacker can easily break them. Or perhaps there is a database vulnerability and the attacker can extract all of the information from the database, including usernames, passwords, emails, and other personal information that shouldn't be public. Some vulnerabilities can also target not only websites, but client devices as well. By this, I mean that there are vulnerabilities that could also be dangerous for the client that visits a vulnerable web page. But don't worry, all of this is something that we will talk about in the course, and we will explain how all of these attacks work. For now, it's important that we mention what do we need before we even start hacking. So the first thing that we want to do is to create a virtual environment. And this is something that we mentioned in the previous video. We want to create a virtual machine that we will use for hacking. This will be our own personal machine that we're strictly going to use to run different tools and perform different attacks. But we will also be installing vulnerable virtual machines that are running a web page that we can attack and that we can practice on. Why, you might be asking? Well, we can't just target any website without permission. That is why we're going to create our own machine with a website that we can attack as much as we want. Second thing that we must get used to is Kali Linux. Now, Kali Linux is an operating system the penetration testers use. You probably already know it, but we're going to use it inside of this course. It is a Linux-based operating system that comes with a bunch of useful tools that a hacker needs. Out of all of that, the most important thing for us to learn is to introduce ourselves with basic command line usage inside of Linux. Don't worry, it will be nothing too advanced, we just want to cover the basics. And the last but not least, we need some basic website structure knowledge. We need to understand the basics of website development, just so we can understand the attacks better. For this, we need to know what different programming languages in web development are used for, and we need to recognize them. So we will briefly cover HTML, JavaScript, PHP, and SQL. Why do we need to cover this? Well, most of these attacks are based on injecting code from these programming languages. But let's not confuse ourselves right now, we will talk about that when the time comes. Right now, I want to show you a quick little bug that is easy to perform, yet it's still considered a small vulnerability. Just so I can give you an insight on how easy can it be to sometimes discover a bug. So here I am on a web page that I'm running inside of my local network, and we can see that this web page right here performs a simple task. It asks us to enter the background color that we would like to see. Whatever color we enter, the background will change color. So for example, if I type red and set background color, nothing will change because it tells us to enter the color in this format. And it even gives us an example. Now this is not important for us, so let's just copy the example for the red color and let's paste it right here. If we set background color, wow, it changes to red. But is this the only thing that this web page can perform? What if we, for example, try to inject HTML code inside of this input right here? Well, let's give it a try. The most simple HTML code that we can enter is h1, which stands for header size 1, and then test. And then we close the tags for the header. Don't worry if you don't know this, we will cover this as well. And if I set background color, it tells me the current background color is test. Just by looking at this, I can already tell that this is a bug in this web page. You might not be able to tell it right now, but by the end of the course, recognizing these bugs will become second nature for you. So, what did I notice here? Well, we typed some text in the size of a header 1, and it seems that this website or web page executed it. It read it as an HTML code, and it printed our text in size of header 1. Even if we try to, for example, underline by using U inside of the HTML tags and using header 1 and then typing test again, then we close header 1 and close underline tags. We click set background color. Well, now we got our text written in size header 1 and also underlined. And this is called HTML injection. This is a bug where the web page allows you to input HTML code in some user input field, which in this case is this background color field, and the web page will process it as HTML code. So we can conclude that this user input is not filtered well. If this is too overwhelming for now, don't worry, we will explain all of this in details later in the course. I just wanted to show you a cool little bug that is so easy to find, yet it is discoverable in so many websites that are currently online. Now, enough of talking. Now that we explained bug bounty a little bit, let's get straight into setting up our virtual environment. See you in the next video.
Hey everybody, welcome to your ZTM course. Now, as part of being a ZTM student, you get to have a couple of nice freebies, a little bonus, a little extras that all the students that are part of ZTM get. Let me show you some of the extra things you get as part of this course. First off, we already talked about it, but we have a pretty big community of tech enthusiasts, learners. So we have a ton of coding challenges. If you go to our website and go to the community tab, we have coding challenges that you can practice some skills with. We have open source projects that are open to anybody, that anybody can participate that's part of ZTM. We have our Discord server, we have campus events, which is like a live virtual classroom that you get to meet other students and talk to them. And we also have events like Advent of Code or Hacktoberfest throughout the year. We also have cheat sheets. Now, these are all free. None of this requires any sign up. You can just open up a cheat sheet that is related to your course that you want to check out. Let's say we want to check out the JavaScript one. Well, you can actually go through the cheat sheet here and follow along with the course and maybe take notes along the way. These cheat sheets, we add every month a new cheat sheet. So you can just keep an eye on this tab and check out different cheat sheets based on your interests. We also have our blog where we post 2 to 3 blog posts a week, so quite a lot. And we have different topics for beginners, for people that are already working in the industry, different instructor posts. We also have posts about how to get hired, so on and so forth. So you can check out our blog, and we have different tabs here. Obviously, beginner, start here, advance your career. But the most important one is right here. We have monthly industry newsletters. So every month, myself and other ZTM instructors write a recap of what happened that month in the industry. You know how you're always overwhelmed with blog posts, what to read, how to stay up to date with the industry? Well, we try to make it easy for you so that you don't have to read 100 blog posts, watch 100 YouTube videos every month just to stay up to date. Instead, we recap what happened in the industry. So we have a Web Developer Monthly that recaps what happened in the industry that month, what are the best resources to read, what is the big takeaway, all digested into one blog post like this one. But we also have one for Python, one for machine learning, and a blockchain developer. Now we're going to add a few more throughout the year, but these should cover a lot of the interests that students have. Now, finally, you can also check out our career paths. So this, if you're looking for a certain career, will give you advice on what path to follow, when to apply for jobs, what sort of skill levels are required for each of these careers. So again, this website you can use for free, doesn't require any sign up, and you can find different sort of information based on your needs. Now, two last things. One is that we have a LinkedIn group for all our students. So this is great if you want to have a LinkedIn profile and you want to endorse each other's skills, get advice, career advice from people. So there's lots of things happening in our group, and people are always sharing job openings, tips and advice on career, and also endorsing each other's skill. So if you want to boost your LinkedIn profile, this is a great place to start. And then finally, we also have a YouTube channel that we recently started, and we're posting about 3 to 4 videos a week, different topics that are free that you can kind of check out. And as you see, we already have a ton here. We're going to have a lot more coming up throughout the year, but you can check out our YouTube channel, Zero to Mastery, as well. All of these you get for free as being part of the ZTM student. So enjoy, good luck, use these resources to your advantage, and welcome to ZTM.
All right, time to set up our virtual environment. Now, there are a lot of things that we must do. First, as we said, we must create a virtual machine that we're going to use. For that, we need the virtualization software and the operating system that we want to install. The operating system that we're going to use will be Kali Linux, as we previously mentioned. And also besides that, we will also need a virtual machine that will host vulnerable web pages that we can attack. And another way that we're going to practice will be through a website called TryHackMe. Now, this website does offer a paid subscription, but we're going to cover things that the website offers for free, just so we can include everyone inside of it. It has really good practice examples of website vulnerabilities. With the combination of vulnerable virtual machine and with practice examples on this website, we will cover most known and most common website vulnerabilities. Okay, let's first start off by downloading VirtualBox, which is the virtualization software that we will use, and let's also download our Kali Linux operating system. Let's start with VirtualBox first. To download VirtualBox, we want to navigate to the page virtualbox.org. It will lead you to this official page of the website, and if you want, you can read through all of these articles and about VirtualBox if you'd like, but right now we're going to see how we can download and install it. As it says, it has a big download button, so let's just click on it, and it will lead us to this page, which will offer us different platform packages based on which operating system you're running. As we can see, the current version is 6.1.18. And the current platform packages that they have are for Windows hosts, OS X hosts, Linux distributions, and Solaris hosts. Depending on your operating system, you want to choose which one you want to install. Since I'm running Windows on this machine, I will click on Windows hosts. It will ask me where it wants to download VirtualBox. I will just select desktop and click save. And as you can see, it will start downloading it right here. Since I already have it, I will just cancel this download. I already have it installed, so I'm not going to do that right now. And while it's downloading for you, let's navigate to the Kali Linux official website, which is at link kali.org, and let's see how we can download Kali Linux operating system. Okay, so we open up this page. It says the most advanced penetration testing distribution. And as with VirtualBox, it has this download button. Let's click on it. and it will lead us to the official download page. Now this downloads page offers the newest release of Kali Linux, or should I say the newest official release, because you also have the weekly unstable and untested releases. We're interested in the official stable release. Currently it is the Kali Linux 2021.1, and the new version of Kali Linux actually comes out pretty much every 2 months. So if you encounter a newer version of Kali Linux or a newer version of VirtualBox, feel free to download that one instead. Since right now the newest one is 2021.1, I will download this one. Now we have quite a few options right here that we can choose from. We have the Kali Linux 64-bit installer, Kali Linux 64-bit live, and Kali Linux 64-bit net installer. As well, we have for Apple M1, we have Kali Linux ARM64 installer, we have the live and the net installer, and we also have for 32-bit systems. Now, if you're running Apple M1, you can go with this one. If you're running a 64-bit machine, you can go with Kali Linux 64-bit installer. And if you're in any case, which I doubt anyone will be running a 32-bit machine, but if you do, you can download Kali Linux 32-bit installer. Now, since I'm running a 64-bit Windows machine, I will go with Kali Linux 64-bit installer. If I click on this, it will once again ask me where I want to download it. I will select desktop and I will click save. You will notice that the size of this file is pretty large, it's 4 GB, so it will take some time. Now, luckily I already have it, so I'm just going to cancel this download. You just wait for both of your downloads to finish and then we can proceed. Oh, and by the way, you also have an option to download it over torrent if you'd like. It's completely up to you. Okay, awesome. Now, let's say that you have both of your files ready, if you don't just pause this video until your downloads are finished, and you should have these 2 files on your desktop. Let's go with installing VirtualBox first. So to do that, we can double click the installer file. It will open the welcome window. We want to just go next. We want to go next here as well. And here you can uncheck some option if you don't like. I will just create a shortcut on the desktop and I will leave everything checked and click on next. And here we have a warning that says installing the Oracle VM VirtualBox networking feature will reset your network connection and temporarily disconnect you from the network. Proceed with installation now. So this pretty much says in case you're doing something important over the internet, make sure you finish with that first before installing VirtualBox. Otherwise you might have some internet connection problems during the installation. I will just select here proceed and I will click install. Okay, so here it asks for administrator password. Since I don't have one, I will just click here yes and it will install VirtualBox for me. This doesn't take much time. It takes maybe a minute or 2 depending on your system, and once it finishes it should open up your VirtualBox. And here is the finish window. We want to check Start Oracle VirtualBox and click on Finish. Let's wait a couple of seconds and here it is. This is the window of Oracle VirtualBox. Now let's do one more thing before we end this video. Let's see how we can create a virtual machine inside of VirtualBox. So this is the official window that we have. We have a couple of buttons right here, and here will be our machines that we currently don't have. So let's create one. Let's create our Kali Linux virtual machine. To do that, we want to click on this button that says New. Click on it, and it will ask us for a couple of information. Name of the virtual machine, and here let's say that we type Kali 2021. Here you can select the path where the machine folder will be stored. Here we select the type of operating system, and since Kali Linux is a Linux operating system, we will select right here Linux. And the version, now this can be a little bit tricky if you don't know, but luckily I'm here to tell you that Kali Linux is based on Debian, so we want to select here Debian 64-bit, or in case you have a 32-bit machine, you want to select Debian 32-bit. Since we downloaded the Kali Linux 64-bit and we have a 64-bit machine, we want to proceed with the version of Debian 64-bit. Let's click on Next. the next thing that it asks us is what RAM memory we want to give to this virtual machine. This is completely up to you. I'm just here to advise you that you should not go below 1 GB of RAM, and 2 GB of RAM is pretty much all you need. You don't need more than this. If you have like 4 GB of RAM or less, feel free to proceed by setting only 1 GB, but since I have more than 4 GB of RAM on my host machine, I can set here at least 2 GB. If you have like 32 GB of RAM on your host machine, you can even increase this up to 4 or 8 GB of RAM, depending on how fast you want your machine to work. Now, I'm completely fine with 2, so I'm just going to select 2048 megabytes, and I'm going to click on Next. Under the hard disk, it asks us for a couple of options. We just want to stick with the one that's already checked, which is Create a Virtual Hard Disk Now, and we want to click on Create. The hard disk file type will be VDI or VirtualBox Disk Image. Click on Next. And storage on physical hard disk. Now, this is completely up to you. I'm just going to go with dynamically allocated, and you have the explanation of both of these right here. As it says, a dynamically allocated hard disk file will only use space on your physical hard disk as it fills up to the maximum fixed size, although it will not shrink again automatically when space on it is freed. And a fixed size hard disk file may take longer to create on some systems, but it is often faster to use. So a fixed size is indeed sometimes faster to use, but nonetheless, I'm just going to go with dynamically allocated, and I'm going to click on Next. And the last option, I believe, is how much disk size we want to give to our virtual machine. Now, I advise you not to go below 25 to 30 gigabytes of hard disk space. I'm just going to select here like 38, it doesn't really matter. You can give it more or less if you'd like, but don't go below 20 to 25 gigabytes. Otherwise, your machine might not work. Okay? Now that we selected all of this, we can click on Create. And as you can see, we created our first virtual machine. We have it right here, as well as we have its information on the right. We have its general information, system information, display settings, storage settings, and a bunch of other things that we're going to take a look at in the next video. This doesn't mean that our machine will work. We still have an operating system to install before being able to use this machine. For now, we only created it inside of VirtualBox. In the next video, we're going to add our Kali Linux operating system or ISO image that we downloaded from the official website, and we're going to install it inside of this virtual machine. And hopefully, by the end of next video, we will have a working Kali Linux virtual machine. Welcome back. Just a quick update on the new Kali Linux website. Okay, so they have just changed the downloads section of this page. And how they made it can be a little bit confusing, so I'm just making a quick update video to explain which exact version should you download. So once you navigate to the Kali Linux page, navigate to the download section, and this is the new design. They separated different versions into different categories on this page. Now, since we talked about virtual machines, it might seem to you that we want to go to the virtual machines and download a version from here. But not exactly. For our course, we want to go to the bare metal, click on that, and here we want to download the version accordingly. We select 64-bit or 32-bit depending on our machine. Since my machine is 64-bit, I would go with the 64-bit version. If you're running an Apple M1 chip, then you want to select this one. Since once again, I'm running 64-bit, I want to go 64-bit installer, and it will download the ISO image on my desktop. Awesome. That's all that I wanted to say, and let's continue with the course. Welcome back. So in the previous video, we created our first virtual machine inside of our VirtualBox. Now it is time that we install our Kali Linux operating system inside of this machine. But to be able to do that, we want to change some settings inside of this machine first, before we actually start it. So, to access the settings of a virtual machine, we can select the virtual machine inside of our VirtualBox manager and click on Settings. Now, to even be able to install the Kali Linux operating system, we must first add it to this machine, right? And to do that inside of VirtualBox, we must navigate to the storage settings, and under the controller IDE, we want to click on this add icon. And if you didn't see it really well, it just looks like a disk with a plus. Pretty much click on it, and you want to click on this add button right here. Once you do that, you want to navigate to wherever you have your ISO image saved or your Kali Linux image saved. For me, it's on desktop, and you want to double click it. Then you want to select it right here in this small window, and you want to click on choose. Now under the controller IDE, you will have your Kali Linux image and you will have this empty image. Now this empty image we don't really need, so we can just right click it and remove attachment, and we will be left with just Kali Linux 2021.1 version. Okay, another thing that we want to do inside of the settings is we want to navigate to the network settings, and we want to change the NAT to bridged adapter. Now, if you want to read more about these adapters inside of VirtualBox, you can check out our networking PDF file that we created for this course, and it has an explanation on all of these adapters right here and why we use this one. In short words, we use bridged adapter because it allows our DHCP from our network to give an IP address to our Kali Linux virtual machine, and in this case our Kali Linux virtual machine will be viewed as another device on our network. It will be able to communicate with all the other devices inside of our network, with our router, with a laptop that you might have connected, with your mobile device. But if you have it under NAT, which is by default, it won't be able to do that. So let's just change it to bridged adapter, and under here you want to select the adapter name or the adapter that you want to use. Now, what I found from personal experience is that if you go with cable connection, it most likely will always work. Now, wireless adapters know to create problems sometimes, and they might need some additional drivers installation in order to run. So if you're able to, try going with cable or wired connection. Okay, awesome. These are the two settings that we wanted to change. Once we do that, we can click on OK, and right now we are ready to start our virtual machine. To do that, we want to click on this start arrow, and it will run our virtual machine. Or it will start the installation process of Kali Linux. Remember, it's an operating system, so it must be installed first. Here is the window of our virtual machine, and you will notice if you try to enlarge it, it will pretty much stay the same size. It will have this white surrounding it, but don't worry, it will not stay like this forever. It will only stay like this during the installation. So what we want to do is we want to choose the graphical install right here in this menu. You can also go with the install, but graphical install looks a little bit better. Let's click here, enter. And by the way, your mouse will not work inside of the virtual machine yet during the installation, so you must navigate with your keyboard inside of the installation process. Let's wait for the next step. And here it is. We want to select the language to be English for me. You can choose whichever language you want. The location, it doesn't really matter. I will just select United States, and the configuration of the keyboard. You can also choose whatever you like right here. I'm going to go with American English and click on next. And this installation process will actually take about an hour to finish. So of course this is not going to be an hour-long video, so I'm just going to skip through some longer parts of installation, and I'm just going to cover the steps where we actually have to choose something. I will fast forward the installation so you don't have to sit through a 1 hour video. Okay, so let's wait for the next step. And here is the next thing that comes up, which is configuring the network. So it asks us, please enter the host name for this system. You can type here also anything that you want. I'm just going to type here Kali, because we're installing Kali Linux. Press enter, And the next thing that it asks is the domain name. Here, for the purposes of the course, we don't need to set anything, we can just leave it empty and we can press enter to continue. Now, a user account must be created. So here, you create the full name for the user. For the purposes of this course, I'm just going to call it Mr. Hacker. Click on continue, and the username for the account that you will use to log in to Kali Linux. The account name will also be Mr. Hacker for me. For you, choose anything that you like, just make sure that you remember it after the installation. And press enter, and now we need to set the password for the user. Here you type the password, whatever you like, and here you confirm the password. Awesome. Once you do that, you also have an option to show password in clear. I don't really need that, so I'm just going to go on continue. And you can see sometimes mouse actually works, but sometimes it doesn't, so I'm just going to go and navigate again with my keyboard and select the time zone that I'm at. Since I'm at Eastern time zone, I'm going to select Eastern, you select whichever you want, and it will continue with the installation. Let's wait for the next step. And here it is, partitioning disks. Now this might be a little bit harder for you to understand in case you're first time running Linux. Nonetheless, here we want to go with the guided use entire disk. We don't want to go any other option, and here we want to select our own hard disk that we created. So you will probably have only one option here, just select that one and click enter. And at this part, we want to go with all files in one partition, as it says it's recommended for new users. For those of you that ran Linux before, you might also be familiar with /home/var/tmp, and these are just some directories that we get inside of Linux. Picture them as just some already made folders that Linux system gives us after the installation. We don't want to separate any of these. Let's pretend that we don't know anything about this, so we're just going to go with the recommended settings that says all files in one partition and click enter. It will ask us finish partitioning and write changes to disk. We want to click enter. And here it asks us for the confirmation where we want to click yes, so change from no to yes, and click enter. And this will pretty much start the installation process of your Kali Linux. Now there will be a couple of more questions during the installation, so I'm just going to fast forward to the next question. Okay, so after a couple of minutes we get this window prompted, so it asks us to customize our own desktop with different settings. So here, what we want to do is we want to select all of these that are checked by default, which is desktop environment, XFCE, and collection of tools. However, we also want to check this large option right here. This means that it will also install some additional tools inside of our Kali Linux machine. And the more tools, the better. We never know when we are going to use some of these tools, so let's just go and select large and we can proceed with the installation. This next part will take some time to finish. It will take around 30 to 40 minutes to finish, so just sit back, grab something to drink, and I will see you guys when the next question pops up. Okay, so here's the next question. And this isn't really that important to us. It would be more important if we were to install Kali Linux as a main operating system and not as a virtual machine. But let's read it nonetheless. As it says, it seems that this is the new installation is the only operating system on this computer. If so, it should be safe to install the grub bootloader to your primary drive. Warning, if your computer has another operating system that the installer failed to detect, this will make that operating system temporarily unbootable, though grub can be manually configured later to boot it. Now here we want to select yes, because our virtual machine doesn't have any other operating system running besides Kali Linux. So let's select yes right here and let's click on continue. Under here we want to select this /dev/sda and we want to click on continue. And this will pretty much finish our installation. It will take a couple more minutes for this to end, and then we will have a working Kali Linux virtual machine. And here is the last question. It says installation is complete, so it is time to boot into your new system. Make sure to remove any installation media so that you boot into the new system rather than restarting the installation. Since we don't have any installation media, we can just click on continue without unplugging anything or removing anything, and our installation is complete. Now our virtual machine will reboot and we will be able to use our Kali Linux virtual machine. Let's wait for a couple of seconds for our login screen to pop out. And here is our login screen. Our Kali Linux machine is working perfectly. Awesome. Now, here we want to type in the username that we created during the installation, as well as the password that we set during the installation. So I'm just going to go with Mr. Hacker, because that is what I set, and I will type here the password for Mr. Hacker account. This will open our desktop environment. In case you're also stuck like this with a smaller screen, in order to make your machine full screen, you can just lower the screen and enlarge it once again, and this will actually fix the issue in 90% of cases. And now we can see the Kali Linux desktop environment. As I mentioned, and as we already know by now, this is a Linux system. So if you're not familiar with the Linux system and the Linux terminal, command lines, and commands that we will use, make sure that you check out the bonus section of the course where we actually cover Linux basics, where we teach the basic commands, where we teach how we can use Linux terminal in order to execute what we want. Nonetheless, if you are familiar with Linux and with Linux terminal, feel free to proceed with the course. We made our virtual hacking machine, and the next thing that we want to do is we want to create a virtual machine that we will use to attack. Okay, awesome. We finished a big part of setting up our virtual lab, and I will see you guys in the next video. Welcome back. It's time to install the machine that we will use to attack. For this course, I have chosen the OWASP Broken Web Applications project. Why this machine? Well, first of all, it's very simple to install. It takes quite a little time compared to Kali Linux. It will only take us a minute or two to install it. And it also has a bunch of vulnerable web applications hosted on this machine that we can use to target and attack. Now, to download it, we can navigate to the link of sourceforge.net/projects/OWASP-BWA. Under this link, we will have the download button, and then just by clicking on it, we can start the downloading process, which will ask us where we want to save the OWASP Broken Web Application virtual machine. Now, since I already have it downloaded, I'm not going to do that, but I just saved it right here on my desktop. And as you may notice, once you start downloading it, it will take a couple of minutes because the file size is around 2 GB large. But once you finish with the downloading, you will have this zip file right here. So in order to get our files that we need, we must extract this zip file first. After you extract it, you will get a folder like this, and inside of that folder, you will have these files. Now, these are the files that we need in order to create a virtual machine. So let's get straight to creating it. Okay, open up your VirtualBox, and we're already familiar as to how we can start the process of creating a virtual machine. Navigate to Tools and click on New. Now, we get this window that we got for our Kali Linux as well, and here we're just going to call it OWASP-BWA. Now, of course, you can call it whatever you like. I'm just going to leave it with this name, and since this is also a Linux machine, under the type, we want to select Linux. The version of Linux, however, should be all the way down to Other Linux 64 or Other Linux 32-bit. Let me select Other Linux 64-bit, and I will proceed on Next. Under the memory size, you can leave it anything between 512 megabytes up to 1 gigabyte. It really doesn't need any more RAM memory. I'm just going to leave it on 1 gigabyte of RAM, and I'm going to proceed with the next step. This is the part that differs from Kali Linux installation. Instead of going with create a virtual hard disk now, we want to select use an existing virtual hard disk. And under that, we want to go to this icon right here, and we want to click on Add. Once we do that, we want to navigate to where our folder is with extracted files from our zip file that we downloaded. double click there, and you will have all of these options. Now, the file that we want to choose right here is going to be OWASP Broken Web Apps CL1 without any extension as these ones have. So we want to select this one, and you will notice that its size is also the smallest. Let's select it. Let's double click it again, and let's click on create. Before starting this machine, I just want to mention a few things. If we go to settings and we go to network settings, we also want to change from NAT to bridged adapter, the same thing that we did with our Kali Linux machine. But with this machine, we need to be a little bit cautious because this is a vulnerable machine. It hosts a web page with a bunch of vulnerabilities. So only use bridged adapter if you're running this machine in a safe home network. If you're running it in your own network, then feel free to use bridged adapter. Don't use bridged adapter in a company network or in a public network or anywhere else that there might be untrusted devices, even though it's a virtual machine. But nonetheless, it's always good to have maximum security as possible. So select bridged adapter. Under name, select the adapter that you want and click on OK. And that's pretty much it. All we have to do right now is start the machine, and it will start the process of installing all the things that it needs, and that pretty much takes a couple of minutes, not too long. So let's just wait for that. And here it is. After 2 or 3 minutes, the machine is ready to use. Now, you might notice that it doesn't have any display whatsoever. Instead, we get this command line interface that we can use. And it's made like this so that machine can take as little space as possible and it can be made as fast as possible. Of course, in order for us to actually be able to access this command line, we need to log in first. And it tells us down here that we can log in with username root and password OWASP BWA. So let's type that in. And it will give us something like a terminal. And we can use that terminal to run the commands, the same commands that we can run in a regular Linux terminal, such as ls, whoami, and a bunch of other commands. We can also ping other devices. And it also gives us our IP address right here, which in my case is 192.168.1.4. And this is another reason that we set it to bridged adapter. It gave me an IP address that I can visit from any network device that I have connected to my network. So I'm just going to go from my host machine and type in 192.168.1.4. Now, in your case, this will probably be a different IP address, so you can either check it right here, or you can also type the command ifconfig, which will also give you an IP address of OWASP BWA. So let me navigate to the IP address of this virtual machine inside of my host machine's browser. And this is the page that it should open up. Here we have many things from training applications to realistic intentionally vulnerable applications. We also have some old vulnerable versions of real applications. And we have applications for testing tools as well as some other things as well. Now, there are a lot of things here. We're not going to cover all of them, but we're going to cover some that are aimed at discovering most common website vulnerabilities. Now that we got it set up, let's also make sure that we can communicate with this OWASP BWA machine from our Kali Linux machine. So start both of them. We already have our OWASP started. Let's also start our Kali Linux machine and wait for it to boot up. So here is our login screen. Let's log in. And to be able to check whether we can communicate with our OWASP machine, what we can do is we can simply just open our terminal. And by the way, once again, if you're not familiar with terminal, make sure that you check out bonus section on Linux Basics. There we teach the basic commands of Linux terminal so you can get familiar with it, and it hopefully will become your second nature. In Kali Linux, to open terminal, we use this icon. It will open up this command line where we can type our commands, and in our case, we want to ping 192.168.1.4. And once again, this is in my case. In your case, it might be a different IP address. So I'm just going to press enter. And if you get an output like this, that means that we successfully pinged this machine. So the connection part is good. They can communicate between each other. And in order to close off this command, you can type Ctrl+C simply, and it will finish with pinging. Okay, awesome. Now that we set this up, the next thing and the last thing that we want to do in setting up our environment is we want to just create an account on TryHackMe website. So that will be a rather short video. We've finished most of our work, and let's create the TryHackMe account in the next video. See you there. Okay, last thing for setting up our environment is creating the TryHackMe account. As I already mentioned, on this website we have a couple of free practice examples that we can use to elevate our skills and to learn even more about website vulnerabilities. But for the start, we only want to create an account, and later on we will use it throughout the course. For now on, let's just create it. So this will be a rather short video. All you want to do is you want to navigate to tryhackme.com. It will open up this page where you want to go on Join Now. Since you don't have an account, you want to set it up right here. So it requires an username, email, password, experience level, and to select that you're not a robot, hopefully. Now, make sure that you use a valid email because it will ask you for verification after creating an account. Once you do that, you can log into your account, and I will do that right now. And once you log in, you should have something like this. Now, after you verify your email, you can go and browse to learn, to compete, and you can check out all of the modules that this website has. So we can go under the modules, which we went to by going on Learn, and we have some Linux fundamentals, networking fundamentals, web hacking fundamentals, which is the module that we are interested in for this course, but you also have some other modules that might interest you after. For now on, we're mostly focused on web hacking, so you want to go to that module, and here we have a couple of free exercises. Now these are the exercises that we're going to touch inside of the course. This is what the platform offers us for free, and we're only going to use what the platform offers us for free, and later on if you decide that you like this platform, you can upgrade to premium, but for this course it will not be needed. Under the dashboard, you have some other things such as how many users there are, what rank you have, and rank is simply just based on how many points you get by solving different challenges in different rooms, and room is something that other people create to make practice examples on hosted vulnerable machines. Once you solve them, you get points. Once you get points, you become a higher rank. So this is just the basic things about the platform. For now on, it's just important that you have an account, and later on we're going to join a room and start exploring different vulnerabilities that different rooms offer us. If you created everything successfully, we are fully done with setting up our environment, and in the next section we can start off with website enumeration and information gathering. See you there. Okay, just a quick break. We have finished creating our environment, and we are now ready to start getting into all the website hacking and bug hunting. But there are a couple of prerequisites that you might need to do first in case you're a complete beginner, and now is the best time to do them. However, if you do feel confident knowing the basics of these things, feel free to continue with the next section where we start website enumeration and information gathering. And after that, we dive straight into website penetration testing and bug hunting. However, as I mentioned, we need to be aware of bonus requirements first, and lectures about them will be inside the bonus sections, which are some very basic website development or website structure knowledge. We must know what HTML is, what JavaScript is, and other languages used in web development. We must know what they are for and how we can recognize them. Besides that, we must also be familiar with Linux a little bit. We must know the basic commands of Linux terminal and get familiarized with Linux structure itself. And the last thing is that we must know networking a little bit as well. Nothing too advanced, but we must know some basic things regarding IP addresses, local networks, DNS, HTTP, and so on and so on. All three of these topics we have in the course added as bonus sections. The web development videos and the Linux videos are in video format, while networking theory we offer in PDF format available to download. After you learn and get all three of them done, and you feel comfortable with them, then we can proceed to website penetration testing lectures. Okay, awesome. Just wanted to mention this, and nonetheless, we continue our journey in the next section where we will learn how to enumerate websites and gather as much information about them as we can. Website enumeration. What is it and why do we do it? And also, why is this something that we should do before attacking the website? Well, it's quite simple. We want to learn as much as we can about our target before we perform any type of the attack. We want to know what we are dealing with and what is the structure behind the website that might look simple on first glance. Does it have forms that we can attack? Where is it located? What is the website used for? Basically, any information about the website could be useful for us. Imagine it like this. We, as penetration testers, have been given a task to test for vulnerabilities on some website. And usually for us to be able to discover any vulnerabilities on the website or any bugs, we must directly interact with it. Which simply just means we must open it up and experiment with different things that the website has. Usually, first thing that we want to do is discover the IP address of that website or domain. We can do that by using tools like DNS Lookup or Host, which we will take a look at later, but this is very simple to do. We just throw the domain name inside the tool, and it will give us its IP address. Keep in mind that some bigger websites could have multiple IP addresses due to them being located and hosted on multiple servers. For example, Facebook, being a big website, has ranges of IP addresses. With an IP address, what we can do is we can, for example, locate the website physical location. We can throw that IP address in a scanner and discover some technical information about the server hosting that website, such as, for example, discovering open ports and services running on those open ports. And after we do that, we can, for example, look at the website structure. What is it made of? Does it have JavaScript? Does it have some third applications that it's running that could potentially be vulnerable? All of that we want to know. We also want to know if perhaps the website has some login pages. Does it have a registration form where users sign up? Maybe we can try and find an administrator login page somewhere which shouldn't be accessible to regular users like us. Does it maybe have any other input fields outside of the registration forms? Why are we looking for user input fields? Wherever website allows us to input something or to type something in, that is the place where we want to interact with it and perhaps make it run something that it shouldn't be running. An example of user input field would be, let's say, a website that has movies on it. And you have the search field where you type in a movie name, and that search field is user input field. And we would definitely be interested in checking it out and to see whether we can do something else besides searching for a movie. We also want to figure out where is that website hosted, on what type of server, what operating system is that machine running that's hosting the website. Does the server have some other ports open besides the ports that are used to host the website? Another possible thing that the website does, especially if it has some registration form or login form, is that it interacts with the database. It probably has a database that's storing all the user's information such as usernames, passwords, emails, phone numbers, and so on. So maybe we can get that database to respond to us with the information that it shouldn't give us, such as, for example, other users' passwords. You never know. All of these things is something that we want to check. We also want to see if the website has good encryption. Maybe it has a weak encryption or no encryption at all, and someone with an attack like man in the middle could capture in plain text passwords that are going through that website. Okay, I just gave you some examples as to why we want to learn as much as we can about our target website. Now, to do this, we can use different tools. Some of the tools that we will use are Nmap, Nikto, Burp. We will also be visiting websites regularly over our browser. And we will also cover possibly the most important tool for bug bounty hunters, which is Burp. Anyway, let's not get lost in too much information straight away. And let's start off with our website enumeration, one task at a time. See you in the next video. Okay, it's time we start our website enumeration. And the very first thing that we should do is to take a look at the website through our browser. So we want to see what pages it has. What does it open when we visit its IP address? This is very basic stuff that we want to check first. So to do that, we can go to our Firefox and make sure that you have your OWASP BWA machine started, and once you have it started, then we can visit the IP address of OWASP BWA. In my case, that is 192.168.1.4. We already showed how we can check out the IP address of this virtual machine, so once you do that, type in the IP address in your Firefox and it should visit this page. So this is the first thing that we take a look at. We already noticed that we have a bunch of links right here, so this page has a bunch of other pages that could be hosting different services, that could be offering different things, and that could potentially have multiple login forms or something similar. So for example, let's pick any one of these. Let's go to this one under the realistic intentionally vulnerable applications. If we click on it, and let me just enlarge this a little bit so you can see everything better. Well, we visit some type of an application, some type of a page that our OWASP BWA has. And the first thing that catches my eye is something like this. We have a search button. And we also have a login button. What does this mean? Well, it means that this could potentially lead us to some type of a brute force attack where we will try to gain access to a certain account on this page. Perhaps they have weak passwords and we can log in if we brute force the account. You never really know. We can also create an account. So this page is already looking interesting to us. We also have some type of a file that we can send. Currently no file is selected, but we can see right here that we have some input as well, and then we have a button to send files. All of these things we would want to play around and see what we can do with them. Let's take a look at another page as well. So if we go back, and let's for example go to this one, we straight away get a login form. So this also tells us that there could be a potential brute force attack or weak credentials attack here as well, since it does offer us a username and password field. Let's go back, since we don't really know any username and password here. We don't really know what this is. It could be some administrator page. It basically could be anything whatsoever. We can also do something like this. For example, go back and let's say we want to try to find some secret administrator page. We can try something like /admin. And in this case, we don't really get anything. It says /admin is not found, but it was worth to try it out. Now, let's check this out on a real website, since this is specifically made vulnerable. So we already know that we will find vulnerabilities in OWASP, but let's go and, for example, search for tesla.com. So this is an official website, it is registered, and if we visit it, so we get some prompt right here that asks us to select our region. Let's just click X right here. And what we would usually be looking for is, once again, we would try to find some type of a login form or some type of a search field or any part of web application where we can interact with. So we already see right here something like a Tesla account. And it does ask us to log in. So we do have some type of a login form. Now, login forms are not the only thing that we are looking for, but for now on, it's the first thing that catches our eye. Now, for real websites, we can also perform some advanced search using Google. This is also called Google dorking. It's using Google advanced search techniques to discover information that we might find useful. For example, let's go to Google and let's go with Tesla first. So let's type in site and then 2 dots, tesla.com. And let's say we want to find all the PDF files from this website right here. We would type site 2 dots, tesla.com and then file type 2 dots, PDF. If I press enter, it will give us all the results of PDF files that this page has. And we can see that these indeed are PDF files. It says right here, as we can see. And perhaps we could find something useful in these PDF files. You never know. Maybe there is some PDF file that has information disclosure and perhaps it gives us some information that we find useful. We can also try to find some emails from this website. How do we do that? Well, we can do something like this. We could open double quotes at tesla.com and then we could dash site and then 2 dots tesla.com. Press enter. And let's see. Right now we do not manage to find something interesting for Tesla. And here is one email we did manage to find, but that's just one email. It still could be useful for us, but we're looking for a little bit more. So we can instead try to go with some university websites since they usually have a bunch of emails. Let's go with this one. I'm going to use a university from my country and it's located at this website. And we're going to use the same command, so at and then the addition to the email and then the site, which is the same link or same domain. I will press enter right now. And here is one email address that could also be useful. Now we can also visit these links and try to find even more, but let's just see what we can gather from here. Here's another email address. And here appears to be a start of a phone number, so we also get that. Here's another email address right here. And that would pretty much be it from the first page. Now we can, as I said, visit these links and then we can find even more email addresses, hopefully. And here's another one that we missed from the first link. Okay. Now, we tried to go to /admin before on our OWASP VM by adding /admin in front of the link or in front of the IP address. But for regular websites, there is something even better that we can try using Google. We can use Google Docs to try and find something like admin pages, but we can do that by searching admin keyword inside the title of the page or inside the URL. To do that, we simply type in title 2 dots admin or in URL 2 dots as well admin, and then we specify which site. And let's use this same website, this university website. So this is the command, and let's press enter. Then we get some responses right here. If you go to any one of them, secure connection failed. And the error that it gives us is SSL error unsupported version. This website might not support the TLS 1.2 protocol, which is the minimum version supported by Firefox. Enabling TLS 1 and TLS 1.1 might allow this connection to succeed. So let's give it a try if we enable it. And we do manage to succeed. And you can see that this link has addition to it that has admin keyword, and that is why we managed to find it. We also have a couple of input fields right here. So here we enter email address and password. And here we also enter our email address. And this is just one of the pages. Maybe there are multiple pages that have admin keyword inside of it, and that could be useful for us. So for now, this seems to be some type of an admin form. And we do also get some email address right here. I do believe this is an email address. There's not much info about it, but nonetheless, we did get here successfully. These are usually the things that you would do first to start off with website enumeration. We just gather some information about it. We perhaps try to find some additional pages, such as this admin page. Now, the most important thing is that we must start somewhere. there is not a strict rule that says how you can perform your website penetration testing and in which order you do all of these things. That's why we're going to check out most common techniques, and it will be up to you to apply them as you like. As far as this lecture, which was on Google dorking and just inspecting website in general, you can take a look at some additional advanced Google commands that are useful for us hackers. So we can find them by, let's say, typing Google dorks, and let's go with the first link, which is exploit-db.com. Let's visit that. And once it opens this page, we will get a saying here that this is Google hacking database. And down here we have a bunch of Google dorks or Google commands that we can use to extract some useful information from a certain website. For example, it gives us the command right here. Under the category it says what does it search for. So in this case, it searches for files containing passwords and the author name right here. And you have a bunch of these commands. As we can see, these are only first 15 commands out of 6,000. So you can take a look at here, perhaps find some useful commands that you might apply to your penetration tests, and you might use them later on. However, you will always have this database right here at this link, so you can visit it anytime that you like. Okay, awesome. So we took a look at Google dorking or executing some advanced Google search commands. We also took a look at our website. We browsed a few pages here and there just to see what the website has. Now, in the next video, we're going to check out how we can use multiple ways to discover some more information about our websites, such as IP addresses, such as domain names, such as its physical address, perhaps some additional emails or phone numbers, and all of that. So thank you for watching, and I will see you in the next video. Welcome back. In this video, we want to check out how we can get an IP address from a certain website, as well as some additional information about it. So, since we can't really do this with our OWASP because this is a virtual machine that's hosting a website inside of our local network, so it doesn't really have a domain name, or should I say a link. We already have its IP address right here, so we're just going to take a look at how we can get an IP address from some random website online. To do that, let's first open up our terminal, and there are a couple commands that you will use a lot. First command, which we already performed in a previous lecture, is called ping. Now, ping command allows us to determine whether a host is online or offline. For example, if I type ping and then the IP address of my OWASP virtual machine and press enter, it will continue pinging the virtual machine, which we can determine that this machine is up and running. Now to stop this, let's press Ctrl+C, and besides using ping and then the IP address, we can also use ping with a website name. For example, we can type ping google.com and it will perform the same thing. And as we can see, we're also getting the response from google.com, and in the brackets, we're also getting an IP address. So with this command, we did manage to get an IP address of google.com. Now, one thing to take in is that this command, or the ping command, doesn't necessarily always tell us the truth. Some websites might block ping probes and we might not be able to ping them, however, they could still be online. And we're going to take a look at that later on, but just keep it in mind for now that if the pinging doesn't work, it doesn't necessarily mean that the website is offline. Okay. Now, another command that you can use to determine the IP address of a website is called host. If you type host, and let's right now use, for example, Tesla, so host tesla.com, it will tell us tesla.com has an address of 199.66.11 and then 62. It also gives us some additional information such as tesla.com mail is handled by this. Okay, so this is additional information, but we were mostly interested in this. Don't worry if you get a different IP address for these bigger websites, it's normal because they're not hosted only on one IP address. And the third way that we can determine is with the help of a command called nslookup. So if I type nslookup.com, It will give me a response of my server or my DNS server, or in this case my router, which is hosted at the IP address of 192.168.1.1. And the answer to our question will be down here. The name that we searched is tesla.com, and we got an IP address of 199.66.11 and then 62, which is the same IP address as we got right here. But besides getting an IP address, we can also extract some additional information that is publicly available. We can do that by using a tool called Whois. Now, Whois tool is used for gathering information about details of website registration that the owner of website provides. This usually provides us with some additional contacts, such as emails, phone numbers, and also some physical addresses. Let's give it a try. So let's type Whois tesla.com. Then we get a bunch of reply right here. We can already see that we're getting some phone numbers right here. If we scroll a little bit up, we're getting name servers, we're getting some postal code, street, city, basically the physical address, including some phone numbers as well. We get information about admin, so we can see the admin name, the organization, street, city, and phone number. Some other information as well, domain status. If we go up, okay, so here is even more information. We get name servers right here. I believe these are the same as the ones that we passed below. We get more phone numbers, some email address as well. So we do get some information right here about the website. Usually, these large outputs will be given for larger websites. For example, if you were to try Whois command on some not that known website, it probably wouldn't give as much information as we got right here. As always, besides of using command line tools, oops, what happened here? Let's clear the terminal. And besides using the command line tools that we will always use, you can also take a look at some website that will also give you information about a different website. That is also called passive information gathering. Why passive? Once we pinged our website and we used host and DNS lookup and Whois from our command line, we performed active information gathering because we pretty much interacted with the website the whole time. But once you do the same thing through a different website, it's called passive information gathering, because our target website won't be able to see who searched that information for them, because we never interacted with that website. We went through a third-party website that did all of that for us. So for example, we can type website's IP and find some website that will determine the IP of our target. Let's visit this first one, which is at link site24x7.com. And it pretty much does what it says. It finds an IP address. So if we were to type, for example, www.google.com, find IP, it would give us the IP address of www.google.com. And we can also get some other information if we go to DNS analysis right here. So we do get something right here. Here are the name servers. We got 4 of them, as we should get. We also get reverse lookup. So we can also perform DNS analysis right here and gather information from this third-party website as well. Okay, awesome. But these are all basic things. So we're pretty much just getting the IP address of the website. For now on, we also performed some Google dorking in order to find some useful information that we might need. We did perform Whois command that gave us some additional information such as phone numbers, email addresses, and physical location, but these are all basic stuff. We want to get to the technical side of a website. And in the next lecture, we're going to check out a tool called WhatWeb. That is the tool that you will also use a lot, and it's pretty useful in discovering technologies that are behind a website. Nonetheless, thank you for watching, and I will see you in the next lecture. Welcome back. In this video, we will cover a tool called WhatWeb. And as I mentioned in the previous lecture, we use WhatWeb to determine which technologies does a website have. So it's still information gathering, but from a technical aspect. And WhatWeb is a tool that we already have pre-installed in Kali Linux, and we can run it with the help of a terminal. So let's do it straight away, As usual, make sure that your OWASP virtual machine is running, and all we need to do to run the WhatWeb tool is to type WhatWeb, and then the IP address of the target that we want to scan. In my case, this is 192.168.1.4, which is the IP address of my OWASP virtual machine. If I press Enter, since this machine is in my local network, it will take just a few seconds for this command to finish, and we do get some information here. As we can see, this is the link that WhatWeb tool tried to visit. It got 200 OK code, which means it successfully loaded the page. It discovered the Apache version, which is 2.2.14. If we go right here, we got country, we got email addresses, so it does manage to even get some email addresses out of this page. The HTTP server appears to be running Ubuntu Linux. We get the Apache version once again, and we get the IP address, the jQuery version, the OpenSSL version, the PHP version, and some other versions as well. As we can see, the target machine is running Python 2.6.5. So this allows us to discover technologies behind a certain website. And what could be our next step is to take perhaps Apache version, Google this version and see whether it has any known vulnerabilities that exist. Now, this is just a regular command with WhatWeb. What we can do to discover what else we can do with WhatWeb, we can run this command, which is whatweb --help. Once you type it in, it will give you all of the possible things that you can do with this tool. So we have a bunch of other options that we can use, such as input file, URL prefix. We got the aggression mode, so the aggression level controls the trade-off between speed and stealth and reliability. There are 3 aggression modes: the stealthy, aggressive, and heavy. Now, you can go through this menu if you'd like. This is just a short help menu of the tool. But if you want to know even more about the tool, you can use a command called man, which is shortened for manual. If you type man and then the tool name, it will open the manual for WhatWeb. And under the description, we can see WhatWeb identifies websites. Its goal is to answer the question, what is that website? WhatWeb recognizes web technologies, including content management systems, blogging platforms, statistic analytic packages, JavaScript libraries, and many other things. In the second paragraph, we also got some explanation on the aggression level, or on the aggression option that we saw from the help menu. So as it says, WhatWeb can be stealthy and fast, or thorough but slow. WhatWeb supports an aggression level to control the trade-off between speed and reliability. When you visit a website in your browser, the transaction includes many hints of what web technologies are powering that website. And that's exactly what WhatWeb does. It enumerates those technologies and it outputs them back to us. Sometimes a single web page visit contains enough information to identify a website, but when it does not, WhatWeb can interrogate the website further. And that is where the other aggression levels come. The default level of aggression, called passive, is the fastest and requires only one HTTP request of a website. This is suitable for scanning public websites. Now, this part right here is important. We can use the default aggression level to scan public websites if we'd like. But if we want to use more aggressive levels, as it says right here, more aggressive modes were developed for in-penetration tests. So you should not use the aggressive modes on a website that you do not have permission to scan. Okay, awesome. So let's take a look at what else can we run with WhatWeb. So let's go back to the help menu. And we do get some examples of usage right here, but what we want to do, as it interests us the most at the moment, is let's try to use aggression level 3. For example, since we used 1 before, which was default, let's increase it a little bit and let's move the aggression level to 3. Then we can also type -v, which stands for verbose, which means it will output even more things. And at the end, let's add the IP address. Oops, we misspelled aggression, so let's add another S and let's let it to run. Okay, the output came once again relatively fast because the target is in my local network, so let's see what else do we have. Straight away we notice much more output than once we ran the command previously, and we got it ordered by detected plugins. So we can see the detected plugins. We got Apache first, then comes the description of Apache, we got the version right here, and we got the website of Apache as well. So we do get some more information about each of the discovered plugins. Up here we get pretty much the information that we already got from the first scan. And down here we can read more about every plugin that it managed to find, including email addresses, HTML version, jQuery, OpenSSL, PHP, and all of that. And in case there is a plugin that you do not recognize, you can read through the description and figure out what it is used for. Besides of using WhatWeb on only one IP address, you can also use WhatWeb on multiple IP addresses if you'd like. You can type the same command and, for example, let's say you have multiple websites in your local network that you want to scan with one command. You can do so by typing your network range, which in my case is this one, and then it will perform scanning of all of the IP addresses inside of your network. And you can notice that I'm getting a lot of errors right here. These are all the IP addresses that are not hosting any website. As you can see, it tries to visit this IP address over HTTP, but it can't find the route to the host. Therefore, it throws us an error. Now, just so you don't have to see all of these errors, what you can do is you can run the same command and add at the end --no -errors. This will remove all of these errors so it doesn't get printed out to us. It just simply gives a better output. And here you will get response for every device on your network that has a website hosted. In my case, that should only be our OWASP virtual machine as well as perhaps my router. Let me see, we got the IP address of 192.168.1.4. And down here we got my router's IP address, which is 192.168.1.1. Now, of course, with the IP range, let me just go down here, clear the screen. Your IP range might be a completely different one. It doesn't have to be the same one that I have. So make sure that you check that out first, and then you can run this command with your IP range. Okay, awesome. And this is what we use the WhatWeb tool for. It helped us discover different plugins that a website has. Now, WhatWeb can be considered one of the tools that are used for advanced website enumeration because it does give us a lot of information back. However, we are slowly getting closer to ending website enumeration. There are a couple more tools that we want to discuss. Of course, you do not have to use all of these tools. We're just showing different options that you can use. And besides all of the tools that we will cover, there are also a bunch of other tools that you might find useful, so feel free to use any one of them that you like. Now, in the next video, we're going to check out a tool called Burp. So thank you for watching, and I will see you in the next lecture. Okay, time to cover another tool used for website enumeration, which is called Burp. Now, this will be a rather quick video because this tool is not that big, but it is really useful. We use Burp to discover hidden directories on a website. Or you can also consider it as a tool that is used to brute force directory names and see whether certain directory names exist on a website or if they don't. Now, as with almost any other tool that we use, we can run Burp straight from our terminal. And to open the help menu, we can just type Burp, which will give us all of the available options that we can use with this tool. But since website enumeration is not our main part of the course, we really want to get straight into bug hunting. We'll just cover the basic of this tool, which you probably will always use like this. However, if you do want, check out all of the other options to see what else you can do with the Burp tool. But for this video, what we want to do is we want to discover some hidden directories. And to do that, all we have to type is Burp and then HTTP and then the IP address of our OWASP virtual machine. If we type it like this and press enter, it will start running without specifying any other option whatsoever. And you can see all of these output that we get are discover directories on the website. Right here we can see how many generated words did Burp create, and all of these words will be tested out as a possible directory on this website. Straight away we managed to find some of them. As we can see, we have /assets on the website, we have CGI bin, we have cross domain, and if you're wondering what is this in the brackets, this simply just gives us the code, and as we already know, code 200 means that the page loaded successfully, which also means that the page exists on that website. If it were to get some other code resulting in an error, then the tool would probably determine that that page does not exist, so it doesn't print it out right here. Okay, so if we go all the way down, we can see that it already discovered a bunch of other directories, and what you would do is you would pretty much go through this and see whether you see anything interesting for us. For example, any administrator directory could possibly be interesting. Of course, if you find something that has passwords inside of its name, that would also be interesting because you never know what the website developer put there. Maybe they forgot to remove a certain directory from the test phase and they left it right there, which could possibly have perhaps the source code or some additional information such as users, or perhaps they made the entire database public. I mean, you never know. Even though it is rare, it can and it does happen sometimes. So nonetheless, let's see to which point did this tool get. And it's still discovering directories, so I'm just going to stop this because I don't really need it to finish till the end. Instead, I also want to show you another option that you can do with derp, since if you type a straight command like this, which is just derp and then the IP address over HTTP, it will use its usual list that it always uses. But what you can do is you can specify your own list right after the IP address, so you can do something like user share word lists. And this is the path to word lists in Kali Linux. So it's /user /share and then /word lists. And if you want to see all of the options that you have inside of this word list directory, you can press tab twice fast. And here you will be able to see all of these subdirectories to this word list directory. And since we are running derp, let's go to the derp subdirectory. And inside of the derp subdirectory, we have all of these txt files, and all of these txt files are certain lists. Let's go with common.txt, which I do believe is also ran by default, but nonetheless, let us just see how we can use a specified word list of our choice, and all you have to do is press enter. And it will pretty much do the same thing, just with your word list instead. It will try to find all of those directories and it will print out the ones that exist. And if you wanted to, for example, make sure that a certain directory exists, what you can do is you can copy any of these directories. For example, let's go with this one, which is /images. You can go to your Firefox and visit it like this. And we do see that images directory does exist on our OWASP virtual machine. You can do so with any other as well, such as, for example, phpMyAdmin. Let's copy the link and let's paste it right here. And it also loads the phpMyAdmin login screen. Awesome. All we're left to do is cover two more important tools. In the next video, we will cover Nmap, which will pretty much be just the basics of Nmap because that is a huge tool. It has a bunch of options and we're not getting into details with Nmap. However, we will cover some of the basics of it in the next video, and then in the next section we're going to dive deep into a tool called Burpsuit. Now, why are we going through all of these previous tools with only basic options, and with Burpsuit we're going to go with advanced options? Well, it's pretty simple. Burpsuit is a tool that you will use for bug bounty. Its main purpose is to actually use it for bug bounty. While as all of these tools that we covered by now, you can use if you like, but you don't really have to. It's pretty much your choice. Nonetheless, more about Burpsuit in the next section, and let's focus now on Nmap, which we will cover in the next video. See you there. Okay, big tool is ahead of us. It's time we cover Nmap. Now, what is Nmap? Well, Nmap is shortened for Network Mapper, and it's a tool used to pretty much map the network or discover open ports on the target system that you're scanning. With those open ports, we can also discover which services are running on those open ports, and Nmap can go as deep as discovering which version of a service is running on which open port on the target system. Now, Nmap does have some other options as well, but as we did mention in the previous video, we're here to only discuss the basics of Nmap, and if you'd like to dive deeper into Nmap, you can take a look at our Nmap cheat sheet, or you can also learn it from the Nmap manual. We already know how to open the manual. You just type man and then the tool name, and it will open the manual for that tool. However, we are not going to read it right now. We're more interested in running the help menu of Nmap, and this will be a shorter version of what are the possibilities with this tool. As we can see, there are a lot of options that we can run. If you'd like, read through them and see what are the possibilities, but right now we're going to perform the very basic scan with Nmap just to see what output do we get and what does this tool do for us. The very basic scan would be typing the Nmap and then the IP address of our target. And as we can see, it finished in less than a second, and this is the output that we get. We scanned our OWASP virtual machine, and the only output that we get is which ports does our machine have open. And there are quite a few of them. So we have the 22 port open, which is running the service of SSH. We got our website hosted on port 80, since it's running HTTP over there. And as well, we got our website on port 443, which is running HTTPS. But we do also get some other ports open that are running different services, and that is also why Nmap is useful. Perhaps sometimes once you're scanning a website, you will discover other ports that are hosting other services, even though the website might not have bugs itself. Maybe the machine hosting the website has other services that are vulnerable to a different attack. But that is out of the aspect of this course. However, you can use Nmap to determine that, and you will use Nmap a lot if you perform penetration testing. So this very basic scan gave us the output of all of the open ports on Nmap, and it also gave us that it found 991 closed ports. Now, why is that? Well, Nmap by default scans most known 1000 ports, and out of those 1000 ports, 991 were closed, while as these 9 ports are found to be opened. If you want to dive even deeper into these open ports, and perhaps you want to discover a version of a service that is running on this open port, you can run this command, nmap-sv, and then the IP address of your target. In our case, I'm using again OWASP BWA, and if I run it, it will take longer to finish than this scan. However, it should also take about a few seconds. Let's wait for it to finish. And this is the output that we get right now. You will notice that it's quite larger than the previous one, since besides getting the same output, which is which ports are open, we also get this column right here that says version. It gave us the version of each service that it is found on open port. For example, if we take a look at SSH running on port 22, we get the exact SSH version that this target machine has, as well as we get the exact Apache version that is being hosted on port 80 for HTTP. And we do see that it does match with the output that we got, if you remember, from our WhatWeb tool. Remember that we got Apache 2.2.14? Well, Nmap gave us the same result, so we can pretty much determine that this is the correct output and that the target machine is indeed running Apache 2.2.14. We also get the versions for other ports as well. So this is pretty useful information. And we can also see that apparently HTTP is being served on these ports as well. So it's not only port 80. We also have HTTP running on port 8080, which is running Apache Tomcat. And we got HTTP being served on port 8081, which is running Jetty. Now, this is something that we didn't know before. And now if we go, for example, to our Firefox and we try to visit our OWASP virtual machine on port 8081. So let's type it right here, 8081. Wow, so we do open another web page. This is a web page that we didn't see before. Since by default every browser opens a page on port 80, since that is the usual HTTP port, if we wanted to, for example, open a web page on a different port, we need to manually type it like this. And we do open another web page. Awesome. Let's see what else do we get. So pretty much that would be about it, all of this services version. And another thing that I want to show you that is possible with Nmap is to use something called scripts. Now, Nmap can also try to find vulnerabilities. It can be used as a vulnerability scanner. How can we do that? Well, we can type something like this, nmap --script, then we type vuln, and then the IP address of our target. Now, this will take a little bit longer to finish because it does perform all the scripts that are used for discovering vulnerabilities. And while this is running, let me show you this website called nmap.org, where you can pretty much read anything about Nmap that you like. You can go to this page and you can also find the manual here, read all of the available options with Nmap, read what it is used for in case you're interested in this. Awesome. Let's see if our scan is finishing. We did get some output right here. And by the way, you can check out the percentage of your scan by typing upper arrow, and it will tell you at what percentage is it at. So let's wait for it to finish. Okay, and this did last much longer than I thought. It took quite a few minutes, but it's finally over. And here is all the output that we get. If we scroll all the way up, let's start from the beginning. It's going to run the scripts per port. So it determines first which ports are open. Then for each port, it runs all of the scripts that are used for discovering vulnerabilities. As we can see, for HTTP port 80, it ran first the script HTTP cross domain policy. Down here, it tells us that the state is vulnerable, so perhaps we found our first vulnerability. Keep in mind that sometimes Nmap does know to give false positives, and I will show in just a second why. Let's go all the way down. We got CSRF script running right here. It tells us found the following possible CSRF vulnerabilities. So this is not really 100%, it just says that it could be possible on these links. And by the way, if you don't know what these vulnerabilities are, CSRF, XSS, don't worry, those are all the bugs that we will cover once we get to the bug bounty, and trust me, we're getting there quick. Nonetheless, let's just go through this. Here is the HTTP DOM-based XSS, and let's see right here. Found the following indications of potential DOM-based XSS. That's interesting. On this page, let's go down here. We got the SQL injection script running. It found the possible SQL injection queries on these links right here. So this is all the links that we would want to test in a real penetration testing attack. Down here we got HTTP stored XSS script, and here it says couldn't find any stored vulnerabilities. And that is false. I assure you that on the page or on OWASP, we will get certain pages that do have HTTP stored XSS. So you can never fully trust what you get from a certain tool. That's why we will be discovering all of our bugs manually and not with tools. So you can scroll all the way down and check out all the other scripts that Nmap ran and what are the results. Or if you don't want to run these type of scans, which you use every single script to discover vulnerabilities, you can, for example, copy a script name, which you can also find in the nmap.org website. You can find all of the scripts that the Nmap has, and you can run a single script by typing nmap --script, then the script name, and then your target IP address. And it will only run this one script. In case you're trying to target just one vulnerability, you can simply just run just one script that discovers that vulnerability and see what the Nmap will tell you. Once again, if I'm not mistaken, this HTTP stored XSS will give us the result that there is no such thing on the OWASP virtual machine. However, we will see later that stored XSS does indeed exist on our OWASP virtual machine. And here is the response. So this is what we get: open ports, and on the HTTP ports, because XSS is a website vulnerability, it tells us that it couldn't find any stored XSS vulnerabilities on both HTTP and HTTPS. Okay, nonetheless, these are some of the basics of Nmap and how you can use Nmap. Now, I strongly recommend that you dive deeper into this tool, and we will be leaving some resources for you to take a look at in order to learn Nmap, since it can be useful not only for website penetration testing, but for penetration testing and ethical hacking in general. This is one of the most important tools that hackers use. Nonetheless, as I mentioned, you will have resources where you can learn more about this tool, and in the next video, right before we get into Burp, there is one more tool that we need to cover, which is called Nikto. See you in the next video. Alright, last tool before we get into Burp and bug hunting. So, Nikto. What is it? Nikto is a tool that performs comprehensive tests against web servers. It searches for server misconfigurations, it checks for outdated versions of servers, it scans for dangerous files and programs on a web page. It has many useful features that we can read at this page. This is a page on Kali.org website, and it has a Nikto tool description. Under here, we have its features, so we can read through them. It has SSL support, full HTTP proxy support, checks for outdated server components, which we already mentioned. You also have the option to save your reports in different file types. We can go all the way down, identifies installed softwares via headers and files, host authentication with basic and NTLM, subdomain guessing, so it pretty much performs website enumeration and vulnerability assessment all together. However, the most important thing that it gives us is which softwares are outdated. Okay, but we want to see the basic use of it, and if you find this tool useful, feel free to check out all of the other options that you can use with the combination of your scans. And for us, to run the tool help menu, we can open the terminal and we can type Nikto. This will open a small help menu for us, and here we can see some of the options that we can use with this tool. However, for our basic scan, the most important option for us, and the one that we must specify, is the -host option. As we can see, its description says that -host specifies target host or URL. So let's scan our OWASP virtual machine. We're going to type Nikto -host and then the IP address of your OWASP machine. In my case right now it's 192.168.1.5. If you press enter, it will start the Nikto scan. And Nikto tool is made to perform these scans fast, so they will usually not take more than a couple of minutes at max. So let's wait for this to finish, and then we're going to read through some of the information that we got right here. And it's done. It took around 30 seconds, and this is the output that we get. At the very beginning, we got some target information, as well as the server configuration. It tells us which versions is it using, and down here it describes each of those versions and what it managed to find that might be interesting for us. As we can see, let's go from here. The anti-clickjacking X-frame options header is not present. The XSS protection header is not defined, and it gives us a description why this might be useful. As it says, this header can hint to the user agent to protect against some forms of XSS. And XSS is once again the attack that we will cover later. Down here it tells us some of the versions that it is running, pretty much the same output that Nmap tool gave us. We got the Apache 2.2.14, and it tells us that this version appears to be outdated. Current is at least Apache 2.4.37. It tells us pretty much for any plugin that our OWASP has that it appears to be outdated. And what does an outdated mean to a penetration tester? Well, it means probably a bunch of vulnerabilities, because most of the time a certain plugin gets updated and gets a newer version because of a previous bug or a previous vulnerability. If we go all the way down, it tells us that the Python version that it's running appears to be outdated, the Perl version appears to be outdated, pretty much everything is outdated. We get the allowed HTTP methods, which is get, head, post, options, and trace, and down here, that would be pretty much it. It also gives us some output as to which directories might be interesting for us that Nikto managed to discover. For example, this phpMyAdmin is a directory that we already found, and it tells us that this might be interesting for us. Down here. Okay, awesome. And this would be a simple Nikto scan. It gave us some information, mostly that many plugins are outdated. And if you want to combine Nikto scan with other options that Nikto offers us, feel free to use them. These other options are there in order to make a scan more precise. For example, if we run Nikto menu once again, we can see, let's say this option port defines which port we are scanning. By default, it's set to port 80, which is a default HTTP port. But remember that our Nmap scan gave us a result that there is HTTP servers running also on port 8081. Well, we can scan that as well with Nikto. All we have to do is type nikto-host and then the IP address of our target. And we can also add the -port option and specify which port we want to scan. Once we press enter, it will target that port and it will print us the information about that port only. And here is the result. It's much less information than with our previous scan, but we do got some things here as well. For example, this is the same as in the previous scan. We got that Jetty version appears to be outdated. We also got which allowed HTTP methods does it have. And we got some interesting directories, for example, /admin, /css, /admin.indexhtml. It tells us that it found an admin login page on this directory. Okay, awesome. We are done with website enumeration. All we are left to do now is to set up our Burp suite tool, get introduced to its basics, and we are fully ready for discovering website vulnerabilities straight after that. See you in the next video. Okay, this section is important. Even though it will be a short one, you will find using Burp suite a lot. But before we get to setting it up, let's first briefly discuss what Burp suite is. Burp suite is a platform specifically designed for testing of web applications. It has many tools that make testing process much easier, and it's also used as a proxy. Not a proxy in a sense that it will hide your IP address, but proxy in a sense that it will allow us to inspect all the packets and HTTP requests and responses that we do while visiting a certain page. It will allow us to intercept different requests, modify them, and then forward them to the web page or to drop them if we choose to. Burp suite is considered #1 tool for bug bounty for many penetration testers. In this section, we're going to set it up and check out some basic options that it has, and the rest of it we will practice throughout the course. Let's first start off by configuring it as a proxy for our Firefox. So to do that, the first thing that we want to do is we want to open terminal and start our Burp suite, and we can do that by typing Burp suite inside of our terminal. Press enter, and in just a few seconds we will get the opening menu for this tool. And unlike many other tools that we used before, this tool has a graphic user interface, so it will be much easier to use and to navigate through. If you get this community edition warning, you can click here on OK, and in a few seconds we will get to open Burp suite. Okay, here is the opening window. You can leave this checked or unchecked, whatever you like, and click on I accept. Once this window opens up, And you might also get this window opened up, which says an update is available. You can update it now, but if you get it, just click on close for now. And here select temporary project, click on next, and use Burp defaults and click on start Burp. This will open our project in just a few seconds, and then we will be fully able to use BurpSuite. Now, one more thing to mention is that BurpSuite has a community edition and professional edition. A community edition is free, while professional edition is paid, and it does allow us some other additional options that we can use with this tool. However, for this course, we will be using the free community edition. Once it opens up, you will get a window that looks something like this. Let me enlarge it. And I know that there are many things happening right now, but don't worry, all of this is simple. First thing that we want to do in order to configure it with our Firefox as a proxy, we want to navigate right here on proxy. Make sure that this intercept is off by clicking on it. It will simply just say intercept is now off. Then navigate to the options and make sure that you have in this small window 127.0.0.1 on port 8080, and make sure that you also have it checked. If you don't have this option right here, just click on add and you can add it right here. Since I already have it, I'm not going to add anything, I'm just going to leave it as it is. And the next step that we want to do is start our Firefox. Once you start our Firefox, we want to navigate to Firefox settings. You can do that by going on these three lines, scroll a little bit down onto the preferences, click on that. And under the general settings, we want to scroll all the way down until we get to network settings right here. In the network settings, click on the settings button. And it will open the first setting, which is proxy configuration, which should by default be set to no proxy. We want to change it right now to manual proxy configuration, and in the manual proxy configuration under the HTTP proxy tab, we want to select 127.0.0.1 as an IP address on port 8080, the same settings that we have inside of our BurpSuite under the options tab. Once you set it right here, check this option as well that says also use this proxy for FTP and HTTPS, and it will autofill these two fields with the same settings. Once you have it looking like this, click on OK. And if you try to visit any HTTP page right now, for example, I will go to this page, just make sure that it is an HTTP page and not an HTTPS. And if it is an HTTP, it will successfully load the page. And you will notice that it also does do it a little bit slower because right now all of our connection is going through our BurpSuite, through our proxy. As we can see, here is the link right here. But if you tried to, for example, visit any HTTPS page, let's go to facebook.com, for example, it will give you this error, did not connect, potential security issue. Now, in order to fix this, we must download the Burp certificate and add it to our Firefox certificates. How can we do that? Open another tab, navigate to http://burp. Visit that link and it will open a window like this. On this window we have this button right here that says CA certificate. Click on that and save file. Click on OK. And it will download this file for us, which will be in our downloads directory. After we do that, we want to go back to our Firefox settings and we want to navigate to Privacy and Security tab. Once again, we want to scroll all the way down until we get to the option that says Certificates right here. Then click on View Certificates. And here we want to import the file that we just downloaded. How can we do that? Well, simply just click on Import, navigate to the Downloads directory and select the file that we just downloaded and click on it. Once it opens this window, check both of these options that says Trust this certificate to identify websites and trust this certificate to identify email users. Check both of them and click on OK. Then you can click on OK right here as well. And now we should be able to fully use our Firefox, and we have completed the Burp suite setup. Let's double check again on Facebook whether we can visit HTTPS page. And right now it loads it without any error. And we can also see if we go to the target tab in our Burp suite, we can see that we successfully loaded HTTPS facebook.com. And that's pretty much it. If you can load both HTTP and HTTPS pages after configuring Burp suite, then you are good to go. In the next couple of videos, we're going to check out some stuff that Burp suite allows us to do. Welcome back. We performed the setup of our Burp suite tool. Now, let's see what we can do with it. First thing that you will notice after the setup is that if you have Burp suite off, you will not be able to visit any website at all. Let me show you what I mean. For example, currently I don't have anything open, and if I go to my Firefox and try to visit a page like facebook.com, we get this error. The proxy server is refusing connections, and this is due to our Burp suite not being started at this very moment. Now, you can always remove Burp suite as proxy if you'd like by doing the same steps of going to proxy settings right here. Let me scroll all the way down to the network settings, and under the proxy settings, all you want to do to remove the Burp suite and make your Firefox run as usual is to select no proxy right here. However, right now, we do want to have it as a proxy. So let's just start our Burp suite by going to our terminal and typing Burp suite. Let's wait for a couple of seconds for it to start up. And while it's starting, let's also start our OWASP BWA virtual machine. Let's click on temporary project, use Burp defaults, and start Burp suite. Okay, so this is our Burp suite window. We already saw it from the previous video. And in this video, let's start off by checking that intercept option that we saw in the last video. So by default, once you open Burp suite, intercept, which we can find under the proxy tab, will automatically be on, as we can see right here. And this will always be navigated under the proxy tab and under the intercept tab. But what does this intercept option even mean? Well, it's simple. It will intercept every single HTTP request that we try to send, and it will block it right here. It won't forward it or drop it. It will ask us what we want to do with it instead. Let me show you how it looks like. For example, once we have intercept off, if we turn it off, we can normally visit a page like facebook.com. As you can see, it will load everything normally. There will be no problems. It might work a little bit slower because we're going through Burp suite, but nonetheless, it will load the page. But if we try to reload the page with intercept being on, let's turn it on, and let's click on this reload button. We intercept an HTTP request. And this is the request that we're trying to send. Here it is. We are performing a GET request on host facebook.com. This request didn't reach its destination yet, and we can confirm that by going to Firefox, and as we can see, our page is not loading. Instead, it seems as if it's still reloading, as we can see right here on our tab. That is because Burp suite is waiting for us to choose what we want to do with this request. And we do have some options right here. We can either forward the request, or we can drop it and not send it at all. But we also have this action button right here that gives us multiple options as to what we can do with this request, such as send to sequencer, send to intruder, send to repeater, and these options are something that we will talk about in the next video, but for now, let's see what happens once we forward this request. Let's press forward. Another request comes in. Why? Well, usually when you visit a website, you don't just perform one single request. It is multiple requests to multiple pages that, once they are sent, we get to load this Facebook page. In this case, our Facebook page does appear to be loaded. As we can see right here, it's no longer loading. But we must also forward all of the incoming requests as well. So let's do that real fast. Let's forward every single request that we get. And that should be about it. There were a lot of them, but now we can see no requests are being sent anymore. Now, you might have a couple of them coming every couple of seconds right here. As we can see, here's one that came a couple of seconds late. And this will depend on which page you're trying to load. So a couple of requests might come every couple of seconds. As we can see, even though we forwarded this one, another one might come in just a couple of seconds, and here it is. Now, another thing that we can do, for example, is to modify our request. Let's turn our intercept off for a second. Let's go to our Firefox and let's first check what is the IP address of our OWASP machine. It is 192.168.1.5 in my case. Let me visit it. And let's, for example, go right here to the DVWA. And if we turn our intercept on, and for example, we try to submit test username and test password, we intercept the request right here. We can see we are trying to perform a post request on this page because we are actually sending some data inside of a form, which in this case is username and password. And here we can see test and test to be the username and the password. Now, if we want, we can change this data. We can, for example, type test123 and we can forward our packet. Let's forward this one as well and this one. And if I go right here, it will tell us login failed. So that is incorrect password and also incorrect username. Now let me turn intercept off, and just so I can show you that changing of certain things in an HTTP request works, let me tell you that the username and password for this DVWA page is admin and admin. So once you type admin and admin, click on login, you will successfully log into this page. But let's try to turn on intercept, write incorrect username and incorrect password, which is once again test and test. And let's try to modify it right here to the correct username and correct password, just so we can see whether we managed to log in. So admin, admin, we forward the request, and let's forward other requests as well. And now you can see that we managed to log into this page. Awesome. This is the power of intercepting the requests. Now that we explored this option, in the next video we're going to take a look at some other possibilities with Burp Suite. See you there. Okay, we are aware of the intercept option inside of Burp Suite. But we did also notice that there are other things here such as intruder, repeater, and others. What are those options? Well, they all have their own purpose. Let's first start by checking out this target tab right here. So in this target tab will be all the websites that we visited while having Burp Suite as proxy in the current session. They will be listed in this left window right here. Let's give it a try. For example, if I go and visit tesla.com, let's first of all make sure that intercept is turned off so we don't get stuck on a certain request. Turn it off. Go back to the target tab. And here are all the links that we visited once we tried to visit tesla.com. In order for us to load tesla.com page, we had to send requests to all of these domains right here. And somewhere in here we should also see tesla.com. Let me check it out. Here it is. It's last in my case. And once you select it, or once you select any of these links or domains, in the window to the right, we will see all of the HTTP requests that we performed with that website. Let's, for example, take a look at this first request. So this is the first request that we performed. It's us trying to get www.tesla.com. And here are the HTTP headers of our HTTP GET request for this page. If we wanted to check out the HTTP response, we can take a look at this right window right here. So this is the response to our HTTP request. We can scroll all the way down and we will be able to see the HTML code of tesla.com page, which is this one right here. We can print it out like this. We can also take a look at the raw headers right here, as well as the HTML code. And we can also press the render option, and this will render the HTML code of that page, and we should be able to see the page right here in just a couple of seconds. And here it is. Now it doesn't look quite that good, as it does look right here, but nonetheless it tried to render it. Okay, now let's check out these actions right here, but let's check it out on our DVWA page. So let's visit our OWASP BWA machine. Let's navigate once again to this DVWA page. And once it loads, let us first log out just in case, because we did log in last time we used this application. And if we go to our targets tab, now we should see somewhere our OWASP virtual machine. And in my case, here it is. You should see just the IP address of your OWASP machine. And you can see once we have the render tab, it does render out the page for us. But let's go back to the pretty response, which will give us the HTTP response headers as well as the HTML code. Now let's try to find the request where we visit DVWA. And let's see it right here. I do believe it's this one. Let us check out. And if you don't want to scroll to all of these requests, what you can do is you can just turn on your intercept and specify once again incorrect username and password. And once it intercepts this request, you can click on action and let's go with repeater. Let's send to repeater. As soon as you click on that, you will see this repeater tab light up. It will become orange. So for now, we can turn off intercept, we can navigate to the repeater, and there we should be able to see our request. Here it is. Now, what you can do with the repeater is you can send a certain request as many times as you want. For example, I can try to send this request, and in the right window, we will get the response. Now, you might notice something weird right here. We're not getting the HTML code down here. So what does this mean? Well, if we take a look at this response a little bit better, we're going to see that we didn't get the code of 200, which means that the page loaded successfully. We got the code of 302. And once this happens, this usually means that you're about to get redirected to a certain page. In that case, we can click on this button, Follow Redirection, and it will redirect us to the page. As we can see, now we have the HTML code, and since we submitted the username and password of test, we get the login failed message, which is the same message that we have right here. We specified incorrect username and password. So we can also do the same thing that we did with intercept. We can also do it in repeater. We can change the incorrect username and password to the correct username and password. For example, let's go to the intercept turned on. Let's forward these packets. Or let me just do it like this. I'm going to type test and then test, turn on the intercept, and click on login. Now, let me go and find this specific request for the DVWA page, and here it is. Now, let's send it once again to the repeater. Turn off the intercept, go to the repeater, and here we will have once again this request. Now, you can change anything that you want in this request. For example, we can see the user agent tab right here that says Mozilla 5.0 and says the Linux version. It pretty much gives the information about us. And if you wanted to hide that information to the DVWA page and to our OWASP virtual machine, you can type, for example, that user agent is iPhone 7. For example, and leave it just like this, and this will get sent to the page. We can also change the correct details. Correct usernames and passwords to admin and admin. and then we can send this request. Remember that it will get redirected, so we must follow the redirection, and now we shouldn't get that login failed error. Instead, we should successfully log in to the page. And if we go to render, it should render out a logged in page. As we can see right here, down here it says username is admin, so we successfully logged in, as it says right here as well. You will also notice that the next request that we're about to send has the user agent of iPhone 7. So that is also something that we managed to change. How cool is that? Okay, this is repeater. It is similar option as to intercept, just here it saves our HTTP request. It allows us to modify it as we like and resend it as many times as we want. Then we can easily take a look at the response and render its HTML code right here. In the next video, we will be checking out the intruder option, which is also really useful. See you in the next lecture. Alright, let us take a look at another option that Burp gives us, which is intruder. Now, you can consider intruder as something made for brute force attacks. The definition behind it is that it allows us to change anything in the HTTP request and forward it, but it also allows us to change certain parts of HTTP requests by reading stuff from a list. Now, it might sound confusing, but let me show you what I mean. Make sure that intercept is turned off, make sure that you have the OWASP virtual machine started, and let's visit our DVWA login page. It will lead us to this page, and we should be able to find it under the target tab and right here. So here it is. As we can see, this is the GET request that searched for /dvwa/login.php, which is the exact link right here. Now, we can send this request straight from here to the intruder by right-clicking on it and clicking Send to Intruder. And as usual, you will see this intruder tab light up. It will become orange. Go to it, and this is pretty much all we get. Now, it might seem nothing at the beginning, but we do have 4 different tabs for this request. So once we switch to the Positions tab, here we can see our HTTP request. Now, you will see some of the things here already light up, and these are the things that we do want to change because they might be important for us, which in this case is correct since these are cookie values, and in some attacks we might want to change the cookie value. But let's go with a different HTTP request. Let's go with an HTTP request where we try to log in. So let's go test and test, which is incorrect login. We will get the login failed error, and now let's try to find that request right here. It will be a post request, so you can already filter it out since all of these other requests are GET request, and here is the only post request. And down here we can see that it does contain our username and password. So we can either go here on Actions and send it to Intruder, or we can just right click here and send it to Intruder. And once we visit the Intruder, we will have another tab opened up, and if we go to the Positions, here is our HTTP login request. Now, you will see that these options as well are now printed in green, because as I mentioned, Burp recognizes them as something that could be important for us. Now, what I usually like to do is I like to clear out all of these other options, and this will remove any green print that Burp gives by default. Now we have something called payload positions, and as you can see, there is this attack type option that we can choose from. If we click on this arrow, we will get 4 different attack types. Now, to read more about these attack types, what I advise you to do is click on this question mark, and this question mark will open up a page that gives you all the detailed information about these attack types as well as what you can do with the intruder. If we scroll all the way down, it also gives you the explanation for Add, Clear and Auto button, which are the buttons right here on the right side. And under the attack type, we can read about each and every attack type that we want. For example, the sniper attack type uses only a single set of payloads. it targets each payload position in turn and places each payload into that position in turn. Now, in other words, this simply means that with sniper attack type, we can only select one word right here that we want to change. For example, let's say that we want to brute force this account, but we do know username and we don't know password. We would select the password field and we will use the sniper attack in order to brute force the password field. You have some other options that you can use. Battering ram, this uses a single set of payloads. Now, you can read about all of these if you like. For example, cluster bomb is an option that you would use if you want to brute force both username and password, since, as it says right here, this uses multiple payload sets, which means you can select, for example, password and username. And then you can brute force both of them at the same time. Now, let me show you what I mean. For example, let's say that we do know the username, which is admin, but we don't know the password, and we just set it to be test. What we would want to do in order to get into this account is we would want to select this test and click on add. And you will see that it will become green. Once we do that, we told the burp suite that we're going to try to brute force this word right here. Then we can go to payloads. And under the payloads, in this window right here, we want to load our list. Now you can either add list by clicking on this load button and then navigating through your file system and trying to find a txt list that you want to use. Or you can add some random words right here, for example, test123, test1234, 12345, let's say root, and let's also add the correct password, just so we can show you that it does work. And let's go password and password 123. Now, let's say that this is our list that we want to use. Once we select it right here, we can click on this start attack. It will give us this error, which we want to click on OK, and it will start our attack. And what Intruder will do is it will send an HTTP request with changed password, and it will change password with these items that we specified in our list. It will go for each password and it will perform the request, and we can see that we got status 302, which, if you remember, it does redirect us after we send this request. But what you can do is you can, for example, select the incorrect password. Now in this case we do know what incorrect and what correct password is, so we can just select the incorrect one, and we can right click on it and click on request in browser, or we can also choose show response in browser. If we click on that, it will give us a link that we want to copy. We can copy that link, go right here and paste it. We get login failed printed a couple of times, and we do get correct login right here. Now this is a bug because we only requested one password, but it does give us that one of these 8 passwords from our list did work and we did manage to log in. Since we already know which one it is, let's go to this option, select the correct password, which is admin, and show response in browser, copy the link. We can close this for now and we can go to that link. And here it is. Once we selected the HTTP request where the password was admin, now it logs us in, because that was the correct password. How awesome is that? So we performed a small brute force attack right here. Now, this is not that practical, and we're going to talk about that more once we get to the brute forcing part of the course. For now on, we just took a look at a very simple brute force attack. Now, we're going to take a look at how we can deal with the problem once it redirects, because we don't really want to go and visit every single request for every single password just to see whether we managed to log in or no. We want another way that we can check out which password is correct much faster, right? Well, we will talk about that in the brute force part of the course. For now on, we checked out the option called Intruder, and there are many other options that Burp Suite allows us to use. However, we're going to check most of them out throughout the course. We just covered the basics of Burp Suite right now so we can get familiar with it. And if there is something that you didn't quite get or didn't quite understand, don't worry, we will practice it a lot throughout the course. For now on, it's just important that you do know how to navigate through Burp Suite, you do know what target tab is, you do know what proxy tab is, you do know how to intercept certain requests and how to remove the intercept. All of that is important. However, more advanced stuff we're going to cover throughout the course. Now we are fully ready, and in the next lecture, we're going to start off with our first vulnerability, which will be HTML injection. See you there. Finally, our first vulnerability, HTML injection. Now, I already showed you an example of this bug in one of the first videos of the course, and it's very easy to perform. That's why we're starting with it right now. This is first bug that we are going to cover. For all the bugs that we will cover in this course, we will be asking three main questions. What is it? How can we do it? And how do we fix it? These are important questions for us, especially how we can discover a certain bug. Now, luckily, HTML injection is not one of those critical vulnerabilities, however, it is considered a bug. And we are going to start off by explaining what exactly is it. So, what is it? To describe it in one sentence, we can say HTML injection is injecting HTML code into the website page. Simple as that. How exactly does it work? Well, here's an example. Let's say we have a very simple web page that performs only one task. It asks the client to enter their name inside of a user input field. Once the person enters their name, for example, let's say that they entered a name Tom, the application then outputs hello Tom. So we notice that this application reflects what we input to the page. We type something in, and the application processes that input and reflects it back in a sentence hello Tom. So code could look something like this. We have form, where we submit our name, and after the form it will output hello and then whatever we wrote inside of our input field. In our code example, our name is reflected here. But the key part of our code is Tom. That is what we have control of. So then comes the question, what would happen if instead of a regular name we submit an HTML code? In this case, a simple open header of size 1 tags and test written between header tags would be enough. What would happen to the HTML code on the web page if we injected this? What would it reflect then? Well, here is where we decide if the page is vulnerable to HTML injection or not. Our HTML code injected in the page would look something like this, once added to this code example. But the question is, how will the website process it? Is it going to process it as a regular string, or will it process it as an HTML code? If the website processes it as an HTML code and it outputs test written in header size 1, then we can conclude that the web page is vulnerable to HTML injection and that user input field isn't filtered well enough to block HTML tags and HTML code. Okay, this was an example in theory, but right now let's see how that would look like in practice. Hello and welcome back. In this video, we're going to take a look at our first example of HTML injection, but we're also going to take a look at how we can set up and deploy vulnerable virtual machines on our Try Hack Me platform. So first thing to make sure is that you have Burp Suite turned on, even though we won't need it for this lecture, but it's good practice to get used to using it and having it as a proxy every time you perform some website penetration testing. Then go and log in to your Try Hack Me account. And now we want to see how we can actually deploy their virtual machines and test them. So for this course, we're going to be using OWASP 10 Vulnerabilities Lab, which is free to use on this platform. It is located if you go on Learn, then you navigate to Web Hacking Fundamentals. And under the Web Hacking Fundamentals, if we scroll a little bit down, we're going to see OWASP Top 10, which is the room that hosts top 10 most critical website vulnerabilities. And it's also free to use. So let's click on it. This will be the room that we're going to be doing. And in this specific room, we don't really have an HTML injection. However, we can use a different task that we have right here to demonstrate HTML injection. And that different task is going to be this one, task number 5, command injection practical. Now, just so you don't get confused, we are not yet learning command injection. We're going to be focusing on command injection later in the course. For now, we want to do HTML injection. And we can also do it on this lab right here. You don't need to read any of this for now. We're going to leave that for later. For now, we're only interested into starting this machine. But there is one problem with this. Once we start the machine, it will be deployed in their own network. So we must VPN to their network in order to be able to access this machine. How can we do that? Well, it's rather simple. We can do that with the help of OpenVPN that we have inside of our Kali Linux. And they have a good guide on how we can do that. So navigate to this icon right here, then navigate to Access. And here we have the page where we can download our configuration file that we will use to access their VPN server. Here I have my VPN server selected, which is currently this one. And if I click on download my configuration file, it will open this file, which will have my username as well as .ovpn. If we save the file, it will be located in our downloads directory. And all we have to do afterwards is open a terminal, navigate to your downloads directory. If I type ls, here will be the file that I just downloaded. And in order to VPN into their network, we type sudo openvpn and then the file name, which in my case is this one. If I press enter, I enter my password. In just a few seconds, we will have everything set up. And now if we open a third terminal and we type ifconfig, you will see this third interface right here where you will get the IP address from the VPN, which in my case is this one. And this is the IP address that we will use to communicate with the vulnerable virtual machines that we're going to deploy on their network. So now that we did that, we can refresh this, and hopefully if we did everything correctly, this should update our information. We're currently connected to their VPN server, and this is our Kali Linux IP address. Okay, now let's go back to the lab. Now that we did all of this, let's navigate again to Web Hacking Fundamentals. Let's go to OWASP Top 10. And as already mentioned before, to demonstrate HTML injection, we're going to start this machine under task 5. Let's start it by clicking on this start button. And it will say starting your machine, please wait. In a few seconds, we're going to see this tab right here. It will say that the machine expires in 59 minutes, so that is how long we have to solve our task. Even though we're not really doing the command injection task, but this is how long the machine will stay up. And the IP address of the machine will be shown in 39 seconds. So all we have to do for now is to wait for this timer to go to 0 in order to be able to see the IP address of our target machine. And here it is. I got my IP address of my virtual machine. Now it gives you this option to copy it. And the first thing that I always like to do with this is I like to try to ping that IP address. Because sometimes it might take a couple of minutes for you to be able to communicate with this machine. You won't be able to communicate with it straight away, so pinging or visiting the HTTP web page won't really work. As we can see right here, I'm still not able to ping it. So let's wait for a couple more seconds, and hopefully in a minute or two we should be able to visit the web page of this IP address, and also we should be able to ping it. Okay, a few minutes went by, and let's try it again. If I ping the IP address, now we have established connection, and we can communicate with this machine. Awesome. Let's Control-C this, and the next thing that we want to do is visit the web page on this machine. Now, for the command injection part, if we go to the task that we have, we would be visiting this link right here. But we're not really interested in performing command injection right now. We will do that later. For now, we want to perform HTML injection. So what I want you to do is I want you to copy the IP address of your machine and add / at the end. Press enter, and it should load this page that says directory search. It's a very simple web page. As we can see, we do have a user input right here. We can type something in, and then we have a button to submit. So let's type, for example, test. Click on submit, and we get an error. User test was not found on the system. Now, what does this tell us? If we go back to our theory video of HTML injection, we remember that if our input that we specified reflects somewhere on the web page, we can try and test for HTML injection, and our test was reflected here. So what would happen if we, for example, typed HTML code? Let's give it a try. Let me just zoom this in so we can see everything better. And I'm going to type h1 and then close header tags and then capital test and then close header tags again. So we have open header tags for the h1 header size. We have test and close h1 tags. Let's submit this. And here it is. We get test printed in header of size 1. So that means this is vulnerable to HTML injection. And just in case you're not sure, we can do something like this, for example, h1, and then we can also underline to see whether it will process the underline tags of HTML code and if it will underline our test string. Don't forget to close both underline tag and header 1 tag, and if we submit, well, here it is. We get our test string underlined. This means this web page is vulnerable to HTML injection. And this is the most simple example that we can have. Nonetheless, we're going to take a look at some other examples and some other possibilities with HTML injection in the next videos, but for now on, we'll learn how we can deploy our virtual machines inside of our Try Hack Me account, and we also learned how we can connect to its VPN. Remember that you will have to do this every time you start Try Hack Me. But once you downloaded this file that we have right here, you can always use the same file. Just also make sure that you use the same VPN server. You just run this command every time you want to use Try Hack Me, and it will connect to their VPN, which will allow you to access their machines whenever you start them. Okay, awesome. Now that we got that out of the way, let's see an example of HTML injection on our OWASP BWA virtual machine. See you in the next video. Welcome back. Let's see a different example of finding HTML injection vulnerability. For this, we're going to need our OWASP virtual machine, so make sure that it is started. Make sure that you have Burp suite started right here and that Intercept is turned off. Now what we want to do is we want to navigate to the IP address of our OWASP virtual machine. Then we want to navigate to OWASP mutilday 2. And you will notice that right here, if we go to OWASP 2013 and A1 injection, we will have multiple examples of HTML injection, or should I say multiple practice examples of it. Let's go to, for example, this one. Let's go to HTML injection and then browser info. If I click on that, it will open a page that it should be vulnerable to HTML injection, right? But compared to the last example that we saw, here we don't really see any user input that we can use to inject code. We can't enter our HTML code anywhere on this page. So what are we going to do? Well, let's take a look at the page a little bit closer. If we take a look at all of the information that we have right here, we're going to notice something quite familiar for us, which is this user agent string. It appears to be our user agent, or us. Now, if we remember, in the HTTP headers, there is a user agent header that has this information for us. So could it be that perhaps the user agent header is getting reflected on this page? I mean, we can give it a try. Let's see what happens once we reload this page while Intercept is turned on. So let's go to our Burp suite. turn on the intercept, and let's reload this page. So straight away we get this HTTP request, and this is the same request for this page since we tried to reload it. Now let's compare this information right here, which is the user agent string, with the user agent string that we got in our HTTP headers. So here it is. As we can see, it's pretty much the same thing. So even though we don't have a user input field on our web page, could we possibly try to inject HTML code in the user agent field? Well, let's give it a try. If I delete the current user agent and I type h1 tags and then test, and then I close h1 tags, and let's also, for the purposes of this tutorial, add the underline tags just so we can see whether it will also underline it. So if we open the tags, we must also close them. And once we inject this, hopefully, if it gets reflected on this page, we're going to see test written in header size 1 and also underlined. Let's give it a try. Let's forward this packet and turn off the intercept. Go back to the page, and here it is. We get test reflected as an HTML code. How cool is that? We didn't use any user input field on the page, but we still managed to inject HTML code through HTTP headers. Awesome. This is just another example of HTML injection, and in the next video, we're going to take a look at even more interesting example and more useful example of HTML injection. See you in the next video. Welcome back. Let's take a look at a different usage of HTML injection and what else can we do with it once we find it out. Well, let's take a look at a different example this time. So in the last video, we injected our HTML code in the user agent HTTP header field. And that is when we found out that it's possible to inject HTML code without having any user input field. We just intercept the request in our Burp suite, and we injected the HTML code in our user agent field. Now, let's take a look at another example. So, navigate once again to OWASP mutildate2. Let's go to the HTML injection, and let's try this one. HTML injection via cookie injection. That is the one that we haven't tried yet. So let's go on capture data page, and let's take a look at this page. So once again, we don't really have any user input field that we can type our HTML code in. But we do get this printed out. And if we take a look at a little bit closer to here, we will have this data or this string written on this page. Now, what does this look like? Well, it looks like a cookie value. As we can see, PHP session ID, and then we get the value right here. So could it be that our cookie value reflects on this page? Well, we already know how we can check that. We can simply just intercept the request inside of the Burp suite. So let's reload the page, and here we get the request. Here is the PHP session ID. And let's compare these values right here. And that's pretty much it. This is getting reflected on this page. So we already know how we will go about doing this. We would just inject our HTML code, we would reflect the HTML code on the page, and we would conclude that the page is vulnerable. But let's try to inject something else than just HTML headers. Let's try to redirect this page to google.com with the help of HTML code. So how we can do that? Well, we can write this code. Let me just open Nano real quick. HTML redirect code.txt. Code.txt. And we are going to write this code. So open tags meta http-equiv equals open double quotes refresh close double quotes. Then let's add space content equals 5, and we're going to explain this in just a second. It's rather simple. Then semicolon, and then URL equals https://www.google.com. Close double quotes and close the HTML tags. So what are we doing right here? Well, first of all, let me just delete these two dots. We don't need two of them. One is just enough. And what this code does is it refreshes the page where we inject this code and redirects it to google.com. And this content equals 5 is simply just the amount of seconds that it's going to wait before it redirects the page. If we write 5, it will wait for 5 seconds and then it will redirect the page. If we set right here 1 or 0, it will redirect it straight away. So let's give it a try. Instead of injecting HTML header size 1, like we did in the previous video, let's try to inject this under the cookie value inside of our HTTP request. And here it is. Okay, let's forward this. And let's turn off the intercept. Navigate right here, and in 5 seconds, this page should get redirected to google.com. Here it is. We didn't type anything, it redirected automatically due to our code being processed as an HTML. Now, if you want to, you can do this. Let me just go back via cookie injection, capture data, let's intercept the request, and let's refresh the page. You can also do this straight away. You don't need to wait for 5 seconds in order to redirect the page. All you have to do is navigate to the content and change it to 0. Then forward the request or turn off the intercept, go back, and it will get redirected straight away. How cool is that? Okay, so this was another tag that we could have done with HTML injection. We can simply just redirect the page. And we also saw another way that we can perform HTML injection, which is through the cookie value. We changed the cookie value with the HTML code and it got executed because it got reflected on our page. Awesome. So in the next video, we're going to take a look at another example of HTML injection, and then in a video or two, we're about to move on to the next, more serious and dangerous vulnerability. See you in the next lecture. Welcome back. In this video, we're going to take a look at 2 more examples of HTML injection. And with this, we're going to finish off with this vulnerability. Now, before we start off with these examples, it's important to notice that this is not the most critical vulnerability that we can find on a page, but we did start with it just because it's simple to perform. The effect that it can have is, well, with HTML injection, you can pretty much change anything on the page. You can change the HTML code, you can make it redirect to a different page that we saw an example in the previous video. So what you can, for example, do is you can create a fake page that looks exactly like the page that you're testing. You can add a form, perhaps a login form there, and then you can redirect the real page to the fake page that looks exactly the same, and the user that gets redirected won't really notice anything. They might type their information such as usernames and passwords on the fake page, and you would be able to get all of that. And that is the power of HTML injection, because a regular user won't really see the difference between a real page and a fake page. Nonetheless, enough of talking, let's get straight into these 2 examples. So the first one that I want to show you is once again under the injection, and then let's go HTML via DOM injection. And let's select HTML5 storage. Here we do have some web storage. And if we type something in these user input fields and click on add, it will get reflected on this table that we can see on this page. Now, there are a few things that we might notice right here. There are a couple of things reflecting. We have our test getting reflected here and here. We also get test getting reflected here, but we also get our user agent field getting reflected here. Now, we will not be injecting this because we already saw an example of injecting the user agent field. It would probably work and we could probably reflect our HTML code right here. But let's give it a try under these 2 tabs. So the first thing that we will notice is that if we turn on the intercept and we type something in, well, we didn't really intercept anything. Our request didn't get interrupted. We simply just added another test value on this storage. But even though we can't really intercept this request, we can still try to write HTML code. And let's copy this right here and paste it on the second input tab as well. And we do get HTML injection, we just don't get it here. We get it right here. As we can see, our input got filtered and it simply just added our HTML code as a regular string. But here where it also reflects, we got test written in header size 1 tags. Okay, so this was a simple example. We got our HTML code right here, so we know that it's vulnerable to the HTML injection. But let's take a look at more advanced example. To navigate to that more advanced example, even that one is rather easy. We can go to the injection and let's go, for example, to the first one and let's go to this one, those back buttons. Click on that. Oops, we still have intercept on. Let's turn it off. And this is the page that we get. Once again, no user input fields. So what are we going to inject? We can't even see in this text that anything from our headers gets reflected. Well, besides this one, which is standard thing on every page that we visit, we're just going to ignore it at the moment. But if we read this discussion right here, it says the large back button image appears automatically on most pages, and they're probably referring to this arrow and this back button right here. If the image is clicked, the user is redirected to the previous page. The button works by executing a JavaScript statement which sets document.location.href equal to the HTTP header refer. This might already give us enough information. If we give it a try, for example, let's turn on the intercept and we click this back button. If we find the refer header, which is right here, well, it is correct. We do get the link to the page that we want to visit, which is the previous page to this one. Since we clicked the back button, it will redirect us to the previous page, and the link to that previous page is in the refer of our HTTP headers. But how does that help us? It doesn't get reflected anywhere on the page. At least this link doesn't get reflected anywhere on the page. Or does it? Well, let's take a look. Let's go right here and let's go under the inspect element. And for the inspect element to work better, let us just turn off the intercept and go back to our those back buttons example. So here it is. Let's go on it and let's try to find the code of this back button. So usually just by going over these lines of code, you will be able to select the different parts of pages. So let's just select this one since it's the entire page. Let's go to this one as it also takes our back button inside. And let's go to this one next and this one. Here we should be able to find the div open tag, which covers our button, which in our case is this one right here. And here's the button. If we click on lower arrow, we're going to get this OpenA tags that says onClick document.location.href, and here is where our refer link gets reflected. It is right here in our HTML code. We can see it inside the A tags. But how can we inject right here? Well, we could try to inject a simple HTML code in the refer button, but you will notice that it won't work if I type h1 and then test and then close h1 tags and forward the packet. Then turn off the intercept and navigate back to the page. Well, we didn't really get our HTML code reflected anywhere. So could it be that it's not vulnerable? Well, let's give it a closer look to our code. So here is our button where we now injected the HTML code instead of the refer link, which will lead us to the previous page. And it looks like this. So we have open A tags, onClick, document.location.href, and under the open single quotes, this is equal to our HTML code, as we can see right here. So let's copy this line of code. I'm not sure what I copied, but we're going to give it a try. Let's go nano HTML code.txt just so we can write our HTML payload right here. And for some reason I copied this, but nonetheless I'm just going to type it in so we can see it better. Okay, I wrote the entire code right here. So this is how it looks like. But we can see that this HTML code that we injected belongs to this document.location.href. So in order for our HTML code to get processed as an HTML code, we must escape these A tags and this document.location somehow. Well, here's what we can do. Let's try to write our payload down here. So it will start with onClick. Oops, and I misspelled right here. So onClick document.location.href equals open single quote. And the first thing to notice is that this document starts with double quotes. So perhaps what we can do is we can make it end right here by adding the closing double quotes, instead of just starting to write our HTML code right here. So now perhaps if we write our HTML code, it would look something like this, right? So our document.location should end right here, but we still got our HTML code between the A tags. So what we can do is we can also close the A tags right here. After the double quote that we injected, we can type closing tags that we have right here and closing A tags. Now, you might notice some similarities because we pretty much just moved this entire part of characters right before our HTML code. As you can see right here, here was it before, and now we have it here. So we're essentially making this open A tags with the document location end sooner. And as soon as it ends with this line, we are moving on to our next line of HTML code that we are injecting. So our final payload will look something like this. We want to inject this into the page. Open h1 tags. This is our payload. Let's see if it works. So if we copy it, go back to the page, turn on the intercept, we can lower this, refresh the page, and under the refer, we don't really need to remove this link. We can just append our payload straight at the end of the link. So let's go paste, and here it is. We got double quotes, close tags, close A tags, open header1 tags, we wrote test, and we closed header1 tags. Let's forward this packet and turn off the intercept, and we go back. Here is our HTML code getting reflected on the page. We successfully performed HTML injection that we couldn't get to work at the beginning. And this right here is the leftover code that we pretty much cut off once we injected our HTML code. And in order for us to take a look at how this code looks in the HTML page, we can navigate to our button, which is right here, and here is the open A tags that we have before. We closed it right here. As we can see, this is the first part of our code where we closed the double quotes and we closed the A tags. And down here, it processed our h1 headers with test written inside of it. So it processed it as HTML. And here is that leftover part that we cut off from this line right here. So once again, in case you're confused, what we did is we took the original code, which looked like this once we inject our h1 headers. We moved the closing tags before we type in our HTML code. Then it closed this entire line of A tags, and it processed our HTML code as a separate line, and it wrote it on the page right here. So this was a little bit more advanced example of HTML injection, and with this, we are done with this vulnerability. So it was rather easy to perform, as we already mentioned, but it does not have that big of an impact. The best thing that you can do with this is pretty much change stuff on the page or redirect the page. Nonetheless, if you want, you can take a look at the other examples of HTML injection on this and on other pages of our vulnerable virtual machine. You can see there are too many. Of course, we're not going to cover all of them, so you can practice this vulnerability on different examples. And we are going to continue with the next vulnerability in the next section, which is going to be a more serious and a more dangerous one, and it is called command injection. See you in the next lecture. Welcome back. Time to cover our first real vulnerability. Even though HTML injection is considered a bug, command injection is much more serious. So, what is command injection? Well, we can define it like this. Command injection is a web vulnerability that allows an attacker to execute operating system commands on the server that is running the application. Typically, once it's discovered, it allows the attacker to fully compromise the application and all of its data. Sometimes, command injection can be used to compromise other parts of the host's infrastructure, and it can be used to pivot the attack to other systems within the organization. So yes, it can be really serious vulnerability. It allows us to execute system commands on the server, which could also mean that we can see the files, check out the passwords folder, delete files, and perhaps even set a reverse shell connection. But how exactly do we do that? And when can we find this bug? Let's check out an example in theory. Say we have a simple web application that lets people read different stories. It gives you a list of stories that it has available, and you type in which one you want to read. Let's say that those stories are stored in TXT files on the server. Once a client types in the name of the story that they want to read, the server processes the content of that story's TXT file and outputs it back to the web page. Now, this is a very simple example, but it will give us a good understanding on what exactly is command injection. And what we saw right here was a normal usage of this web application. But the problem can occur if the website processes the content of the story itself through its system without the user input being filtered as to what characters and what commands can it receive. Let me explain this a little bit better. For example, let's say this application reads the content of the TXT file with the help of the cat command. We type in the story name and it cats the story, reads the output and throws it back to the web application for us to read. All of this is good, but what happens if we enter this, for example? Story1.txt, semicolon, who am I? And here is where our terminal commands knowledge comes in play. What we did right here is we simply typed the story that we want to read, then we used semicolon to add another command that the server should execute, which in our example is who am I? And by the way, semicolon can be used to separate multiple commands. It's just one of the ways that you can separate multiple commands and execute them one by one. So now the command that the server would process would no longer be just cat story1.txt, but it would look something like this. Cat story1.txt, and then after it executes that, it would execute who am I. And if the website is vulnerable to command injection and it doesn't filter our input, we would get an output like this. It would output a story, and at the end we should also see the response of the who am I command, which can be root or the account name that executed the command. So in general, the process looks something like this. We find a user input that could potentially get processed by the system. We add normal input and concat additional command to it, and if the input isn't filtered, it will process both of those commands and it will give us both of these results. Awesome. Now let's see how that looks like in practice. Welcome back. Let's cover our first example of command injection. And as usual, we're going to start off with an easy example first. This example will be the one from our Try Hack Me OWASP Top 10 Lab. So we already ran that virtual machine once we covered the HTML injection, and we want to do the same thing again. We want to run the virtual machine used to perform command injection in the lab that we covered inside of the Try Hack Me platform. Now, since we already ran it once, I'm going to go through the process of running those virtual machines and setting up VPN one more time, just so we can refresh our memory. So the first thing that we want to do once we open our Try Hack Me account is we want to make sure that Burp suite is started and that Intercept is turned off, and then we want to run our VPN file. Remember, we downloaded it in the home and then our account and in the downloads directory. And all we have to do to run it is type sudo openvpn and then the file name. Enter your password and it will start the VPN for you. Now, if you open another terminal and type in ifconfig command, you should be able to see another interface right here that will give you the IPv4 address that will belong to the Try Hack Me network. Okay, awesome. Once you got that set up, you want to navigate to your dashboard, navigate to the Learn tab, scroll all the way down till we find our modules, which are right here. Select Web Hacking Fundamentals. And under here, we want to go with OWASP Top 10. Okay, awesome. As we can see, we are connected to their network. Here is our IP address. As it says even here that we are connected via OpenVPN. So everything is set up good. Now, if you don't connect from the first try, just try to restart both of your OpenVPN and your Try Hack Me platform. Just refresh it after you start your VPN again, and it should work perfectly. Now, once we navigate right here, we want to go to the task 4 and task 5. Both of these are command injection. Just this one is only theory. It allows you to read something about it. You can go through all of this if you want to. I do advise you to read it. And you can also read examples of command injection right here under the task 5. But we're not going to be reading this at the moment. What we want to do is we want to start the machine. As we remember, it will take around 1 minute for our IP address of our vulnerable virtual machine to appear right here. So let's wait for that. And by the way, after we finish showing the command injection, in the next video, we're also going to try to do these tasks or do these challenges right here. These are something like capture the flag challenges. So it will ask us to find something and we will try to do it with the help of command injection. But for now, let's just get command injection to work. So let's wait once again for IP address to show. And here is my IP address. I'm going to copy it. And the first thing that I always do, which I already mentioned, is I try to ping the IP address. In case you get a response like this where it is not able to ping it, make sure that you wait for a minute or two and then you should be able to ping it, since it does take some time for the machine to set up. So let's Control-C this, wait a couple more seconds and then we will try again. Let's give it a try again, and if I ping it, now we do get the response. Okay, awesome. Let's go back here, and in our challenge, as we already saw previously, we do get this link right here. So this link is what we're going to use to try to perform command injection. Let's click on it, and it should open a page called evilshell.php on our target's IP address. And here we get a simple web application. It only has this one input that allows us to enter a single command. And if I type something like test, well, nothing will appear. But what would happen if I type something like test and then semicolon to separate the commands and type ls, which is the command to list all the available files in the directory. If I click on submit, now we get a response. We get all the files that are currently in this web server's directory. So this input right here is vulnerable to the command injection. You can do this with any command that you want. You can type test and then semicolon and then, for example, who am I? And it will tell you which account is it running as. Currently it's running as www-data. So command injection works in this input. But there's one more thing that I didn't really tell you. Besides the command injection that reflects the output on the page, there is also something called blind injection or blind command injection. What does that mean? Well, it means that we can't see the output of our command on the page, even though it might be vulnerable to the command injection. Okay, but you might be wondering, well, how can I then know if it's vulnerable if I can't see any output on the page? Well, we have to approach it differently. Now, let's imagine that this same page doesn't give us any output. Let's imagine that once we type test and then semicolon and then space and ls, it doesn't print anything right here. If you didn't know about blind command injection, you would probably think that it's not vulnerable. But there is another test that we can perform. We can try to perhaps ping our Cal Linux machine from our target machine. It won't give us any output here, but if we try to intercept the requests using something like a Wireshark, then maybe we can see the packets that the target machine is sending in order to ping us. If we do see those packets, that means we have a blind SQL injection. Let me show you what I mean. So first thing, we're going to open a program called Wireshark that is used to sniff packets and data over certain interfaces. We do ideally want to open it with sudo, just so we don't have any limitations. So just type sudo Wireshark and then type in your password. It will open this user interface program where we are going to try to sniff our packets once we run the ping command. So you will open a window that looks something like this. And you will have multiple interfaces right here. Ideally, we want to select the interface that we use with our VPN. And once again, you can figure out which interface that is by typing ifconfig. And for me, this is TUN0 interface. It has the IP address that belongs to the TryHackMe network. So I'm going to select that one right here. And here it's going to sniff for all the packets that are coming to that interface. Now, in order to discover this blind command injection, what we can do is we can type test and then ping our IP address. So to check out what IP address we have, we can copy it from our ifconfig output right here, and we can paste it here. But before we run it, we want to be specifically sniffing for ping requests inside of our Wireshark. And those packets are also called ICMP packets. So you can type in the search bar ICMP, press enter, and it will only output any ICMP packets that are received right here. So let's give it a try. We typed test, semicolon, then we added space for the second command, and we typed ping and then the IP address. Now, also since Linux systems ping forever until you Control C, we also want to add -C option, which stands for count, and we want to ping only 5 times. So we were going to type ping, IP address, then space, -C, and then 5. In case you don't see it really well, let me enlarge this, and it looks something like this. Once we submit this request, you will notice that this page is loading consistently. And after a few seconds, we get this output. But if we go to our Wireshark, we also get ICMP packets from the target machine. Now, imagine that we didn't get this output right here. We would think that there was no vulnerability. But if we opened our Wireshark and saw the requests coming in, we would know that we have a case of blind command injection. How cool is that? Okay, awesome. And this was the simple example of command injection. In the next video, we're going to take a look at these tasks right here, even though they don't really have much to do with the command injection, but more like system navigation and something like that. But we're nonetheless going to do them just to show how you can approach these challenges. Thank you for watching, and I will see you in the next lecture. Welcome back. Let's try to solve these challenges inside of our command injection task. Now, this is something that we do as a bonus. It has very little to do with the vulnerability itself. It's more like what you're going to do after you find the vulnerability. And we're not going to be doing all of these challenges on Try Hack Me platform. However, we might do a few of them just to see whether we can solve them. So navigate to your command injection, which is task number 5. Make sure it's command injection practical. The requirements for this is that if you want, you can read through this and this part right here. And also you should have watched the previous video where we performed the command injection. Right now, let's use that command injection to solve these examples. Let's go with question number 1. It asks what strange text file is in the website root directory. Well, we already know how we can do this. To list all of the files in that directory, all we can do is type ls. So we can type something like test to finish off the first command, even though it's not necessary for this virtual machine. However, we just do it for practice, and then semicolon, and then we can type ls. This will list all the files in the current directory. And let's get to the question again. We're searching for a strange text file. Let's go back, and pretty much the only text file that we have right here is drpepper.txt. So let's copy that name and specify it right here as a first answer. Okay, it's correct answer. Awesome. Let's go to the second question. Now, it asks how many non-root and non-service, non-daemon users are there. Well, this might be a little bit tricky because for this, we can do something like this. So test, semicolon, and then we can cat @c and then passwd folder in order to see all of the users that the system has. Now, we are searching for non-root and non-service users. And if we take a look at this output that we get right here from the @c passwd folder, well, pretty much we don't have any personal user outside of all of the other users tied to a service such as proxy, such as no login, such as network, and all of that. So the answers to this should be 0. Let's submit it. And that's also a correct answer. Awesome. The third question is the one that we already performed in the previous video, which is what user is this app running as? So we already did this in the previous video. We can type test, semicolon, and then who am I, and it will tell us the user that's currently running this web application. In our case, it's www-data. Let's copy that and submit it for the third answer. The fourth question is what is the user's shell set as? Now, this is something that you can also try searching inside of the @c passwd folder. Let me show you what I mean. Once you cat the @c passwd folder, it will give you this output, and all you want to do right here is try to find the www-data user. And if we go and scroll a little bit, it's right here. At the end of that user's line, we should be able to find a path that says /user/has-been/no-login. Let's give it a try. Let's copy that. This is the path that we get, and if I set it right here, let's see whether it's correct, and it indeed is correct. So all we had to do is cat the @c passwd folder, find the www-data user, and at the end of the line you will have the path that is the answer to the question of what is the user's shell set as. Okay, awesome. Now, the fifth question is what version of Ubuntu is running? And most of these questions are something that we can actually Google if we don't really know. So for example, let's say that we don't know what command can we use to discover the Ubuntu version. We can try something like this. How to check Ubuntu version. Press enter, and we can visit first or second link, it doesn't really matter. Let's go with this one, how to check your Ubuntu version. And ideally we want a command that is used to do that. So let's scroll a little bit down. and it says use the lsb release-a command to display the Ubuntu version. So let's give it a try. If we copy this command and we run it inside of our evil shell, so test semicolon, and then let's paste the command. Okay, so we do get the output. Here is the Ubuntu version. And which format are we looking at? We're looking at a number.number.number. So it's pretty much this, 18.04.4. Copy that. This is the Ubuntu version and paste it right here. Awesome. Now, the last question is the trickiest because it says print out the MOTD. What favorite beverage is shown? Now, pretty much 99% of you are going to take a look at this question and wonder what even is it asking, but I advise you to straight away go to hint. So the hint tells us 00-header. And this sounds like a file, perhaps, or something like that. So we can start off with that. We can try to locate a file that has this inside of the name. How can we do that? Well, we can use a locate command that most Linux systems support. So we can type test and then semicolon. And by the way, just so you don't get confused, you don't need to type test every time. You can type anything, so pretty much anything at all. You can type test 1, 2, 3. The word that you type before the semicolon is really not important in this case. So you can type pretty much anything and then semicolon, and then comes the important command. So we want to locate, and what are we locating? Once again, we're locating 00-header. Let's copy that name, and let's paste it in our command. Click on submit, and we get this output, which sounds like a path, which is under the /etc/update motd.d/00-header. So let's try to cat this, but let's make even more complex command. Let's type test semicolon, and then let's cd /etc/update-motd.d, and let's concat another command, which we can do by typing two of these signs right here. And then we can type cat 00-header. So here we're actually trying to execute three commands. The first command, which doesn't really matter what it is. In this example of this virtual machine, you don't even need to use it because it's specifically made to execute commands. But in real life, you will have a first command that should be normal web application usage. Then after that comes our command injection, where we execute our first command, and in this case we concated another command. After we cd to this directory, we want to cat the content of this 00-header. Let's submit this, and this is the output that we get. So now let's go back to the question, what favorite beverage is shown? Let's go all the way down, and if we scroll, we're going to see something interesting right here that says Dr. Pepper makes the world taste better. We can copy this, go back to here and paste it right here. Oops, let's try like this. No, that doesn't appear to be the answer, so... we should just copy Dr. Pepper if I'm not mistaken, not the entire sentence, so let's go back and let's paste Dr. Pepper. And here it is. That's the correct answer. So this was just a little bit of a bonus video where we covered these tasks right here using different commands. And in the next video, we're going to take a look at how we can run a reverse shell with the help of a command injection on our OWASP BWA virtual machine. See you in the next lecture. Okay, let's try and solve some command injection challenges on our OWASP virtual machine. So what you want to do is make sure everything is started. Burp suite is started, even though we're not going to use it, but we need it just in case. Maybe we are going to need it, maybe we're not going to need it, we don't really know that. Also, besides Burp suite, open your OWASP virtual machine, and once you have all that ready, we want to navigate to the OWASP Multi-Day 2. Now, here on OWASP 2013, we're going to see under the injection, command injection. right here. And we can go with any one of them. So let's go with DNS Lookup. It will open this simple page. So it says, who would you like to do a DNS lookup on? Enter IP or hostname. Let's say, for example, we type in google.com. And just so we can see everything better, I'm going to zoom this in. Let's say we type www.google.com and click on lookup DNS. And this is the output that we get. And straight away, just from the output, we should be able to notice that this output looks quite similar for us. It almost looks the same as the output from the nslookup command. And as we already know from our Linux knowledge, nslookup command is used inside of the terminal. So if I typed www.google.com to the nslookup, we would pretty much get almost the same response. So maybe this application is using its system to execute this command and give us the result back. And whenever this happens, we already know there might be a possible command injection. So let's type www.google.com, semicolon, space, and then let's type who am I. Click on lookup DNS. And this is the output that we get. We have a command injection. As we can see down here, it executed our whoami command. We can do the same thing with ls or any other command that we can run in terminal, and it should also run. As we can see right here, our ls command gave the output of all the files in this current working directory. So this was rather easy. We found the command injection. But let's take it a step further. Let's try to establish a reverse shell with the target system with the help of a command injection. And if we take a look at these outputs or these files that we got with our ls command, it seems that the server is running PHP, which is most common, to be honest. So most likely servers will be running PHP. And maybe we can do something like a PHP reverse shell. Now, even though we're not PHP coders, these type of one-line reverse shells are very easy to find online. And you just need to Google PHP one-line reverse shell or bash one-line reverse shell, and it will give you a single command that can be used to establish a reverse shell connection with our Kali Linux machine. So I got one of those commands right here. It's written right here in my nano editor, and all this command is doing is it's running PHP code where it creates a socket object, and socket object in programming language is something used to establish a network connection. In the brackets between the double quotes, we have our Kali Linux IP address. So this is my Kali Linux IP address. And here is the port that we want it to connect to. The second part of the command is what we want it to execute once it connects. And this entire part simply tells execute the bash shell and make it run as much commands as we want. So this is the entire thing that this command does. It connects to our Kali Linux IP on the specified port, and it executes the bash shell for us so we can execute the commands. But in order for the target machine, which in our case is OWASP BWA, to be able to connect to our Kali Linux machine, we must listen on an open port for the incoming connections. And we can do that easily by opening terminal and typing nc, which is netcat, -lvp, and then the port that we want to listen on. This -lvp simply stands for listen on any interface that Kali Linux has. So we're not specifying the exact interface, we're pretty much telling accept the connection on whichever interface that you get the connection from. So it's nc-lvp and then space, and here we need a port. And if we go back to our command, let me find it. In this command, we specified the port 1234, so we must use the same port inside of our netcat command. So we would type nc-lvp and then 1234. And this is pretty much all we have to do. It says listening on any interface on port 1234. Now we want to copy this command and make sure that you get all of these single quotes and double quotes right, because otherwise it will not work. And then we want to execute it right here. So let's go down and type www.google.com, semicolon, and now let's paste the entire command here. Click on Lookup DNS, and the first thing that you will notice is that it's loading the page. It's not outputting anything for us. It's just continuously loading. And if we go back to our netcat window, here it is. We got our reverse shell opened, and we're on that machine currently as www-datauser. Here we can execute all the commands without having to go to the web page. We can just type who am I, we can type ifconfig, we can type ls, we can type pwd to check current working directory right here, and we can type anything that we can run from a normal terminal. We can even try to, for example, execute one of these PHP files if we want to. So this is really good because now we have a reverse shell established on the target machine, and we can do anything that we want, including deleting files, creating files, navigating through the system, downloading files, uploading files, and all of that. So that's really cool. Even though you can do all of that with just typing in the commands right here, it's much easier once you have a reverse shell established where you can just type in the command in the command line. Now that we did that, we covered a little bit of an advanced example of exploiting command injection, and in the next video we're going to take a look at one last example of command injection, which will be on our DVWA on our OWASP virtual machine. See you in the next video. Welcome back. Let's see an example of command injection on our DVWA page. So open up your OWASP and navigate to the DVWA. Here we are going to log in with our credentials and make sure as usual that Intercept is turned off so we can navigate between the pages. Now, once we get to this page, we want to go to this part right here that says command execution. It's essentially the same thing as command injection, they just named it differently. Let's go there, and for this first example, make sure that security level is set to low, and we'll be checking out security level low and security level medium. I believe in these newer versions of DVWA, the high security level is actually not vulnerable, and it's an example of how the code should look like once the input is not vulnerable, or once the input is filtered properly. So, right here it tells us ping for free. We can enter an IP address, and it will ping that IP address. Here I typed in the IP address of my router, and it performed 3 ping requests, and it outputted the results right here. So already by seeing these results, we can imagine that the page is performing something like this. Ping 192.168.1.1 -C for the count and then 3. Then it pings the router 3 times and it outputs this result back to us on the page. So this page is interacting with the system. Now let's try to inject our command. So I'll type in the IP address, and by the way, this IP address most likely won't work for you. This is just my router's IP, so feel free to try with a different IP instead, whether it's external IP address or a local IP address inside of your network. And now let's type semicolon and let's type ls. Submit this. And here is our command injection. It executed the second command as well. So simple as that, we managed to run our command injection, and now we can do pretty much anything that we performed in the previous videos, such as running reverse shell, such as taking a look at different accounts and passwords and all of that. But this is not why we performed this example. We want to see how we can also perform command injection on security level medium. So to change the security level on DVWA page, navigate to here that says DVA security and change from low to medium. Click on submit and go back to the command execution, and down here you should see that now the security level is set to medium. So let's try the same thing. Let's go with the IP address first, just to see what type of output do we get. And we get pretty much the same output as before. Now let's try to execute our ls command by typing semicolon, space, and then ls. Nothing happens. And you will notice that on this DVWA page, we do have the source code to how this input is filtered. This source code is written in PHP, and we're going to take a look at it just so we can see why our command injection doesn't work now. So let's open the source code. As I mentioned, it's written in PHP. Even though we don't really need to know PHP, we can try to guess what this code is doing. So this is the IP address that we input, or should I say the command that we input. And now it performs this part right here. Or should I say this part. This is the important part for us. So it creates an array that uses these characters. And we can see our semicolon right here. So it pretty much every time in our command that it sees semicolon, it will change it to nothing. Same goes with these two signs. And by the way, these two signs are also used to concat different commands. Let me show you in terminal. So you can type something like ping 192.168.1.1 -c3, and then you can use these two signs to also run ls right afterwards, as you can see right here. So semicolon is not the only way that we can concat commands. And we can see both of these ways are filtered. It will replace them with nothing in this line right here. And that's why our ls command doesn't work. So does this mean that the input is not vulnerable? Well, not really. There are more ways that we can concat commands. For example, we can type ping 192.168.1.1 -c3, and then instead of using two of these signs, we can just use one of them, and it will still work. Let me show you. If I type one sign and then ls, here it is. It printed out both of these things done. It just did this first command straight away and the second command right after. But it did perform both of these commands. So can we try something like that right here? As we can see, it's not filtering just one of them, it's filtering once it sees two of these signs. Well, let's give it a try. Let's try to ping 192.168.1.1 and use one of these signs and then ls. Let's submit this. Whoops, it actually won't work because we typed ping, so we just need to type an IP address and let's say who am I. Let's type who am I this time, just by using one sign to separate the commands. And we do get both of the outputs back, just the who am I output is somewhere in the middle of this command. That is because once you type only one sign and not two of them, it actually executes both the command simultaneously, and whichever output comes first will be printed out right here. And currently we got the output of who am I in the middle of the ping command. But we did run our command injection on medium security level. Awesome. And in reality, you wouldn't really have this source code right here. You wouldn't be able to see the PHP code. However, you would try all of these signs. You would try semicolon, you would try both of these signs, you would try one of the signs. You can also try the pipe character in order to concat different commands. And all of those things could be filtered, or maybe most of them are filtered, but you do manage to find one sign that isn't, that will allow you to perform command injection. So you would just try all of them and see whether any of them works. Now that we covered command injection, in the next section we're going to cover another big set of vulnerabilities that is called broken authentication. See you in the next lecture. Broken authentication. Just by its name, we can already assume what type of vulnerability this is and what it does. And this is one of the most common attacks and vulnerabilities in past years. Now, broken authentication is usually tied to sessions, but let's define a session first. So, what is it? Well, we can say sessions are a sequence of network transactions or network requests associated to the same user for a certain period of time. This is what identifies an individual on a web page, a session. Now, don't confuse sessions with authentication. Even though they are quite similar and sessions do interact and do change based on whether a user is authenticated or not, sessions are established even when a user is not authenticated. It's just that it changes once a user does authenticate on the website. Okay, but regarding broken authentication, what attacks do we have? What can we do to test for this vulnerability? Well, there are different types of the attacks, but we can separate them into two different groups. Group number 1, which are attacks that the user is responsible for, and group number 2, attacks that the developer is responsible for. Okay, so both sides take place into making these attacks work. How exactly? Well, users are responsible for their credentials. They're responsible for making their password as strong as it can be by adding numbers, characters, upper and lower case letters. However, usually this isn't the case, and they choose an easy password that has a meaning to them. We can target this with attacks like brute force of the credentials. We can brute force usernames, passwords, security questions, and anything that we need to get into an account. These type of the attacks we will cover in the next section. However, in this section, we're more interested in covering mistakes in website configuration that allows us to steal a session. These web developers are responsible for the session management, how the website is going to process different sessions, and what parameters is it going to use. Usually, these sessions are identified with cookie values or URL type parameters. Sessions are considered as important as user credentials. A hijacked session ID is as strong as a stolen login credential. And that is the attack that we will mostly be doing, session hijacking or session stealing. There are many approaches as to how we can do that. One of them is an attack called session fixation. The main idea behind this attack is that the attacker predetermines the session ID that the victim will use. For example, the attacker could send the victim a link that contains a predetermined session ID, and that link might require the victim to log in. After they log in, the attacker can then use that session ID to impersonate the victim after the victim logs in. There is also a possibility of weak encryption or weak cookie values. It can be that the website transmits the passwords in plain text or in a weak encryption that can easily be reversed. This is also a point of attack for hackers. Credentials should have best encryption possible since they are the main things keeping someone to have an unauthorized access to another person's account. Same goes with cookie values. They have to be random and unpredictable. Now, different examples of broken authentication attacks we're going to see in this section, while brute force attacks and similar we will do much more in the next section. So get ready and let's get straight into practical examples. Okay, let's cover our first basic example of broken authentication. And for this, we're going to start off with Try Hack Me platform. So make sure everything is started, you have your Burp suite, you have your VPN running, and make sure that you also get the IP address for the VPN. Once you do all of that, navigate to the Try Hack Me platform and go, as usual, to our web hacking fundamentals and navigate to our OWASP top 10 room. Here it is. Let's go right here. And we already know right here we got a bunch of different tasks, but for this lecture we want to navigate to task number 6 and task number 7. Now, if you want to read about broken authentication a little bit, you can read through the task number 6 and then navigate to the practical part, which is task number 7. And this task is rather easy. So let's take a look and let's read what it asks from us. But before we read through this task, let's start our machine, because we already know that it takes about a minute or two in order for it to start properly. While it's starting, let's read through this task. For this example, we'll be looking at a logic flaw within the authentication mechanism. A lot of times what happens is that developers forget to sanitize the input given by the user in the code of their application, which can make them vulnerable to the attacks like SQL injection. Okay, we already knew that. Let's go all the way down. Let's understand this type with the help of an example. Say there is an existing user with the name admin. Okay. And now we want to get access to their account, so what we can do is try to re-register that username, but with slight modification. We're going to enter space and then admin. Notice the space in the starting, okay? Now when you enter that in the username field and enter other required information like email ID or password and submit that data, it will actually register a new user, but that user will have the same right as normal admin. That seems to be quite a big of a problem. Let's continue reading. That new user will also be able to see all the content presented under the user admin. To see this in action, go to this link. So let's visit it straight away. And let's go down just to read until the end and try to register a user named Darren. You'll see that user already exists, so then try to register a user space Darren. And you'll see that you are now logged in and will be able to see the content present only in Darren's account, which in our case is the flag that you need to retrieve. Interesting. And the first question is, what is the flag that you found in Darren's account? So let's go and take a look. If we try to log in as Darren by typing Darren and let's say test1234 and click on sign in, we get an error, invalid username or password. So let's try to do what the try hack me example told us to do, which is to register a user with slight modification. So let's type space and then Darren. Make sure there is space right here, otherwise it will not work. And under the email, we can type any email that we want. I typed test@gmail.com, which is probably a non-existent email. And under the password, I will type test1234. And I will register this user. Okay, so we registered the user successfully. Now let's try to log in as that user and see whether we will be able to find the flag that should only be accessible from Darren's real account. So let's go right here, type space and then Darren and test1234. Let's click on sign in and here is the flag. So we successfully performed a broken authentication attack where we registered a new user with slight modifications such as adding space at the beginning of the name, and it allowed us to see the flag that should only be accessible from the real Darren user. And we would submit this flag right here under this question. Okay, and the other question is try to do the same trick and see if you can log in as Arthur. So I assume the Arthur account already exists, so pretty much we can do the same thing. We can go register, add space, and then Arthur. And for the email, we can type once again anything that we want. I typed test2@gmail.com and password will be test12345, just to make it different than the Darren's account. Now let's go and log in. So add space, Arthur, and test12345. Click on sign in, and here we get the Arthur's flag as well. So we pretty much performed the same thing for two different accounts, for Darren's account and for Arthur's account. And if this type of vulnerability was to exist in a real page, we would pretty much be able to access any account on that page just by knowing its username. We would then perform a slight modification, register a new username, and we will be able to see all the things that original user can see. Okay, but this was a rather simple example of broken authentication. In the next video, we're going to go back to our OWASP BWA and try to take a look at a different broken authentication attack. See you in the next lecture. Welcome back. Let's see a different example of broken authentication attack. And to present this, we're going to be using OWASP motilde 2. So open up your OWASP machine, navigate to the motilde 2, And under here we want to go to OWASP 2013 and navigate to Broken Authentication and Session Management. Right here we want to go to the Authentication Bypass, and let's go to Bypass via Cookies. Click on that, and this is the page that we want to, let's say, hack. But let's read through this first. So some sites keep authentication and or authorization tokens in the user agent field. This gives the user large amounts of control over these tokens. Okay, but do we really need to read through all of this? It just tells us that some different attacks are possible, such as SQL injection, brute force, and secret administrative pages. But let's read the name of our task again. So it's broken authentication. We want to bypass authentication, and we want to do it via cookies. Okay, to be able to do this, we need to have an account on this page. So let's create a simple account by going on login and register. And we don't have an account, so let's register right here. We're going to type username. Let's type username test1 and password, let's say test1234. We will confirm the password, and the signature is not needed, so let's just create an account. Okay, it tells us account created. Now let's go back and let's go on login, and let's log in with our account. So the username was test1 and the password was test1234. Okay, awesome. Let's close this window, and in the right corner we should see logged in as user test1. Now let's go back to our page and try to bypass and switch the account by changing the value in the cookies field. So let's navigate to our Burp suite, turn on the intercept, and let's try to refresh this page. Let's take a look at the request that we're trying to send, and if we go down, here is our cookie value. Now we can see there are multiple fields to this cookie value, but there are two particular fields that should be of interest to us. We got username equals test1, we got user ID, we got PHP session ID, but these two right here do seem interesting to us the most. Let's try to change the username from test1 to, let's say, admin, because there is an admin account on the Mutal page. And if we forward this request, nothing really happens. We're still logged in as user test1. So maybe we can't do it like that. Let's try with the user ID field first. So let's turn off the intercept, turn it on back again, and let's refresh the page. Now we get the same request. We got the username test1, which is us, and we got the user ID. Apparently 25 is the user ID of our test1 account. Let's try changing that to 1, for example. Let's forward this, go back to the page, and here it is. We managed to switch the account by changing the values inside of the cookie header. Now it says logged in as admin. Here is our account. And we can do that for any account that we want. If I refresh the page and change the user ID from 25 to 2, forward, now we should get a different account, logged in as Adrian. How cool is that? And this is a vulnerability in the session management. It allows us to switch the accounts by changing the user ID in the cookie field. So this was also a simple example, and in the next few lectures we're also going to take a look at different approaches to broken authentication attack. Let's cover yet another attack for broken authentication, and this one will be aimed at authorization within the page. To demonstrate this, we're going to go to a page called OWASP WebGoat. It's right here. Let's click on it, make sure that intercept is turned off, and it will open a window like this that will require us to log in. And remember this window because it will be important for us in this lecture. So we got this pop-up window, and to log in we can type guest and then as password also guest. So username guest and password guest. Click on OK. Let's not save the password, and it will open a page like this. From here we want to start our webcode, and let me just zoom this in a little bit, and here we will have different attacks that we can perform. Of course, not all of these attacks have to do with broken authentication. Most of them actually are different vulnerabilities, but the attack that we are interested at the moment is authentication flaws. So click on that, and from here we want to go to basic authentication. Okay, it will open a task like this. So it says basic authentication is used to protect server-side resources. The web server will send a 401 authentication request with the response for the requested resource. The client-side browser will then prompt the user for a username and password using a browser-supplied dialog box. And that is the dialog box that we saw once we logged into webcode. The browser will base64 encode the username and password and send those credentials back to the web server. The web server will then validate the credentials and return the requested resource if the credentials are correct. These credentials automatically resend for each page protected with this mechanism without requiring the user to enter their credentials again. So essentially what this says is that our basic authentication credentials that we inputted once we logged into our webcode will be processed through every page within the HTTP request without us having to log in every time we switch a page. But the problem here is that it's encoded with base64. So here we will have a vulnerability of weak encryption and weak encoding. Base64 is something that we can easily decode. So let's give it a try. For this lesson, your goal is to understand basic authentication and answer the questions below. What is the name of the authentication header, and what is the decoded value for the authentication header? Okay, let's go right here, turn on the intercept, and this is also a rather simple example. If we go to our HTTP header, we get this field that's called authorization, and it says basic and then some random letters. Now, we got our answer to our first question. Authorization is the answer to what is the name of authentication header. So we can type it in, authorization, even though it doesn't matter since we are in the middle of refreshing the page, but nonetheless, let's take a look at this more interesting part that says basic and then some random letters. Now, we already know that this is base64, and you can usually recognize base64 by this equal sign at the end. Right here it also tells that it's basic authentication, so what we can do if we were to, for example, intercept this request by using something like a man-in-the-middle attack on a wireless network, and we were to get this request from some other user that's trying to visit a page within the webcode, we will be able to decode their username and their password and then log in to their page. Let me show you how we can do that. We copy the value that's encoded right here, and then we go to something called decoder. Here you can turn off the intercept and navigate to the decoder. Now, decoder is something that we didn't cover in the Burp Suite Basics, but it's rather simple to use. All we have to do is paste right here what we want to decode. And let me see if I even copied it. Okay, I copied it successfully. And right here on the right side, we want to click on decode as, and we want to decode it as base64. Let's click on that. Wow, here it is. Here's our username and password in plain text. And that is all it took for us to get the username and the password of a certain user. Now, of course, for us to be able to get this HTTP request that we intercepted, as I mentioned, we would have to do something like a man-in-the-middle attack, but that's really easy to perform. The problem right here is that the page has a weak encoding, and then we can easily reverse the encoded username and password back to the plain text. And now we can copy this because this is the decoded value, since that is the answer to our second question on the page. And let's paste it right here and submit. And it will tell us, congratulations, you have figured out the mechanism of basic authentication. Now you must try to make webcode re-authenticate you as username basic, password basic. Use the basic authentication menu start at the login page. Now, all we have to do right here is simply just to close the webcode, and then we would re-authenticate with basic, and basic as username and password. So this is something really easy to do. We're not going to cover that. Just next time at the login screen, you can use this username and this password to enter a different account. And you can also try to intercept a request on a certain page and try to change the encoded value of basic and basic in the authorization header in order to switch the account. That might work too, you never know. Okay, awesome. This was yet another simple example, and in the next video, we're going to take a look at the example of broken authentication once a user forgets a password. Nonetheless, thank you for watching, and I will see you in the next lecture. Okay, let's take a look at another example of broken authentication with the forgot password. Now, an example of this, we're going to take a look at our webcode. We introduced ourselves to the webcode in the previous video, and now we're about to do another challenge using this application. So let's click on OWASP webcode. Let's log in with guest and guest. Now we can log in with any account that we want. We know that there is an OWASP account, and we also know that there is a basic account. But it doesn't matter for this task. All we have to do is start our webcode right here and navigate to the authentication flaws and then forgot password. Okay. Now, let's read through the task. Web applications frequently provide their users the ability to retrieve a forgotten password. Unfortunately, many web applications fail to implement the mechanism properly. The information required to verify the identity of the user is often overly simplistic. Okay, let's take a look at the general goals. Users can retrieve their password if they answer the secret question properly. There is no lockout mechanism on this forgot password page. Okay, and that is the first vulnerability. Every time a page should block an account or block an IP address once they type the secret question incorrectly for 3 or 5 times, and also once they type the password incorrectly for multiple times. Then the page should lock you out or block you for a certain period of time. And that is a good practice against brute force attacks that we're going to take a look at in the next section. But for now on, let's solve this challenge. So webcode password recovery. Please input your username, cd OWASP admin if you do not have an account. Required fields, username. Now, we already know of a couple of usernames, but for this video we're going to try to brute force a username. We will use a list of most common usernames in order to see whether this application has a username like that. So how are we going to do that? Well, it's rather simple. Let's type anything right here. So for example, let's type test and we're going to intercept our request. Let's submit this HTTP request, and this is the one that we want to use. As we can see, we have a field called username, and that field we want to send to intruder. Let's turn off the intercept. Of course, we are going to get not a valid username because test account does not exist on this page. But inside of our intruder, we can set our payloads accordingly in order to try to guess a username. Okay, let's clear out all of the fields. And this can be considered a semi-brute force attack because we are going to try to brute force a username as well as the secret question. Okay, first of all, we want to select the username field. I select it by clicking on add, and now we want to go to payloads. Here we want to load a list of most common usernames, and luckily our Cal Linux actually has some word lists that can help us do this. All we have to do is click on load and navigate to the word lists directory. So make sure that you go first to the / directory, then to the user, right here. Then let's go to share. Then let's try to find word lists directory, which is right here. In the word lists, I'm going to go to Metasploit, and from here I can choose the best list that fits this challenge. And for this, I'm going to go with http default users.txt. I'm going to double click on that, and it will load these usernames right here as my payload list. Okay, awesome. all we have to do right now is start the attack. And how are we going to know which username is correct and which isn't? Well, usually it's rather simple, and I will show you in just a second how we can recognize it. Okay, our username brute force has finished, and here are all of the results. As you can see, for each of these usernames we got status 200. And there's not really anything right here that says which username is correct and if we even found a single correct username out of these ones. But if we take a closer look at the length of our response, which is right here, this number is the length of our response, you will notice that all usernames have the same length except this one, except the admin username. Usually this is an indication that there is something different with this type of username because it gave a different response than the rest of these ones. So the next thing that we can do, we find the username with a different length, we right click on it, we request or show response in browser. Then we copy the link and navigate to that link inside of our browser. And here's the secret question. Since we got the secret question, that means that we found our existing username. And the secret question is, what is your favorite color? As you can see, this is a really bad question for security because there are like 10 colors in existence and we can easily brute force that the same way that we brute force the username. So let's do that right here. We're going to go to our Burp suite. Let's go to our proxy and turn on the intercept. Right now we're going to type test once again because we don't really care what we write right here. All we want is to send this HTTP request to the intruder. Turn off the intercept and let's navigate to our positions. Let's clear all of these fields and let's only double click the color field and click on add. Now we go to payloads and here we can manually type the colors. For example, let's go for green, blue, yellow, and let's type every single color that we can think of. Let's go with green, let's go with black, white, and let me see, brown, perhaps, and maybe I forgot something, but let's give it a try with these colors first. So we loaded 9 payloads or 9 colors, and if we start the attack, we're pretty much looking for the same thing. We're looking for a color with a different response. But here we actually got more than 2 lengths. We got colors with this length, we got colors with this length right here, and we got a single color with this length, which is 31973. And usually this is the one that you want to check first because it has a unique length, which usually means that it's the correct one. So let's right click on green and let's show response in browser, copy this and navigate to our Firefox and paste the link. And here it is. We successfully guessed the username as well as the secret question for this account. So what exactly was a vulnerability here? Well, there are 2 things wrong with this. The first thing is that it doesn't block us after certain incorrect requests. And the second thing is that the secret question is rather easy and we guessed it in 2 seconds. Now we have finished this challenge and we have username admin, color green, and here is the password for the admin account. Okay, awesome. We have one more challenge or one more example left to do from our OWASP WebGoat application, and after that we're going to move to the brute forcing section. See you in the next lecture. Okay, the last task for us for this section is something called session fixation. And we got a pretty good example of it inside of our WebGoat application. To navigate to it, make sure that you go to Session Management Flaws, and under here you want to click on Session Fixation. And here is our challenge. So let's see what it says. We got stage 1, you're Hacker Joe, and you want to steal the session from Jane. Send a prepared email to the victim which looks like an official email from the bank. A template message is prepared below. You will need to add a session ID, or shortened SID, in the link inside the email. Alter the link to include a session ID. Okay, and we already mentioned or talked briefly about session fixation. It's simple as predetermining a session ID for someone, then that someone clicks on our link with a predetermined session ID, they log into their account, and we can access their account because we do know their session ID. And this is an example of how we can do that. Let's see what we need to do. So here is an email, and in this email we have this sentence right here. Please use the following link to verify your account data. And here we have the link, which is in the href statement. So href equals webgoats/attack, and here are some parameters. Now, the first thing that I noticed is that this webgoat is written incorrectly. We need to type capital W and capital G, the same way that we have it right here. The second thing that is more important is us adding a session ID. And a session ID is simply a link parameter. So we already see some link parameters, and they're divided by this character right here. So all we need to do is to copy that same character and add another parameter at the end. Let's Ctrl V to add this character, and then add our SID parameter by typing SID equals, and here we can pretty much type any session ID that we want. For example, let's go with 555. This is the session ID that I've chosen. So now our altered link looks something like this. We have /webgoat/attack, and then these three parameters, which our last one will be the session ID. Now we as a hacker are sending this email to the victim. Let's send the email, and we completed stage 1. Now stage 2 is, now you are the victim Jane who received the email below. Okay, so now we're acting like Jane. If you point on the link with your mouse, you will see that there is an SID included. Click on it to see what happens. Okay, so let's pretend that this is the email that we got, and here's the link that we altered. Let's say that the victim clicks on this link, and it leads it to a page where they can log in. Now here, luckily, we got our username and password for the victim, which the username is Jane and password is Tarzan. So let's type that in right here. These are the correct credentials that, of course, the hacker wouldn't know, but we're acting as both the hacker and the victim in this challenge. And let's log in. And we've completed stage 3. It is time to steal the session now. Use following link to reach Goat Hills Financial. Okay, so in this challenge we're Hacker Joe. And if we go to the link, now we need to log into the session. But we as a hacker don't really know the correct credentials, so we can type anything right here and see what type of link do we get. Just by looking at this link right here, we already see that there is a session ID parameter within the link that says no valid session. Let's give it a try. I'm going to go right here and turn on my intercept. And I'm going to type in test as username and test as password, which is of course incorrect, but all we want to do is to intercept this request. Right now, we want to change this session ID to the number that we sent to the victim, which in our case, or in my case, is 555. We don't need to alter anything else. We can leave the incorrect details, and if we forward this packet, go back, we have successfully logged in as Jane, just by changing the session ID that we sent to the victim over that email. And that is the end of the challenge. As it says, congratulations, you have completed this lesson. Okay, awesome. We have covered some of the basic attacks over broken authentication, and in the next section we will continue just with different types of the attacks that we call brute force attacks. Nonetheless, thank you for watching, and I will see you in the next lecture. Welcome back. Time to perform our brute force attacks. We're going to cover a couple of examples of brute force, whether with Burp or some other tool, but nonetheless the principle behind them is always the same. We want to use lists with bunch of usernames and passwords to try to guess credentials of a certain account. So this doesn't always work. Matter of fact, it usually won't work unless the target has a common username or a weak password. The first example that we will cover is going to be with our Burp suite intruder. We already saw a couple of examples of using intruder, but right now we're going to take a look at a different approach to this attack. So first that we want to do is we want to navigate to this application that says OWASP Bricks. Click on that and it will lead us to this page. Under the Bricks tab, we will have a sub-tab that says Login Pages. Click on that and here we will have multiple login pages that we can practice on. Now for this example we're going to go with login number 1, and then if you want you can practice on the rest of the logins. The steps to performing this attack will be the same for each challenge right here. Okay, let's navigate to login 1 and we have a simple login form. If we type test and test, it will tell us wrong username or password. Okay, let's intercept this request right here inside of our Burp suite. And let's send it straight to the intruder. Here we can turn off the intercept right afterwards and let's navigate to our positions tab inside of our HTTP request. So down here we have our username and password field. Now before, when we used intruder, we used this attack type sniper and we only targeted one field. Right now we're going to target two fields at a time, the username field and the password field. So let's first clear all the other payloads and let's double click on username, click on add and double click on password and also click on add. Under the attack type we want to switch from sniper to cluster bomb, and if you remember correctly, the cluster bomb is the attack type where we can use multiple payload sets in order to perform the attack. In other words, we have multiple input fields that we want to brute force, the username and the password field. Now let's go to the payloads tab and it looks rather the same, just this time we have payload set 1 and we can also choose payload set 2. The first one is the username payload set and here we want to load a list that contains the usernames. Now in a real life scenario you would use a list much bigger than we use in our examples, because for this attack we're going to use the HTTP default users again, which is in our word list directory inside the Metasploit directory. This list only has like 14 common usernames, but this is just to prove that the attack works. In reality, you would use a much bigger list. Once you select it right here, click on payload set and select payload set number 2. Under the payload set number 2, we want to load HTTP default passwords. In other words, it's called HTTP _default _pass.txt. Double click on that and it will load 19 common passwords right here. If we just do this and we start the attack, as it says right here, it will have a number of 266 combinations. So this will take a minute or two to finish, but as soon as we start, we notice something strange. Every single request or every single response almost has a different length. So how are we going to determine which username and which password is correct? We need some other approach. So let's close this for just a second. We're going to stop this attack and let's go back to our page. Once we typed in the incorrect username and password, we got this message right here. So maybe we can use something like this to determine which username is incorrect and which password is incorrect. Let's go back to Burp suite, and if we navigate to Options tab right here, we're going to see this option that says grep equals match. These settings can be used to flag result items containing specified expressions. So let's clear this list and let's perhaps add this statement right here. So in other words, what this means, let me just paste it first, that it will flag each result that contains this sentence in its response. In other words, it should flag every incorrect username and incorrect password combination that it tries. Let's run the attack again. So go back to payloads and start the attack. Now you can see each of these usernames and passwords combination is getting flagged except one of them. we got this admin and admin combination that didn't get flagged, which means that the sentence of wrong username or password isn't contained in its response. This most likely means that this is a correct username and correct password combination. As we can see, the rest of them are all flagged. And it's still going with this attack, but we can stop it since we already found the correct username and password. In reality, this attack would take much longer with much more combinations of usernames and passwords, and even at the end you might not be able to find any correct combination. Nonetheless, let's give it a try to our correct combination to see whether it worked, and let's type admin and admin. Submit, and it worked. We successfully logged in, as it gave us right here. Now you can try this on other examples as well inside of this Bricks application. However, in the next video we're going to take a look at a more useful tool for brute force attacks, which is called Hydra. Okay, so we've used Intruder from our Burp suite to perform brute force attacks. But now it's time to move on to the more advanced tool specifically made for these type of the attacks. And that tool is called Hydra. Now, I said it was an advanced tool, not because the attack itself is hard to perform, but because the syntax for that tool can be a little bit tricky sometimes, and there isn't a unique command that you can run for every website in order to brute force it. So we're going to dissect the command and explain how can you craft one for specific pages. The first page that we are going to take a look at is going to be bweb page on our OWASP virtual machine. So navigate there, and as we can see here we have a login screen. And this is exactly what we need in order to brute force. Now keep in mind that we do get the correct credentials right here, which is useful for us to practice this attack. So we know that B is username and bug is a password, and this will work once we try to log in. But we want to see how we can get this as an output with the help of a Hydra tool and with the help of usernames list and passwords list. Okay, first of all, to run Hydra, we can open terminal and type in Hydra. This will open its help menu, and this help menu will not be of much use to you once you're opening this tool for the first time. It might seem like it has little options and that it's easy to run, but in reality, once you're brute forcing HTTP pages, there are a few things that you need to take a look at. So let's start off with crafting our command. The first thing that we want to type is Hydra and then the IP address of the target that we are attacking. In my case, it is the OWASP virtual machine, which has an IP address of 192.168.1.11. The second thing that we need to specify is which type of the attack are we performing. So we know that we have GET request and POST request. We can either specify the username and password right here with a GET request or with a POST request. And what will help us determine which one it is if we simply go to View Page Source and we find the form that is used to submit username and password, which is right here, we will notice that the method is POST. So we're submitting the username and password with POST request. Okay, let's go right here and let's type that after our IP address. In Hydra, in order to type that, we type http-form-post. If it was a GET request, you would type http-get-form. Simple as that. So those are the two options that you need to keep an eye on, and usually you will have them inside of the page source of the form that you're trying to brute force. The next thing that we need to specify is the path to the login page. Now, in order to get the correct path, we want to type any username and any password, so I'm just going to type test and test and click on login and see what do we get. So we get invalid credentials, and it's under the path /bweb/login.php. We want to copy this path and we want to specify it in our command. in order to specify it, first thing we need to do is open double quotes. After that, we paste our path and we add 2 dots. Now, why are we adding 2 dots? Well, in Hydra, there are a few things that we need to specify. The thing number 1 is the path, which we specified right here. The thing number 2 is specifying the name of the username field, the name of the password field, and the button itself. Now, I know this sounds confusing, but we will do it right now. Hang on for just a second. That's the second thing. The third thing that we usually specify inside of our Hydra command is which error message do we get once we specify incorrect username and password, which in our case is this one right here. And at the end, we add the users list and the passwords list. Okay, so let's go back to the command. We specified at the beginning of the command, and we specified the first thing that comes in double quotes, and that is the path. Now comes the name of the username field, the name of the password field, and the name of the button. So in order to get the name of those fields, we once again want to go to the page source and we want to navigate to the form. Here we want to find the code that identifies the username input, and it's right here. If we take a look at the name tag and ID tag, we will notice that it's called login. So this will be the name of our username field. In order to specify that, we're going to type login equals, and then comes this arrow that is pointing upwards. After this arrow, we want to specify capital user, and then again this arrow that points up. Okay, what did we do right here? Well, the first thing that we did is we specified the name of our username field, and this part right here is just the syntax that tells Hydra to replace this user tag with the usernames that it will read from the usernames list that we will specify at the end of the command. So essentially it will just replace this with all of the usernames that it's trying to brute force with. Same thing goes with password. Now before we specify password, we need to type this sign right here in order to separate these two fields. And now comes the name of the password field, which we can read from the page source, and it's right here. We can see that the name is just password. So let's specify it like that. Password and equals upper arrow, pass, and then upper arrow once again. So the idea is basically the same for the password as well. It will replace the passwords from the list with this pass right here. And we want to separate it once again. And the last thing that we specify is the button itself. So we need to find the button code inside of the page source, and it's right here. As we can see, the name for the button is called form, and the value is equal to submit. So what we want to do is we want to go right here and type form equals submit. That will tell the Hydra tool that once it replaces the username and password, it has to click on a button in order to submit them and check whether they are correct or not. Now that we've finished with the second part of this command, we can go on to the third part by separating it with 2 dots once again. And we need to type the string that we get once a password is incorrect. And we have it right here. We can copy it, invalid credentials or user not activated. Let's copy that string or that message and we can paste it right here. Once you do that, you want to close the double quotes, and at the end, we specify the usernames list and the passwords list. Now, since we don't have one yet, let's just open another terminal, type ls and nano users.txt. Here we can type any usernames whatsoever. Let's go test123, root, admin, and let's add the correct username just so we can see whether the tool will work and whether it will manage to find this to be the correct username. Let me just double check. Yeah, B is username and bug is password. So we will be adding the correct credentials in the list just for the purposes of this tutorial in order to see whether it will work. In reality, of course you wouldn't know the correct credentials and you would use much bigger lists than this. Okay, let's add, for example, admin123, and that would be about it for our users.txt. Now let's go and do same for the pass.txt, and here will be our passwords. So let's go password, pass123, password123, let's go with bug, which is the correct password, and let's go with test1234. Okay, save this as well. And now we go back to our command where we need to specify that we want to use these two files in order to brute force. To specify the usernames file, we type dash and then capital L. After that comes the name of the file, which in my case is users.txt. And after that we specify capital P for the passwords file. And then the name of the passwords file, which is pass.txt. Okay, this is the entire command, and I know it might sound confusing and you probably have no idea what we did right here, but don't worry, this is the same reaction that everyone has once they first encounter the Hydra tool. And we will be taking a look at another example of crafting the Hydra command for a different web page in the next video. For now, let's go through this command once again and explain what we did. So first we type Hydra, then the IP address of the target, then which type of the brute force we want to perform based on how the credentials are being processed by the web page. Since they are processed with post request, we use http-form-post. If they were processed with GET request, we would type http-get-form. After that comes the double quotes part, which has three different things. The first thing, or the first part, is the path to the page that we want to brute force. The second part is the name from the username field, the name from the password field, and the button itself. And the third part is the string or the message that we get once we specify the incorrect username or password. This will help Hydra determine which credentials are correct based on this message. If we specify some credentials and we don't get this message, it will flag those credentials as correct ones and it will output it right here for us. At the end we specify dash capital L and we specify the users.txt file or any list that we want to use for usernames, and dash P and then the passwords file. Okay, let's press enter and see whether this command will work. And you will notice in just 1 second we managed to perform all of the combinations of usernames and passwords. And we got the correct one right here. So not only did this finish much faster than Burp suit Intruder, but it also outputted our correct credentials in clear text right here. Let's give it a try and let's try to log in, B and bug, and click on login. And here we are. We logged in successfully. Awesome. So once again, this is a little bit complicated, but don't worry, in the next video we're going to check out another example of using Hydra on a web page. Thank you for watching and I will see you in the next lecture. Let's cover a second example of using Hydra on a web page. So in the previous video we noticed that the tool can get a little bit hard with the syntax. We brute forced the BWAP page, and now we're going to go with the DVWA page. So we're already familiar with this login screen. We know that the username is admin and that the password is admin. But we want to see how we can get that username and password with the help of our Hydra tool. Of course, since this is something that we do for the educational purposes and we want to prove that it works, we will be adding the correct username and password in the users and in the passwords file. So in the users file, from the previous video, we already have the admin username. And in the passwords file, we want to add the admin as a possibility right here. So let's add admin. And now once we craft our Hydra command, we should be able to get the correct credentials outputted for us. Okay, time to craft the command, which is the hard part of this tool. As we remember from the previous video, the first thing that we do is we specify the IP address of the target that we want to scan. Once we do that, we determine whether the credentials are being submitted with post request or with GET request. To do that, we can go to the page and go on page source. Then, once again, we want to find the form where the usernames and passwords are being submitted, and here we will see that it is once again a post request. Okay, awesome. So we're using HTTP form-post. After we specify this, we open double quotes. Now comes the hard part. We need to specify first the path to the page that we want to brute force. So let's type in incorrect credentials, click on login, and we get this path. So /dvwa/login.php. Let's copy it and let's paste it right here. This is our first parameter inside the double quotes, the path to the page. Now comes the name of the username field, the name of the password field, and the button name, as well as what to do with the button. So once again, go back to the page source and find the code where the username field is being labeled. Here it is. If we take a look, right here the name of the username field is simply username. So we will type that in. Username equals, then we type upper arrow, user, upper arrow, and then the sign to separate it from the password. Now we want to find the password field. Here it is, right below the username field, and the name for it is password. So let's type that in inside of our command. Type in password equals upper arrow, pass, upper arrow. Okay, awesome. And the last part, which we once again separate with this sign, is the button itself. Let's go all the way down, and here is the button. The name of the button is login, and we submit it right here. So we're going to specify that as login equals submit. And this will once again tell our Hydra command to submit the username and password once it types them in. And at the end, we have a third option for our double quotes parameter, which is going to be the incorrect message that we get for incorrect credentials. Since we typed in test and test as username and password, we got this message down here that says login failed. So let's copy it straight away and let's add it to the end of our command. Paste to clipboard and close the double quotes. This should be enough for Hydra to be able to brute force the page and also determine which credentials are correct and which are not. At the end, all we're left to do is specify capital L for the users list and capital P for the passwords list. And this is our entire command. Let's give it a try. If we run it, give it a couple seconds, and it finishes the brute force once again in around 1 second time. We get the correct credentials right here, which are admin and admin. So we successfully brute force this page, and if we want to, we can log in right here. Awesome. So we covered Hydra tool. Now we are officially done with the brute force part of this course. But in the next video, I also want to show you another possibility with Hydra that you can use besides brute forcing different web pages. It will be a short video and you might find it useful in your penetration tests. Nonetheless, thank you for watching and I will see you in the next lecture. Okay, just a quick video before we finish this section. I want to mention one thing about Hydra. Now, Hydra is a powerful tool, and it's not only useful for brute forcing web pages. It can be used to brute force different services as well, such as SSH, FTP, and others. And in this example, I just want to show you that if we take a look at our OWASP virtual machine and we scan it with Nmap, using -f command, which will scan most known 100 ports, we will get this output. And if we take a closer look at scan results, we do notice that the target has port 22, or in other words, the SSH port open. So we can try to target the SSH port with Hydra brute force attack. So let's give it a try. Now the first thing that you will notice regarding Hydra with SSH is that the syntax is rather easy, or much easier than once you're targeting web pages. all we need to do is specify the IP address, then we type SSH and then -l users and -p pass.txt. And this will run the attack on SSH port with these two lists. Now, since we don't have the correct username and password inside of these lists, it gave us an output that 0 valid passwords found. Now, let's add the correct credentials right here. The correct username is root, or we already have root, so we can just leave it like that. But correct password is OWASP BVA. So make sure that you add OWASP BVA inside of the passwords list. And if I run the command again, for some reason we get incorrect or not valid username once again. So perhaps we need to add another option. Let me just go to the help menu real quick. And let's try adding -t option, which default is set to 16. We're going to lower it just for the purposes of this command. So let's type it right here, -t4, and then SSH, and then users and passwords.txt. And here it is. We successfully found the correct login to the SSH port on the target machine. All we had to do is type Hydra, the IP address, -t4, and then we specify which protocol. In our case, we're using SSH, and then the passwords and usernames list. Now, if you wanted to check whether this is correct credentials, you can type SSH 192.168.1.11. Here you want to select yes, and pardon me, we need to close this because we're trying to connect to the Mr. Hacker account on the target machine, which is non-existent, so we must type SSH root and then add this IP address right here. Then we press enter. It will ask for the password, and here we type OWASP BVA as the password for the root account. Now we're logged in on the target machine over SSH, and we can execute any commands that we want on the target machine, such as ifconfig, such as whoami. We can type ls, we can change directories and see all the files on the target system, just because we successfully brute forced the SSH. From here, we can delete the entire website if we wanted to, we can delete the operating system, we can create files, delete files, and do pretty much anything that we want. Okay, I just wanted to show you this, that there is another possibility with Hydra besides just targeting web pages. Nonetheless, we're officially done with the brute force section, and in the next lecture, we're going to take a look at sensitive data exposure. Okay, I want to quickly discuss what could possibly be the easiest vulnerability to exploit. There is something called sensitive data exposure, and it's exactly as it says. It's vulnerability that developers make by exposing some unwanted information in the web page. Now, sensitive data exposure can be something as trivial as showing the application version, but it can also be something as big as exposing perhaps entire database in the web application. And anyone with a little bit of knowledge is going to be able to access it if they want. So it can be a big vulnerability. Now, these type of data exposures don't occur that often, however, you will find them from time to time. Usually, the data will be exposed in the source code itself from the web page. Perhaps multiple developers worked on the website and they left comments for each other in the code regarding some web page details. But if you come across to something like this, well, then there are two possibilities. Either the developer didn't take a single look at the web page before putting it online, or it's made there purposely as a honeypot. And honeypot is something used to catch hackers. Nonetheless, it's most likely going to be the first thing, that the developer forgot to remove his comments from the code. As we can see in this example, there is a comment that says, hey, I put the passwords file in /data directory. Now that could possibly be left for another developer that is going to take over the project. and maybe before they put out the entire website, they forgot to remove it altogether. Now, the plan of the attack is simple, and it goes like this. We search through the code and through the web page. If there is sensitive data exposure, we might find something useful such as hidden directory or an admin page, or perhaps a database. And we use that data to then gain access to things that shouldn't be out there for public to access. Let's see a simple example of this with our Try Hack Me platform challenge. So right here I have navigated to my OWASP challenge inside our Try Hack Me platform, and under the task number 8 we have sensitive data exposure. Now I have already set everything up, I have started my machine, here is the IP address of the machine. If you want, before you do the challenge, feel free to read through all of this and make sure that you read through other parts as well, because the sensitive data exposure has 4 parts. It has task 8, task 9, task 10, and task 11. Now, under the task 11 are our challenges, which we're going to do right now. So, as it says, it's now time to put what you learned into practice. And there's not much to do right here. We just want to copy the IP address and paste it right here. And it will load the page for our challenge. So we can already see that the page is simple. It has some text right here, an image, it has a login button, and it has this button right here that says Sense and Sensitivity. We can click on all the buttons if we'd like, just to see what happens. So if we click on login button, it will lead us to this page where we need to specify username and password. And if we click on this, it will just go back to the main page. Let's try to find sensitive data exposure. If we read through this text right here, we won't really see anything useful for us. As well as on the page itself, we don't really see anything that could potentially give us some more detail than we should have. So let's take a look at the source code. We right click and go view page source. So we take a look at the code. It's just a simple HTML code. We got some directories right here, /login, /assets. And that would pretty much be about it. We don't get any comment whatsoever. Now, we will want to visit these directories in order to see what files perhaps are there. But before we do that, let's also go to the login page and view page source on this page as well. And here we have one comment that says, must remember to do something better with the database than store it in /assets. And remember, /assets is that directory that we saw from the first code, and it appears that they've stored the entire database in that directory. So if we can access it, we have sensitive data exposure, but of course this is to the extreme part. You will rarely see something like this happen, although it does happen sometimes. So let's go to the /assets. And here it is. We got all the regular files such as JavaScript files, PHP files, CSS files, and we also have webapp.db, which stands for database. We can download this file if we want to, save it on our machine, and then we can go through their entire database in order to find out some information, perhaps about users, about their private data, and other things as well. And we're going to do that right now. So let's open a terminal. Let's navigate to the downloads directory where we downloaded our webapp.db. And in order to navigate through this database, we can type the command SQLite 3 and then webapp.db, which is the name of our database. We press enter and it will open this SQLite interpreter where we can type in our SQL code. So first thing with this database, we want to see all of the tables that it has. And we can do that by typing the command dot and then tables. If we press enter, we get two output right here that says it has sessions table and users table. We're more interested in this users table since perhaps maybe there are passwords there. So what we can do is we can run the SQL command to select everything from this table. And the command would go like this: select star, and star simply just stands for everything, and then from, and then the users. let's not forget the semicolon at the end, and if we press enter, we get this output right here. Now, before we discuss this output, let's go back to our task and see what we need to submit. So the first thing that it asks us is what is the name of the mentioned directory. We can already specify the answer, which is /assets, submit that, and it's the correct answer. It says navigate to the directory you found in question 1, what file stands out as being likely to contain sensitive data. And in our case that is webapp.db. Let's submit that as well. And use the supporting material to access the sensitive data. We already did it. And the question is, what is the password hash of the admin user? So could it be that these are the password hashes? Well, they most likely are. We're in the database, and usually databases store passwords in hashed value and not in plain text. So we can copy the hash and specify it to see whether it's the correct answer for the user admin. Let's go right here and paste the hash. And it's the correct one. Now it asks what is the plain text password from this hash, so we must crack it first. We can do that with the help of an online website. We can navigate to a website like crackstation.net. And here we can type in our hash, which hopefully will get cracked by this website. Down here it says which hash types does it support, and they probably have a huge database with a bunch of plain text passwords that they run our hash against and see whether they found a match. So let's paste our hash right here. Let's click I'm not a robot. Let's select all the bridges, verify, and let's click on crack hashes. And we get the output. Our hash is the type of MD5, and in plain text it is QWERTY UIOP. So this is the password in plain text for the admin account. Let's copy it, go back to our page, and let's type admin and then the password that we just cracked. And here it is. We found the flag for our challenge. Now we can submit both the plain text password and the flag right here. Awesome. So this was an example of sensitive data exposure. And we're not going to take a look at more examples because this is pretty much what it will always be. You search through the web page and through the code. If you find something useful, you use it to gain access. If it's, of course, something as big as database exposure or passwords exposure. In other words, this is not a technical vulnerability, it's strictly bound to developers making a mistake and leaving something out there for public to see. Nonetheless, thank you for watching, and in the next lecture we're going to tackle another vulnerability type which is called broken access control. See you in the next lecture. Okay, broken access control. What type of vulnerability is this? Well, before we define it, let's first see what access control itself is. Access control is how web application grants access to content and functions to some users. Notice that I said to some users, so not all of them. Access control is part of the application that decides who gets to see which content and who doesn't. Sometimes access control can be strictly tied to authorization and session. And in some cases it might even be the exact same vulnerability as broken authentication, which we already covered. However, there is more to it than that. Once we covered broken authentication, we mostly focused on breaking the session and the authentication of the user. Broken access control, on the other hand, can also target not only sessions, but for example, different files or directories on the web page. Perhaps some users have access to certain files that are on the web page and the others don't. If the access control is not performed properly, we could also get access to those files. Same goes with directories. Perhaps there are some directories that are only meant for admin to use and visit. but they have no access control and can easily be visited by adding the directory name to the link. This is also a broken access control vulnerability. Besides different files, it might also allow us to see other user information. Now, all of this is once again due to developers' mistake. If the access control is not implemented properly, then you might have the broken access vulnerability. And it could look something like this. Let's say we have a random site that has a function to choose a file and perhaps download it on your machine. Choosing a file should have its own access control. We can assume that this randomfile.php is stored somewhere on the server. But so are all the other files that we don't have an option to download. So have they implemented a good and valid filter that will only allow us to download the files that they offer? Well, we can find out if we try something like this. What if we type, instead of randomfile.php, we type in /etc/passwd. If we get the output of the passwd file, or if it downloads it to our page, we have an example of broken access control. We downloaded something that we should not have been able to. This type of vulnerability can also be called IDOR, or in other words, Insecure Direct Object Reference. This vulnerability occurs when an application uses user-supplied input to access objects directly. And we will see more examples about it in the practical lessons. So let's first of all start with our TryHackMe platform. Okay, here we are on our TryHackMe platform, and we have the broken access control challenge, which is task number 18. Now, as usual, I advise you to read through all of the broken access control tasks, which in this case is task number 17 and task number 18. I have already started the machine. Here is the IP address to the machine, and now we need to perform these challenges right here. So let's first of all navigate to this page by copying the IP address and pasting it right here. So note viewer, what user are you? And we have the field to log in with username and password. Let's check whether they supplied us with some information as to how to log in to this page. And here it is. The username is newt and the password is test1234. Let's type that in. And let's submit this. And it gives us a rather simple page that only types out I am newt with the exclamation mark. But if we take a look at the link, we have this parameter right here that says note equals 1. And this is the parameter that we can try to tamper with. We can conclude that this parameter could have something to do with the user ID, for example. Maybe this parameter that equals to 1 is strictly made for our newt account. So what would happen if we change it to 2? Well, we don't get anything. What would happen if we change it to 3, for example? We still don't get anything. Let's try changing it to 0. Press enter. And here's the flag. We got the flag from a different account, which means that we have an example of broken access control vulnerability on this virtual machine. Now, this was rather easy. All we had to do is change this parameter right here, but it's all possible due to them not filtering our input correctly. They don't have any control over this parameter as to what the user can do with it. In real web applications, this input right here should be very well filtered that if you try to change the session or try to change the user ID, it just goes back to your own account. It doesn't let you see the information from different users. And in our case, this is our flag that we need to specify as the answer. Look at the other user's note and let's paste the flag, submit it, and it's the correct answer. Okay, so this was rather easy. Now let's look at some a little bit more difficult examples on our OWASP virtual machine. See you on the next lecture. Welcome back. Let's see another example of IDOR vulnerability. So in the previous video we saw a simple example of tampering with one parameter in order to change the user ID, or in order to be able to see private information from a different user. Right now let's see what examples can we get on our OWASP BVA. So first example that I want to show you is on OWASP Mutil 2. So let's click on that. And here, as usual, under the OWASP 2013, we will have this vulnerability that says insecure direct object reference, or in other words, it's the IDOR vulnerability. This is an example of a vulnerability that I showed you in the theory lecture. Now let's put it to practice. Let's go to any one of them. So for example, let's go to source viewer. And in this simple page, we have a source file name to select, and it tells us to see the source of the file, choose and click view file. Note that not all files are listed. Okay, so let's choose any one of them. For example, let's go with register.php, click on view file, and it gives us the output of this PHP file. So pretty standard, but once again, remember from our theory lecture, we must ask ourselves the question, is this or are these files that we have in this list the only files that we can read? Well, in this box we can't really type any other file name, however, we can intercept this request with our burp suite and try to change the file. Let's go to our burp suite, turn on the intercept, and let's select any file whatsoever. Let's go with login.php and click on view file. So we intercept the request right here, and down here in these parameters we have the PHP file parameter that selects which page we want to view. Now since we can't really type it in right here, we're going to type it in inside of our burp suite. So let's delete login.php and let's for example type /etc/passwd. Let's see if this will work. If we forward this packet, turn off the intercept, go right here, well, here it is. We have the output of the @c/passwd folder. And once again, that is the broken access control vulnerability. We got the output of a file that we shouldn't be able to see. Now, same goes with this parameter right here in the page. This is simply just parameter that selects which task are we currently doing. So if we go to insecure direct object, you will see that the page name is source viewer, and it probably has some PHP file that processes this page. But we can also try to go and perform broken access control right here. If we type /@c/passwd for this parameter, well, we get another output and another broken access control vulnerability where it outputs once again the passwd file. And it's the same with all the other examples. So for example, if we go to cookies right here, we can inject our @c/passwd right here in this page. Oops, I misspelled passwd. And once again, here is the output of the @c/passwd file. So this type of vulnerability is not that hard to perform. Of course, it might have some filters that might protect it to some extent, and those filters we're going to see in the next video with a different example. However, usually once you have this vulnerability, it will most likely not have any access control whatsoever, therefore you will be able to access different things that you shouldn't be able to see. Okay, awesome. Thank you for watching this lecture, and I will see you in the next lecture. Welcome back. Let's discuss another IDOR example inside of our OWASP BWA machine. So in the previous lecture, we took a look at the IDOR challenge where we changed the file that we want to view to /@c/passwd. And that way we displayed the file that we shouldn't have been able to access. Now let's take a look at a different type of IDOR challenge inside of our BWAP application. Click on that, And as usual, let's log in with our credentials, which are B and bug, and click on login. We have our current security level set to low, and we're going to leave it on low for now, and let's choose our bug. So navigate to either challenges, which are right here, and out of these three, we're going to go onto this one, which says insecure door order tickets. Click on hack, and it will lead us to this challenge. So it's a simple application. It asks how many movie tickets would you like to order, 15 euro per ticket, and here we can type in how many tickets we want to order. For example, if I want to order 10 of them, and click on confirm, it will tell me that I have ordered 10 movie tickets and that the total amount charged from your account is 150 euro, or simply 10 times 15 euro per ticket. Okay, let's see whether we can manipulate this and perhaps change the price. So first thing that we're going to do is we're going to turn on our intercept, and here let's go with 10 tickets once again. I will click on confirm, and this is the request that we get. Down here we can see all of the parameters that are being submitted with this request. So we have the ticket quantity equals 10, we have ticket price equals 15, and the action equals to order. Now this is a constant. We know that the price of a ticket is 15. So perhaps with the either vulnerability, we can try to change the price of this ticket. So instead of 15, let's just leave it on 1. Let's make the price to be only 1 euro. And let's see whether this will work. If we forward this request, go back to our page. Well, here it is. It worked successfully. We ordered 10 movie tickets, and the total amount that was charged was 10 euro. So we pretty much ordered 10 tickets for the price of 1 euro per ticket. Let's also see how this would look on medium security level. Let's click on medium, and let's click on set. Oops, we still have our intercept turned on. Let's turn it off and let's go back to our page. And now let's see how our application is acting. So if we once again specify 10 tickets and we click on confirm, well, it doesn't really appear that anything changes from the low security level which we had previously. We still get the output, you ordered 10 movie tickets and the total amount charged is 150 euro. But let's see, are there any differences in the HTTP request once we intercept it? So let's turn on the intercept. Let's once again try to buy 10 tickets and let's confirm it. And this is our request. You will notice that we no longer have the ticket price parameter inside of our request. So how are we going to change the price now? Well, we can take a look at this ticket quantity. The ticket underscore quantity is a parameter for how many tickets we want to buy. And we can assume that perhaps there could be a ticket underscore price parameter that could be set to the price of a single ticket. So maybe we can try to input it ourselves right here and see whether that would work. As we can see, these parameters are being separated by this sign, and let's give it a try. If we type that sign and then ticket underscore price equals 1, let's try to set it to be equal to 1. Let's see if us injecting the parameter manually will make any changes on the page. If we forward this, go back, and there it is. We made this work successfully. We ordered 10 movie tickets for the price of 10 euro, and once again we managed to perform the either vulnerability on medium level. Now on high level, I believe all of these applications actually show the secure code, so I'm not sure if it's possible on high level, but let's give it a try. Let's confirm with 1 ticket, and the price for 1 ticket is 15 euro. Now if we intercept that, well, we get pretty much the same response as from the previous medium security level. So if we try the same thing ticket price equals to 1 and we forward this, well, it won't really work. And this is because high level is usually a secure version of these applications. But we can always do something like this. If we have intercept turned on and we go on confirm, what we can do is we can try something like this. So let's inject ticket price to be equal to 1 and let's change the security level to be equal to 0. Now if we forward this, well, now we once again changed the price to 1. But we cheated a little bit. We exploited a different parameter inside of our request, which changes the security level. Nonetheless, this is another example of either challenge, and in the next lecture we're going to take a look at a security misconfiguration vulnerability. Welcome back. Let's discuss security misconfiguration. Now, in this lecture, we're going to check out default credentials vulnerability. Now, you might be asking, well, didn't we already do that? And isn't this something that belongs to broken authentication or brute force attacks or something like that? Well, it's a little bit different. We covered guessing default credentials and brute forcing pages of client profiles. Now we want to take a look at default credentials vulnerability for an application that is implemented in the web page. So this is not a user account on a web page or something like that, which a user sets up. This is something that the server owner and the web page owner sets up once using an application within a web page. So we have a simple example right here in our OWASP top 10 on our Try Hack Me challenge. And we're just going to cover it in this video, and then we will move on to a different vulnerability, because this is once again just default credentials vulnerability. It's rather easy to perform. All you need to do is try to find the default credentials for a certain application. Nonetheless, let's go all the way down, and here it is. Task number 19, which is security misconfiguration. Now, let's start our machine straight away. And if you'd like, you can go and read through all of this. We also see that it does mention default passwords as one of the security misconfigurations, whether it's once again from the user's perspective or from the server's perspective. In both ways, there shouldn't be any default credentials on the web page. However, this is something that developers are responsible for because they didn't really change the default credentials on the application that they host on their website and that anyone can access to. While our machine is starting, let's read through our challenge. This VM showcases a security misconfiguration. Deploy the VM and hack in by exploiting the security misconfiguration. Okay, so they didn't really tell us anything important. All they said is to deploy the VM and find the flag. Let's wait for a couple more seconds for our VM to start. And once we get our IP address, let's copy it, go right here and paste it. Okay, so this is the application that it opens. We have a login screen, we have swap theme, which doesn't really do anything, and we have change password. If we take a look right here, we also have this sign that says Pensive Notes. And it tells us down here, Pensive Notes, a note-taking app for people who like to think about their notes. So we already know this is an app. Let's try to perhaps Google it. We go Pensive Notes inside of our Google. And the first thing that we see is a GitHub project that is called Pensive Notes. Let's click on that. And we get the same message that we got on our web application. Pensive Note is a note-taking app for those who want to think and reflect about what they write later on. So we're on good place. This is the app that we're looking for. If we go to information and installation, down here we will find this sentence that says, after downloading and compiling Pensive Notes, log in using the default credentials, Pensive and Pensive Notes. So we found default credentials. Let's see whether they work on our application. If we type Pensive and then Pensive Notes, well, it does have default credentials, and we get our flag right here. So this is another security risk that could happen once a website is using some type of an application that has login form. This can also happen on something like Tomcat, on PHP, and all of the other services that website can have. Nonetheless, I just wanted to mention this is another possible vulnerability and that it differs a little bit from regular default credentials that a user on a web page can have. And now that we're done with this, we can move to the next vulnerability, which is called XSS. Thank you for watching, and I will see you in the next lecture.
Hey everybody, I want to take a quick break here. Go grab a coffee, grab a tea, just take a break from all the learning that you just did. And I want to talk to you quickly about imposter syndrome. It's this idea that you're not good enough, that things are too complicated for you to ever achieve what you want to achieve. You look at other people, at other industry experts, and you say, I will never get there. But it's just a symptom of learning. This idea of you not being good enough simply means that, well, you're just not there yet. Things take time. If you want to learn a valuable skill, well, it's hard work. That's why it's valuable. Remember how you felt on the first day of going to school, first day on a job. It's the same experience. But over time, with repetition, with practice, you get comfortable, you get experience, and you slowly start to lose that imposter syndrome. Now, this idea of an imposter syndrome is great. It means you're doing something worthwhile. So don't use it as a negative. Use it as an encouragement that you're doing something good, that you're learning and you're stretching your limits. So with this break, I want to propose that we do a quick exercise. I want you to stop the lectures, again, grab a coffee, grab a tea, and head on over to our Discord. Now, in our Discord server, if you've used it up until now, that's great. If you haven't, head on over to this server, and I want you to do something that I think it's super important to learning. And that is using what you've learned up until now to actually teach someone or help someone. So you can go all the way to, let's say, the coding and courses section and pick a topic that you want to help somebody in. So let's say you go to the Python channel. And in here, you'll have other students that are asking Python-related questions. Now, you can scroll through here and see if you're able to help someone. Even though you may not have the experience or the knowledge yet, this idea of practicing and explaining what you've just learned to other people, even if you're not 100% certain, actually is beneficial to your learning. Because if you're never teaching, if you're never explaining and vocalizing and showing what you've learned, you'll always be a beginner. This idea of teaching what you learn is a very important concept. So moving forward, as you go through the lectures, anytime you feel like taking a break, hop on over to Discord and help somebody. Our motto here is that we're always kind. We don't judge anybody. We're all just beginners here. We're all learning. So don't be afraid to answer things because you got to remember, nobody's perfect except for Yoda. Yoda is pretty perfect. All right, I'll see you in the next one. Bye-bye.
It's time we get started with biggest vulnerabilities or bugs on a web page. Now, by biggest, I don't mean most dangerous. However, these ones are still not something that you want to have on your web page. We will be starting in this section with cross-site scripting vulnerability, or also known as XSS. Now, you might have noticed that in the upper right corner, we have this JavaScript icon. This can give us a hint as to what this vulnerability is. So, let's explain it. First of all, XSS is very similar to HTML injection. Those two are executed almost the same way, and since we already covered the HTML injection, this will be a lot easier for you to understand and perform. XSS is based on injecting JavaScript code in the web page. As with the HTML injection, we're looking for a vulnerable user input field that reflects our output somewhere on the page. Once we find it, we try to inject simple JavaScript code to see how the page would react and whether it would execute it. One thing to keep in mind is that XSS is not a vulnerability that targets server. It is a vulnerability that targets clients that use that server. If we are able to inject our malicious JavaScript code in the web page, then that JavaScript code will also run once a different client visits that web page. Now, whether the client visits the web page directly or through a link makes a difference depending on what type of XSS vulnerability it is. And we will discuss different types in just a second, right after we discuss the process of why our JavaScript code executes on a vulnerable web page. So imagine we have this code as an example. It's the same code that we showed inside of our HTML injection, just this time instead of injecting HTML, we want to try to inject JavaScript. And the most simple thing we can run with JavaScript would be the alert function. Of course, once embedding JavaScript inside the HTML code, we must add the open script tags where our JavaScript code starts and close script tags where our JavaScript code ends. This is how the browser will know that it's JavaScript, so it doesn't try to render it as an HTML code. This code being a simple code that asks for someone's name and then reflects it on the page would look something like this once we inject our alert function. And if the website doesn't filter the input, it will process this as JavaScript code and we will get a small pop-up window which is tied to this alert function. That's when we would know that there is an XSS vulnerability. Of course, web page can also have filters that are not properly set. Usually a page can have a filter that says everything between the HTML tags where the user input gets reflected, process it as a regular string or regular text. To bypass only that filter, we could then do something like this. We can first close tags for that line and then run our JavaScript code. In this case, the end closing tag will get left out and it will no longer consider our script as being a part of the open pre-tags. Of course, this is all working considering there are no other input filters. Now, let's talk about two main types of XSS and how they differ. These two types are called reflected XSS and stored XSS. Let's explain reflected XSS first. In reflected XSS, we have an attacker injecting JavaScript code inside a certain web page. The web page processes that input as JavaScript and runs it, letting the attacker know that it's vulnerable to XSS. Then the attacker sends the link to that web page with the JavaScript code set as an input to the vulnerable parameter. Once the target opens the link, it will also run the JavaScript code on the vulnerable website. The XSS where the JavaScript code we inject doesn't get stored and saved on the server is called reflected XSS. On the other hand, stored XSS is the exact same attack, just this time our JavaScript code gets saved and stored on the server and on the web page. This can be perhaps a web page that offers comment section. If we inject JavaScript code in the comment section, it will run every time someone opens that page. And that's the main difference between these two. In stored XSS, target doesn't have to click on any link at all. They can just go straight to the web page and it will run nonetheless. The stored XSS is more dangerous since it doesn't require the target to open any links, they only need to go to that website. Now, besides these two, there is also something called DOM XSS, or DOM-based XSS, and it's an XSS attack where the attack payload is executed as a result of modifying the DOM environment in the victim's browser used by the original client-side script so that the client-side code runs in an unexpected manner. We will see examples of different XSS types throughout this section. Since this is one of the most common vulnerabilities on a web page, we will devote a little bit more time to it than to other vulnerabilities. Welcome back. Now that we learned what XSS is in theory, let's see different examples of how we can use and exploit the XSS vulnerability. We're going to start off, as usual, with our Try Hack Me platform. So, I already have my machine started right here. I have navigated to task number 20, which says cross-site scripting, and we have a couple of options right here, or a couple of tasks, should I say. We have to solve all of these challenges. And I also advise you, before you do that you can read through this theory part right here and maybe learn a thing or two more about XSS. Nonetheless, once you do that, copy the IP address of your virtual machine and paste it in your browser. Okay, so we got a simple page that has a login form, a register form, and it has some options right here where we can go to reflected XSS or stored XSS. Let's see what our first task is. The first task is to deploy the VM. We already did that. The second task is navigate to our IP address in your browser and click on Reflected XSS tab on the navigation bar. Craft a reflected XSS payload that will cause a pop-up saying hello. Okay, this sounds like a simple task. So let's go right here and let's navigate to the reflected XSS. As we can even see right here, our task is to create a payload that will pop up a message that says hello. And we can do that with the help of a JavaScript alert function. The same one that we covered inside of our theory video. So all we have to do is, let's first see what would happen if we type just test. So it will reflect it right here on the page. It will say you searched for test. Now if we type our JavaScript code, and the function that we use is once again alert in order to specify the alert message. In our case, the message will be hello because that is our task. And we close the script tags, we click on search, and here we have an XSS. It ran our JavaScript code and opened this window that says hello. Okay, let's click on OK, and we get our flag right here. So this is the flag to our challenge. Let's copy it. Let's go back, specify it right here and submit it. Okay, awesome. Let's close this and let's see what our second challenge is. So on the same reflective page, craft a reflected XSS payload that will cause a pop-up with your machine's IP address. Okay, so we pretty much use this same user input, so we know it's vulnerable to XSS. Now we need to run a different JavaScript code in order to pop up an IP address of the virtual machine. We can do that by typing this script right here. And let me just zoom this in, just so you can see it a little bit better. We run script, and then inside the script tags we type alert, and in between the brackets we specify window.location.hostname. And of course at the end we close the script tags. So this is how our script would look like in order to pop up the IP address of the virtual machine. Let's click on search, and here it is. We get it right here. Click on OK, and we will get our flag, which we specify as a result for our challenge. Let's go right here, paste it, submit it, and that one is correct as well. The second thing, or pardon me, the third task that we have is navigate to the same IP address in your browser and click on stored XSS. And we also need to make an account. So let's do that real quick. Let's close this, navigate to stored XSS. Remember, the reflected XSS only reflected our JavaScript code on the page, it didn't store it on the server. With the stored XSS, we're going to see an example of our JavaScript code being stored on the server. But before we do that, let's register as a user. We type test, and as a password we can use test1234. Let's register. And we are currently signed in as test user. Now we could have maybe used an XSS on this part right here as a username because it does get reflected on this page, but this is not a part of the task. that is something that you can try after we finish this video. For now, we want to navigate to stored XSS, and it appears that we have a simple comments application. If we type hello right here, post a comment, here is our username, and we said hello in the chat or in the comments. Now let's see what our first task is. We want to add a comment and see if we can insert some of our own HTML. So we're already comfortable with HTML and HTML injection, so this is already something that we know. We can try to type open header tags, test, and close header tags. And here it is. We also have the HTML injection, and the answer for this question is this HTML T4GS. Let's specify it as the answer right here. And let's move on to the last two challenges in this video. So on the same page, create an alert pop-up box appear on the page with your document cookies. Well, we already know that we're going to use the same alert function. So let's open our script tags. And in between the alert brackets, we want to specify document.cookies in order to alert us with our cookie values. We of course need to close the script tags, and once we submit this comment, we get our cookies right here. And this is also stored XSS. We will get our result or our flag right here, which for some reason I can't seem to copy. Let's try it like this, paste it, and it works. Now, if I refresh this page, you will notice that due to this being a stored XSS, this will pop up every time I refresh the page. And not only every time I refresh the page, but every time someone else visits this exact same page, they will get a pop-up with their cookie value. And that is because this is a stored XSS. A stored XSS gets stored on the server, and this value right here of our HTML injection and our value of our JavaScript injection or XSS vulnerability is also getting stored on the server and loaded every time someone opens this page. And that is the difference between the reflected XSS and stored XSS. This one we can say it's a little bit more dangerous because it's getting stored on the server. Now let's go with our last challenge. It says change XSS playground to I am a hacker by adding a comment and using JavaScript. We have the XSS playground right here, and we want to change this into I am a hacker. This can be a little bit tricky. We want to find the ID of XSS playground and we want to change it to I am a hacker. We can find the ID by going to inspect element. Then we want to navigate to this part right here, and it's in the navigation bar. Lower that, open our div tags, open our A tags for the XSS playground. Right here we should be able to find the ID of the XSS playground, and it's right here in this line. The ID equals THM-title. So that is our ID. Now I want to call it with our JavaScript injection. So let's go down here, open our script tags. Let's type document dot, and we're going to use query selector. And in between the brackets, we specify the ID of our XSS playground, since that is what we want to change. We need to specify it in between the single quotes, then we add a hash, and then the ID name, which is THM-title. So we change it like this, then we add dot, and then text content equals, and now we specify what we want to change it to. For our challenge, we must change it to I am a hacker. And at the end, we close the script tags. So this is our payload. If we specified everything correctly, it should change this XSS playground into I am a hacker. Let's click on comment. We get loaded with these values. And for some reason, oh never mind, it worked. We managed to change it, and now it says right here I'm a hacker, and we successfully completed the challenge. If we take a closer look at this page, we also get this right here, which is our flag. This is a flag that means that we successfully completed this challenge. Let's specify it right here, and let's submit it. Okay, awesome. I do admit this last task was a little bit harder, but we managed to get through it. We used the query selector, and then we selected the ID of the thing that we want to change, and we used the text content in order to write the I am a hacker sentence. Awesome. Nonetheless, we finished with try hack me example of XSS, and we're going to move to XSS examples inside of our BVA virtual machine. See you in the next lecture. Welcome back. Now I want to discuss a reflected XSS on our DVWA page. Now, there we have a certain level of security that we can set, and we're going to take a look at how we can bypass the medium security level on this page. The reason we're not covering the high security level is because in the latest updates, high security level is set to be impossible to hack. It's actually set to the correct code as to how secure pages would look like. Let's go to our DVWA. Let's log in with admin and admin. And here we first want to check what security level we'll have. Currently we have low. Let's leave it like that for a moment. And let's navigate to the XSS reflected. So we get a simple application. It asks for our name. If we specify test, our usual string, it says hello test. So we already see it's getting reflected on the page, and it becomes interesting for us to test for both HTML injection and XSS. Let's try with a simple alert function. So let's alert hello, and let's close the script tags. As easy as that was, we get our alert window pop-up right here that says hello. Okay, awesome. But let's give it a try on a medium level. Will that same example work on this level? If we change it to medium and submit, then navigate back to XSS reflected and type in the same thing, close the script tags, and I submit, we get hello alert and hello inside of our brackets. But where are our script tags? Well, perhaps they got filtered, and by this output we would assume that they did indeed get filtered and removed from our input. If we want to cheat a little bit, we can take a look at the source code that will tell us exactly what this page is doing in order to filter our input, and for practices that would be a good thing to do. Let's open this PHP code, and if we take a look at right here, here is where filtering happens. We're getting our script tags replaced with nothing. Interesting. But we can't run our JavaScript code without the script tags. So does this mean that this is a secure input? Well, not exactly. If we try to do something like this, and we type in capital letters script, and then alert hello, and we close capital letters script, we submit this, well, this worked. We only changed the lowercase letters into capital letters, and it managed to bypass the filters of this page, because by their PHP code, they're only replacing lowercase script tags with nothing. If we type uppercase script tags, then it will work. So how easy was that? And believe me, many pages have this type of a weak filter where they only filter some things and not all of them. Nonetheless, thank you for watching, and in the next video we're going to take a look at the stored XSS on DVWA page. Okay, we're starting off where we finished from the last lecture. We managed to bypass a simple filter on our XSS reflected page. But right now, we want to see how we can also exploit the XSS stored on DVWA. So navigate to the stored XSS, and this is the application that we have. it's a comment section. We type in our name and the message, hello world, and we sign the guestbook and it will add it right here on the page. We already know that these comments are getting stored on the server, so anyone loading this page will also see our comment. Same goes with the JavaScript code that we inject. Anyone loading the page will also load our JavaScript code, because we injected it straight into the web page storage. Now let's try on low level to execute our JavaScript. So let's go to DBA security. Let me change it to low and navigate back to the store XSS. Let's try to inject both fields. If I try to continue to type in the name field, it won't allow it. I guess it has some filter of how many characters we can input. So let's just try to go with test right here, and let's inject our JavaScript code or our simple alert function in the message field. If I sign my guestbook, and let me just load this a little bit more so you can see it better, then I click on sign guestbook, well, here it is. On low level, it's really easy to exploit, it has no filters at all, and all we have to do is type in our script tags, alert function, and it will run on the page. Now let's give it a try on the medium security level. If I type submit, go back to the stored XSS, we load our previous alert window because it's stored on the page. And now let's try again. If I type test and a simple alert function between the script tags, well, the window that we just loaded was from the previous low-level security script. If we manage to execute this one, we would get two windows. And just so we can differentiate them, let's run the script alert, and in this window we're going to type in hello, just so it can different from the previous script that's already stored on the page. As you can see, this is not the one that we just ran, it's from the previous attack. The one that says hello is not getting executed. Now, if we take a look down here, it appears that our script tags are getting removed, and also we are getting these backslashes before our single quotes. So it's getting filtered. But let's try to inject inside of the name field. If I type here script alert, and we know that we have the character limitation, but let's just leave it like that for a moment and sign the guestbook. Our script tags appear to be filtered as well. So what are we going to do? Well, let's take a look at the source code of this page. Let's see how it performs the filtering. So this is the code of this page, and we have a part of the code that sanitizes the message input and a part of the code for the name input. Now, by looking at the message input code, I can already see that this is getting filtered a whole lot better than the name input. Why? Well, because it has this HTML special chars function that removes all the HTML characters from our message. But this is not being used on our name. We only have the same filter that we had from the previous video inside of our name input. But we do have another problem. We have character limitation inside the name input. So how are we going to bypass that? Well, we can do something like this. We can type script alert, and we get to the character limitation. So in order to bypass it, we go inspect element. We find this name input inside of our code. It's in this form. Let's open the table, open the body of this table, and it's right here. It's this line that I have selected. And in this line we have max length equals 10. So if I double click on this and change 10 to 100, press enter, now I go back and I can continue typing in this field. Now I can type the entire script statement. And remember, our script tags are getting filtered, so we're just going to bypass it the same way that we bypassed it in the previous lecture by adding capital letter script. And if I click Sign Guestbook now, we'll load the first alert from the low security level. And it doesn't appear that we loaded the second alert. Let's give it a try once again. Of course, we need to increase this to 100. We type uppercase script tags and alert, and let's just differentiate it by typing hello in the brackets. Close the script tags. We can type anything in the message since that is getting filtered well, and we sign the guestbook. Here it is. Here is our alert script getting executed. We get our message hello. So it worked perfectly. Now I want to show you another thing that you can do with XSS or with HTML injection in general. You can inject a link for a file download. For example, for the purposes of this, I'm just going to go back to low so I can inject it in the message field. Go back to stored. Here we load our to XSS, and here I'm going to type test, and to inject a code that will allow the user to download a file from your command, we can type something like this: open a tags href equals, and in between the double quotes we specify the link that will lead to the file that we want the users of this page to download. So for the purposes of this, what we can do is we can, for example, go to this PHP info, copy the path to this file. Let's copy it, go back, and paste that path right here between the brackets. So open a tags href equals this link, and now we want to type space download. Oops, we also have character limitation right here, so we can bypass it the same way that we did previously by finding that in our HTML code and increasing the max length to 100. Now if I type download till the end, it will work, and I close the tags and type the file name. So the file name could be pretty much anything that we want. We can just call it php info.php. We close the a tags at the end, and we sign the guestbook. Let's click on OK. And here it is. We injected a link for file download. If I click on it, it will ask me whether I want to save this file on my PC. So that is also something that you can do with this vulnerable input. Whether you inject an HTML code that will download a file or JavaScript code that will download a file, it doesn't matter. What matters is that the possibilities with this are limitless, especially when you can inject JavaScript code. Okay, awesome. Now that we covered both reflected and stored XSS on the DVWA, let's take a look at the DOM XSS on our Mutilday page in the next lecture. Welcome back. Let's discuss a DOM-based XSS. So, in the previous few videos, we covered a couple of examples of reflected and stored XSS. We also saw some of the possibilities, such as stealing cookies, getting the IP address, changing the contents of the page, and also injecting a file to download. We also bypassed filters that removed our script tags, and we managed to bypass the max character security. Now let's navigate to the password generator in DOM XSS vulnerability. You can do that by going to OWASP, then navigating to cross-site scripting, and under the DOM injection, you want to select password generator. And this password generator, once we click on this simple button, generates a random password every time. Now, the first thing you will notice with DOM XSS is that if you tried to intercept this request, it will not work. You're not going to intercept anything once clicking on that button, even though the intercept is turned on. That's because no requests are being sent. As we can see, nothing is happening, so we can turn this off. But if we take a look closer at the link, we'll have this username equals anonymous. So let's try to inject it. If I type our usual alert function by opening script tags and closing script tags, press enter, it doesn't work. At least we think that it doesn't work. We didn't get a pop-up window, but what we did get is this part right here. And this looks like a part of code. So let's try to find in the source code where exactly is this located. Let's open page source. And let's copy this, for example. And let's try to find it right here. We can't seem to find it. Let's try just finding it manually. Or we can try to find all of the alerts on this page. Here is one alert. Here is another alert. And here is where our code is getting injected. This is the error message that we get, as we can see right here. And this is our code that we injected. So it's still getting there, just it's not getting executed. Let's see why it is not getting executed. Well, if we take a closer look at this part of the code, we'll notice that we already have open script tags. So our JavaScript code is actually getting injected inside our JavaScript code. That means these script tags are not needed, or we need to specify close script tags before we open them to run our alert function. So how can we bypass this? Well, since we already have open script tags, we can just first close the script tags for this part of JavaScript code from the page, and then we can open the script tags once again to run our alert function. Let's give it a try. If I go to this page, I delete my previous payload. What I'm first going to do is I'm first going to close the script tags. And then I'm opening script tags right after, then typing my alert function. Let's specify hello as the pop-up message, and I close the script tags again. So this is how our payload looks like right now. If I press enter, now it's getting executed. Now we managed to run our JavaScript code by closing the previous JavaScript code and opening the new alert JavaScript code. Let me show you how that looks like now that we ran it successfully. Let's try to find our alert function once again. And here it is. As you can see, the script tag that is getting opened by the code itself is getting closed by us right here. Here is our closing script tag. And right after we did that, we opened another JavaScript function that will run the alert message. Then we closed it, and the thing that we see outputted right here as an error is actually a part of code that we get right after we close our script, because this is no longer belonging to these JavaScript script tags. This is getting processed as a regular text on the page, therefore it's getting outputted right here. So we managed to execute our JavaScript code by taking a look at the source code and seeing what we need to adjust in our payload in order for it to be able to execute. Awesome. Now that we did that, we're going to take a look at another example of XSS, or a different example of XSS, in the next lecture. Okay, we went through a bunch of different XSS attacks, but on our OWASP BWA machine, we have even more examples of different XSS possibilities, and if I were to choose on which of these applications that we have available, on which one we have the most examples of XSS, I would go with an application BWAP. On BWAP, we have most XSS examples, and I advise you to go through all of them just so you can practice this vulnerability even more. We're going to cover 2 or 3 at the beginning, and then I will let you go through the rest of the attacks. So we're already familiar with this app. We log in using B and Bug as username and password, and here we choose our vulnerability. If I scroll all the way down, here are all of the access attacks that this application offers. And they're all different. As we can see, this is an example of reflected GET request XSS. This is an example of POST request XSS. We have JSON XSS, and we have a bunch of others as well. Towards the end, you even have some stored XSS examples. Let's start with first 3, and let's see how we can solve them. So let's click on Reflected XSS, click on Hack, and here's the application. So enter your first and last name. So let's enter first name test1, last name test2. We click on Go. Nothing happens. The only thing that changes is that it prints out welcome test1, test2. So both of these fields get reflected on the page. We can try to inject both of them with alert script just to see if they both execute. So let's type alert hello, and let's close our script, click on Go, and of course we get 2 different pop-up windows for both of our alert functions. So both of these inputs are vulnerable to the XSS attack. Once you go through that one, we can navigate to the next one, which is post request XSS. And in this one, we get the same application, just if I type test1 and test2, we get the same output, but our parameters are not being sent within the link. So we will not be able to inject our JavaScript code inside the link. However, we can still inject it right here. Matter of fact, let's copy our previous code and let's click on Go, and it will also execute twice on this page as well. So this was rather simple, but these are also the attacks that we already covered. But right now, I want to cover another attack with the XSS that we didn't encounter yet, and that is the XSS over JSON. So let's click on that one, click on Hack, and this is the application that we get. So we have a single input. It says search for a movie. If we type in movie named test, we click on search. Well, the output that we get is test 3 question marks. Sorry, we don't have that movie. What if we try to inject JavaScript code, our regular alert function? We click on search. It doesn't execute. But we do get this part of code right here. Let's go to the inspect element to see where exactly is our script on this page. So let's select this one. Here it is. So we have open script tags. We have var or variable JSON response string, and this could be a little bit hard to read. So let's go and open page source. Let's enlarge this just so we can see it a little bit better, and let's search for the alert function. And here is the script that we are trying to input. It's right here. But it's not executing. We have a similar example as in the previous video. This part of code that we see right here is the part of code that is being written on the page after we try to inject our script. So how can we make this execute? Well, the first thing that you should have noticed, because we did cover it in the previous video, is that in this example, we're already injecting our JavaScript code inside the JavaScript code. We already have these script tags open right here. And we also have them closed right here. So our input is somewhere inside. So one of the things that we need to specify at the start is a closed script tag. But we also have this variable right here that starts with single quote, Then we have curly brackets. We also have the square brackets, another curly brackets. And here where our input is, we have an open single quote. So we must first escape this variable. We want to close all of these brackets in order to continue writing our script outside of this JSON response string. The easiest way that we can figure out which characters we need to specify at the beginning of our command is by going right here and simply copying these characters set. All of these characters are something that we need at the beginning. If we take a look at the source code, we will see that these characters are corresponding to the open brackets and also the double quotes right here and the single quotes right here. And we also have this semicolon at the end to replicate the end of the line that we have in JavaScript code. After that, we want to close our script tags since we are inside of the script, and we want to open another script tags. We can do that by running something like this. And then alert hello. And we close the script tags at the end. So this is our current payload. We have these brackets right here. Close script tags, open script tags, alert function, and at the end another close script tags. Let's click on search. And here it is. We finally got it to work. So if I go to the source code of this page, and I once again find the alert function, here is our code. The JSON response string is getting closed with these brackets and the semicolon at the end of the line, and then we are injecting our JavaScript code after we close the previous script tags. Awesome. As you can see, there are a bunch of different examples as to how we can exploit XSS, and I advise you to continue with the other examples right here to really grasp the concept of this vulnerability. Nonetheless, thank you for watching, and I will see you in the next lecture. Before we finish off with the XSS section and the XSS vulnerability, I want to just mention one thing that we have within our OWASP BWA application. Now, we do have a lot of these training applications on this virtual machine. But if you scroll a little bit down, you also have old vulnerable versions of real applications. And once you finish through this course and you finish all of these vulnerabilities, you can go through these real-world applications that really existed previously and test for real vulnerabilities that were previously found. For example, since we are in the XSS section, let's try to find an XSS vulnerability on one of these applications. There are many such as Joomla, AVS Tots, TikiWiki, we have WordPress, we have GetBoo, and many others as well. So let's, for example, go with this one. Let's go with GetBoo. We have one search bar. We can go through all of these pages right here, but since we are in the XSS section, this search bar might be interesting for us. Let's type in test just to see what happens with our input. So we get test written right here. Okay. But what happens if we, for example, try to inject a simple script? Let's go. It does get reflected here, but nothing really happens. Let's take a look at the source code. Let's once again try to find the alert, and here it is. Besides there, we also have it right here. So on two different places. Let's go with this place first. So we have open input tags, and our script is being added between these double quotes right here inside of our value parameter. So what would happen if we were to, for example, type in something right here, for example, test, then we manually close the double quotes, and then we add the ending HTML sign to end this entire input part. And after that, we inject our code. Let's see if that would work. Let's go back, delete this, and we type in test, for example. Then we type in closing double quotes. Then we close the HTML tags, and now we run the script. So let's do it like this. Simple open script and close script tags with the alert function in between. This is our payload, and now if we run it, well, here it is. We get access vulnerability in this application. Let's just quickly take a look at the code to see what happened with our input. Here is the input field, and what happened is value is now equal to test. As we can see right here, the input open parameters are getting closed sooner than in real application, and then we're running the script alert function. The rest of the code, which belonged to the input function, is getting processed as a regular text. That's why we have it outputted right here. So how cool is that? You can go through these real applications and you can try to search for all of the vulnerabilities that we covered and see which vulnerabilities you managed to find. Nonetheless, we have fully covered XSS right now, and in the next lecture, we're going to start off with another big vulnerability, which is called SQL injection. SQL injection. It is one of the biggest and most serious vulnerabilities out there. SQL injection happens once a database query is taking an argument of an unfiltered user input. Usually, those inputs are something like usernames or passwords. It could also be something like an input on a page where you search for a specific product. Whatever it is, the backend process is the same. Our input is getting sent to the database of the website. The database checks whether our input is stored somewhere. Usually this is something like a password check. So the website would send a hash of our password that we inputted, it would send it to the database, and it would see whether it can find the match. If the match is found, and we inputted correct password, then the database confirms it to the server, and we get to log in to our account. Now, this is just an example. It doesn't have to be passwords that we input. It can be any type of application as long as it communicates with the database. And as we know, this communication between the server and the database is being done with the help of something like an SQL query. SQL is just a programming language used to communicate with the database. Now, all of this is how a normal application should act. But this is all considered if our input does indeed get well filtered. But what if we, as attackers, instead of sending a regular input that the application expects, we send an SQL query? Well, that is when the problems can occur. And in this vulnerability, it can be a really big problem. If the input isn't filtered and our SQL query gets through, then what we can do is we can craft a query that could maybe tell the server to drop or to send us the entire database. If we were to do this successfully, we will have all the usernames, all the passwords, and all the private information of all the users registered on that specific website. As you can imagine, this can be really bad. An example of an SQL query that can be used to extract something from the database looks something like this. So it says select elements from table where condition. The things in the square brackets would get exchanged for elements and tables that are inside the database. So the real life command that a real website could potentially send to the database could look something like this. Select $sign from books where ID equals to 5. Now, this star sign is simply just a referrer that says select everything. Every time you see this star sign, it usually means everything. So select everything from the table called books, where the ID is equal to 5. And ID could potentially be an ID for a product or a user or pretty much anything depending on the application. And this is just an example of a normal SQL query. In the practical lectures, we will see how we can manipulate user input and SQL language in order to get information from the database. See you in the next lecture. Okay, before we start with exploiting SQL injection, I want to show you a quick guide that will teach us how exactly SQL injection works and what are the steps that we need to perform in order to discover it. The reason we're going with the guide first is because this is arguably the hardest vulnerability that we covered by now, so we could use a little bit of practice in order to really get used to it and to really understand it. So what I want you to do is I want you to open your Firefox. In your search bar, type in SQL injection practice, and you should find this link to be among the first ones. It is SQL injection-hacksplaining. You want to click on that link, and the full URL to the example is this one, in case you want to type it in. Once we get there, we want to click on Get Ready and start the application. So once you click on that, it will load this application right here. This is our vulnerable website. These are the steps that we need to go through in order to exploit the SQL injection. And here we will have a small guide, which will come as this message. So the first one says this is the vulnerable application we will be trying to hack with an SQL injection. And it appears it's a bank application with login form. So let's move on to the next step. It gives us another window that says here are the application logs. What will happen here when you interact with the vulnerable application? Okay, one thing to notice is that logs is something that we wouldn't really have in real life attack. This is given to us just so we can understand this vulnerability. Okay, so let's go on to the next step. It tells us go ahead and try logging in with the following credentials: user@email.com and password. Let's type that in, user@email.com and password. Let's click on login, don't save, and nothing really happens. If we go to logs, it will say invalid credentials specified. But the next step tells us that guessing the password didn't work. Let's try adding a quote character after the password. And you will see in just a second why are we adding this quote character. Let's type that in first. So let's type password. Our email is already specified and let's just click on login. Now we get an error. An unexpected error occurred. This says this application crashed with an unexpected error. What could that mean? Well, let's go to the next step, which will lead us to logs that says the log shows an SQL syntax error. This indicates that the quote character messed something up in an unexpected way. And if we take a look at the logs, we do get syntax error, and here we also get the SQL query used to query our username and password, or in this case our email and password. And you will notice where the error is. Our credentials are being specified between the single quotes by default. Once we added a single quote at the end of our password, it messed up the syntax, because now here we have one open single quote and two closed single quotes, which gave us the syntax error. This is a really good indication that there is an SQL injection vulnerability on the application. Let's move on to the next step. Now it pops another window, and in this window we get the SQL query or the SQL code use to query our credentials to the database. And this code that we get right here is the same one that we got inside of our logs. It will change once we type something in. It will show us how it looks like inside of this code window. So let's go to the next step and let's type once again password question mark, or pardon me, single quote. It even tells us to do that again, and here we can see how it looks like. If I delete this single quote, you will notice that this is the entire SQL query. This also belongs to this command. But as soon as I type a single quote, it messes up this part that comes after. So this is why this single quote gave us an error. The SQL syntax is no longer valid once we specify it here. Let's go to the next step. It even tells us right here the quote is inserted directly into the SQL string and terminates the query early. This is what caused the syntax error we saw in the logs. Okay, we already mentioned that. Let's go to the next step. It says this behavior indicates that the application might be vulnerable. We already mentioned that as well. And the next step tells us to enter the following command. We specify the regular user email.com and the password is single quote or 1 = 1 -- Why are we typing that in? Well, let's type it first and then we're going to explain it. So let's go with single quote, space or, space, 1 = 1 -- If we go to our code window and we take a look at the query, it actually is a valid query. It's a valid SQL syntax. We're selecting everything from users where email is equal to this email and password is equal to nothing or 1 is equal to 1. And this -- at the end is just a syntax for a comment in SQL language. What this last line does, it simply says find the user with this email that has a password to be equal to nothing, or if that user doesn't have a password that is equal to nothing, then check whether 1 is equal to 1. And if any of these two conditions are fulfilled, log us in to that account. Now, since probably password is not equal to nothing, this will not go through, but the second argument is that 1 = 1. And if any one of them is equal to true, then it will log us in case this user exists inside this application. And 1 is always equal to 1, so this should log us in. Let's give it a try. And here it is. It says even here, we are in. We successfully gained access to the application without having to guess the password. Now we are logged in to the bank account of that user with a simple or 1 = 1 command. So what we essentially did right here is we injected SQL syntax inside of this query and we tricked the application to execute our code just because it doesn't filter user input. Nonetheless, you saw how easy this was, and we're going to take a look at more similar examples in the next few videos. Welcome back. Let's do the first example of SQL injection. So in the previous video, we took a quick guide that told us how exactly we can exploit certain types of SQL injection. Right now, let's see how we can put that to practice with our OWASP BWA machine. So what I want you to do is I want you to go to the OWASP /2, and from here I want you to navigate to OWASP 2013, A1 injection SQL, and we want to go with the first example, which is user info SQL. Let's click on that. And this is the application that we want to try to perform SQL injection on. So if we follow the same guide from the previous video, we should be able to get it to work. Let's give it a try. So first let's take a look at the application itself. It requires the name and the password in order to view account details. Let's type anything just to see whether it will work. Click on view account details and we get results for test, 0 records found. authentication error, bad username or password. If we remember from the previous video, in most cases we can take a look whether there is an SQL injection on a web page if we make the application run into an error by specifying something like a single quote. Let's give it a try. If we try to specify a single quote for both name and password and we click on View Account Details, we still don't get anything. Let's also give it a try like this, test single quote and test single quote. Perhaps we can make it crash, or perhaps we can make it give us some details that we didn't have. And by those details, I mean something like this error message. So we typed in test single quote for the name and for the password, and it gave us this error message. We didn't exploit it yet, but we are aware that this does cause an error in the application. And if we take a closer look inside of this error, it does also give us the SQL query used to query the database. If we take a look where our username is being specified, we have single quote creating a problem right here, and we also have a single quote creating a problem in the password variable. Why? Well, because both of them have one open single quote and two closed single quote, resulting in this error. So what we can do is we can try to perform the same thing from the previous video. Just this time we don't really know the correct username like we did know in the previous lecture or in the previous guide. How can we bypass that? Well, we can type the same command, which is, for example, test single quote or 1 equals to 1. And we can type this for both username and password. Now, since our username is in the middle of the syntax, we can't really use dash dash at the end to comment out the rest. So what we're going to do is we're going to type it in like this. Test single quote or single quote 1 single quote equals single quote 1. This will be our username. Now, you could be asking, well, why didn't we specify single quote at the end? Well, that is because we already have it inside the SQL query. Our input is getting stored between the single quotes by default. So this end single quote inside of the username will replace the end single quote that should belong to this one number. And then we will get the username to be equal to test, or 1 under single quotes is equal to 1 under single quotes, which should be correct. We want to specify the same thing for our password. So pretty much you can just copy this and paste it right here. And if we click on View Account Details, scroll a little bit down, here it is. We successfully exploited the application, and now, since we didn't specify a unique user, now we got the entire database of users outputted right here. We got their usernames and passwords as well as their signature. And we got passwords for every username inside the database. Now you can see how dangerous this can be. Now we can access any of these accounts that we got right here by going simply on the login screen, which is right here, and specifying their username and password. This was also a simple example, but nonetheless it has a powerful result that you can really do some damage with. But in the next lecture we're going to take a look at more advanced example inside of our DVWA application. Thank you for watching, and I will see you in the next lecture. So let's go right here, log in as usual to our DVWA page. And let's first select the DVWA security to allow and navigate to the SQL injection. Now, you might notice that we also have SQL injection blind, and this is something that we're going to talk about later on. For now, let's just focus on this SQL injection tab. So, what do we have right here? We have something called user ID. And usually, we would input something like a number right here. So, let's give it a try. If I, for example, input number 1 and click on submit, well, it will tell me that the ID of 1 is a user with the first name admin and surname admin. And that user has ID 1. What if we type 2, for example? We click on submit. Well, we got a user with ID 2. His name is Gordon and his last name is Brown. And we can go for each and every number if we want. For example, the ID 5 has first name Bob and last name Smith. But to search for the SQL injection, what we can do is we can type some special characters, and that might throw an error if there is an SQL injection. For example, if I type apostrophe or a single quote and I click on submit, it will throw me this error. It will say you have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use near line 1. And this already is an indication that we have SQL injection bug, since it interpreted our apostrophe as a part of SQL syntax. So for now we know that there is an SQL error because we got an SQL error syntax, but before we continue, let's first explain why does this give an error? Why using a single quote gives us an error? Well, let me show you like this. If I open terminal and I open a program called LeafPad. Oops, let me see if LeafPad exists anymore in Kali Linux. If I type it right here. Okay, never mind. Let's just go and find a program that will allow us to write text. And here we got some text editor under the usual applications. I'm going to open that and I'm going to enlarge it just so we can type something right here. And now that we open this, let's explain why apostrophe gives an error in SQL syntax. Well, as we already mentioned in our slides, usually we will have an SQL syntax or an SQL query that will look something like this. So select and then something from a certain table where some condition is fulfilled. And for our page right here, if I go back, since we have user IDs, first names and last names, it could possibly look something like this. So select name, comma, surname from the table that could be named something like accounts, we don't know that yet, where ID equals, and then the ID number goes between single quotes. So this could possibly be our SQL query that we send to the database, and then the database retrieves the user under the ID 2. But what happens when we type apostrophe is instead of these two, and instead of it filtering the apostrophe, it just writes it between these two single quotes. And then we get 3 single quotes. The opening single quote, and then our single quote that we injected becomes the closing single quote, and then the third one is the single quote that's hanging. It doesn't belong to anything, therefore the SQL throws an error that it has 1 single quote more than it should have. And whenever that happens, you got an SQL injection bug. And this is also called the error-based SQL injection because it throws us an error. On the other hand, we got the blind SQL injection that doesn't throw an error, so there are some other methods that we must use for that one in order to figure out whether it exists. Now that we know that there is an SQL injection, what we can do is we can type some other statements as well. For example, we can select the ID number 2 and then close the single quote inside of that SQL query, and we can type some logical statements such as, for example, and 1 equals 1. And keep in mind that this right here, if I copy it and write it down, has single quotes between the numbers. And it doesn't have the single quote at the end because inside of our SQL query, we already have a single quote at the end. So this single quote will cover the last part of this one, and this first single quote will cover the first part of these two. So essentially, once added to our SQL query, it would look something like this. Instead of this single quote, we would have this. And you can see this opening and closing single quote fulfills our statement. Let's give it a try and run this. And we'll just get the information about user under the ID 2. And that is because our statement is correct. So we select the user ID 2 and we say, do that in case 1 is equal to 1. And 1 is equal to 1, so there are no problems, it just prints the username. But if we were to type the same command, just change 1 equals 2 and click on submit, we wouldn't get any output right here. That is because 1 is not equal to 2, therefore it won't print the user under the ID 2. That could be another sign that there is an SQL injection. Now that we know for sure that there is an SQL injection, we can try some other commands, such as for example this one. So if I go down here and type 2, single quote, and this is just us selecting the ID number 2, and then use a statement called order by 1, and add dash dash, then space and single quote at the end. So let's explain this command. The reason we have this dash dash, space and then single quote is because that is referred to as a comment. This dash dash is a comment, and we must add this at the end of our statement, at the end of our SQL query, because otherwise it would throw us an error. We must have it so we don't get error when running our SQL commands. And order by 1 will just check whether there is column 1, and we are going to do that for 2, for 3 as well, and we're going to see how many columns do we have. So if I copy this and go back to here, paste this, click on submit, we'll get an output first name Gordon and surname Brown. That means this is a valid statement. Let's try with order by 2. So just change from 1 to 2 and click on submit. And this is also a valid statement because we get the first name and surname. And if we try number 3 and click on submit, well, there is an error, unknown column 3 in order clause. And that's how we know that we have 2 columns. Now, let's see what those 2 columns are. If I go and type this command, and I'm going to type it right here first, 2 as our ID, and then union select 1 and 2. And let's not forget our comment at the end by specifying dash dash and then single quote. If I copy this and I paste it right here, click on submit. Okay, so we get this output right here. The first name for the ID 2, and we get the first name 1 and surname 2. Now that we know that we have 2 columns and that we have an SQL injection vulnerability, we're going to start extracting data. So we know that we have 2 output fields, the first name and the surname field. So we're going to try to extract the database name and the user of the database. To do that, we can type the command to select the user ID and then union select, and we're going to type database open and close brackets and comma user open close brackets. At the end, we add our comment with a single quote, and here we are specifying the functions called database and user. These 2 functions are already defined in MySQL. So let's copy this command just to see the name of the database and the name of the user and type it right here. And we get the first name, which will store the database name, which is dvwa, and the surname or the user, which is going to be root at localhost. Now that we know this, we can try to extract the list of the databases by injecting the following command. So after this, we once again start with 2 and then union select. And these select statements you can also type in capital letters. It doesn't really matter. You can type capital or lowercase letters. What matters is that you type the correct command syntax. So right now we're going to call for schema underscore name, comma 2 from information underscore, and let me just enlarge this so the entire command can fit. So 2 from information underscore schema dot schemata dash dash and then close single quote. Okay, so let's just copy this and see what do we get with this command. If I copy, go to my page and paste it right here, well, we get quite a few results back. And we essentially get different databases outputted right here. We got our DVWA database, we got Metasploit database, MySQL database, OWASP 10. And since we're doing this all inside of the DVWA application on our Metasploitable, we would most likely be interested in this DVWA result. So let's try to extract even more from it. We can use the following command, which is id2 and then union select table underscore name, comma, 2 from information underscore schema dot tables. So you might be wondering what even are these, and this is just regular syntax for the SQL language. These are just something that you will get used to over time. Once we type from information schema dot tables, where the table underscore schema is going to be equal to the one that we want, and in our case that is DVWA. So we can just type equal open single quote DVWA close single quote and then our comment dash dash quote. Let's copy this entire command, copy it and paste it right here. Now I'm not sure if I copied the entire command, so I'm just going to go back and add what's missing, which is 2 and then single quote and then union. Click on submit. And here is the output. So with this command, we sent a query where we requested names of all the tables inside the DVWA database. We got 2 results, which is guestbook and users. And this users right here could be interesting for us, so let's dive deep into it. We want to extract columns inside of this users table. We can do that by injecting this command right here. So let me just make a few spaces and type the next command, which we, as usual, start with 2 and then apostrophe. Union select. And now we're selecting columns, so we are going to type, instead of table name, we're going to type column underscore name, comma, column underscore type from information underscore schema dot columns. Remember in the last command we used dot tables, now we are using dot columns because we are furthermore diving into our database and we need a condition at the end, so where table underscore schema is going to be equal to DVWA and table underscore name equals users. So remember, we got 2 results right here and we want to go with the users one first because that looks more interesting to us than this guestbook table. Okay, so let's copy this command and now I'm going to copy the entire command. So select, copy and paste right here and click on submit. And again, we get a lot of results. Here they are. Can you guess which one out of all of these columns are most interesting to us? If you guess the password one, well, you guessed right. But we also want to extract other columns as well, such as usernames, which we get right here, such as first names, last names, IDs as well, and all of that we want to extract. To do this, we will need to use the concat function, because we only have 2 fields available to input our result. So we must concat a few results in one field and the rest of the results in the other field. We can concat, for example, user ID, first name and last name in the first name field, and we can concat the usernames and passwords in the surname field. So let's see how that command would look like. If I go back and add a few more spaces, let's type 2 and then apostrophe, union, select, and then use the concat function to concat multiple fields into one, and we can do that by specifying which fields we want inside of this function. Let's type user underscore ID as a first field, comma, and we're going to separate them with 2 dots. So comma and then first underscore name, which is going to be our second field, comma, let's use again 2 dots to separate that also from the last name. And these are the 3 fields that we're going to concat into first result. Then after it, we want to type comma and concat the usernames and passwords into second result. So let's type it like this, password. And at the end, we must specify from where are we extracting all of this. And in our case, since our database is called dvwa, we're also accessing the users table. So we must type it like this. So extract all of this from dvwa.users. Add the comment at the end. And let's copy all of this. And submit. Well, here it is. Here is all of the information about all of the users from this database. In the first name field, we get the user ID, followed by the first name, followed by the last name. And in the surname field, we get the username and the password. So we successfully performed SQL injection and we extracted all of the information about all of the users inside of their database. But you will notice that passwords are rather strange, right? This is because they are hashed. Usually, websites store hashed value of passwords inside their database for security reasons, since even if something like an SQL injection happened and someone managed to extract the entire database, they wouldn't get passwords in plain text, but rather as hashed value that they need to run a dictionary attack on in order to find it in plain text. And by looking at them, I would say that this is probably MD5 hash. We can figure this out by copying one of these passwords, so let's go with this one for example. Going to Google and just pasting it inside of the search bar. And we can see most of the results are MD5, 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 so we can guess that this is an MD5 hash. And since this is an easy password, if I click on this link, it will even tell me which password this MD5 hash is. So it is the password ABC123. So if I go back to this page, we can conclude that Gordon has a password of ABC123 because this website showed us what is the string of this hash that we pasted. We can do that for any other hash as well. As long as it is a simple password, it should manage to find it online. If I go and paste this one, for example, go right here, click on this website, MD5 hash for password is this. So it seems that our MD5 hash is a string of password. So our user called admin has a password that is simply just password. And that is how you extract the entire database with the SQL injection vulnerability. Now, this is probably the hardest bug that we are going to cover inside of our web application section. And it might take some time for you to get used to it and to get used to all of this SQL syntax that we performed right here. For example, these database functions, user functions, could be known by someone that already knows SQL, since these are already the inbuilt functions, and that also stands for all of these syntax like table name, like information_schema.columns, and the rest of these commands. But if you practice it more and more, you will eventually get better at performing SQL injection. Okay, great. So we performed SQL injection, and in the next video, we're ready to continue discovering even more bugs on our DVWA application. See you there. Okay. In the previous lecture, we saw an example of how we can exploit the SQL injection inside of DVWA application. But right now, let's see how we can apply the same command that we used to exploit it, which I have written right here. This is the command or the end command that we use to extract all of the data from the database. Let's see how we can change it to make it work on the medium level. So last video was on low level. Now let's change it to medium and submit and navigate back to the SQL injection. Now, if we try to run the same command, let me just copy this, and we try to run it, it will not work. It will result in an error. luckily, this error does give us a little bit more information than it should. For example, if we scroll all the way to the right, here we will see how exactly our command is getting processed in the page. You can see wherever we have a single quote specified, it is getting filtered by a backslash. So every time we specify a single quote, it adds a backslash, the application adds a backslash, which then results in my SQL error. This command is not valid once it has this backslash. Another thing that we can notice is that it doesn't really give us the entire command at all. It only gives us a part of the command. This could mean that there could be a character limitation that we can specify. Let's give it a try to see how we can bypass this backslash and how we can actually bypass the character limitation in case there is one. So let's go back to the page and let's delete this. Let's delete all of it. And the first thing that I want to take a look at is the source code. Let's enlarge this. And what we are mostly interested in is the actual query used to query the database. Of course, the source code is not something that we would have in a real application, but luckily, during the practice, we can take a look at the source code and figure out how we can exploit this. You will notice one main difference that differs this application from the low-level application. Our ID or our input is not getting stored between the single quotes. This is really good because this can help us bypass the single quote problem that gets filtered by a backslash. Because if it doesn't get added between the single quotes, we don't really need to use single quotes at all. We can type a command that looks something like this. So if we take this same command, we can make it work if we run it like this. To union, select, concat, and let's type user ID. Now, since this is getting processed as a character, we must remove it altogether. So what we're going to do is we're just going to type it like this, user ID, and then first name. The only problem with this is that these users and first and last names are not going to be visibly divided by the semicolon. Nonetheless, it's still better than not extracting any data, so we can run it like this. We need to specify the user and the password, and we're extracting this from dvwa.users. We specify 2 dashes to comment out the rest of the command, and if we copy this, go back to our application and run it, well, here it is. It worked successfully. We managed to extract all the data just by removing the single quotes from our command, as we can see right here. It appears to be that is the only filter. I thought there could maybe be a character limitation filter there as well, but that could easily be bypassed. We could just remove the unnecessary data, such as, for example, this one. We don't really need the user ID, the first or last name. Only thing we are interested in are users and passwords. And we can type it like this: to union select, 1 comma, and then concat user password from dvwa users. And this will make our command even shorter, allowing us to perhaps bypass the character limitation. Let's give it a try to see whether this command will also work. And before I type it in, you will take a look at the only problem that we have is that the first last name is not getting separated, and the username and password are also not getting separated. But we are extracting them nonetheless. Let's take a look at this third command to see whether it will work. And it will work. We removed specifying the first and last name, so now in the first name field we only get number 1, which we specified right here. And in the last name field, we get the username and password all together. And we get that, as usual, for every user in the application. Nonetheless, I just wanted to show you how we can exploit the SQL injection on medium level. And in the next lecture, we're going to tackle the subject of blind SQL injection. See you there. Okay, it's time we cover a blind SQL injection. So we already know what SQL injection is, we know how it works, and we know how we can exploit. But what is blind SQL injection? Well, let me show you. Let's navigate to our DVWA, log into our page, navigate to blind SQL injection, and if you remember how we actually managed to discover whether an SQL injection was present on an application or not, is we used a single quote. And once we entered that single quote, it would give us an error, or it would give us some error message, or possibly even the query itself where the error occurs. That's how we would know that this input is not really getting filtered well. If I click submit on blind SQL injection, nothing happens. It's as if this application is not vulnerable. Doesn't give any error. We can type anything with as many single quotes as we want, and nothing will happen. Any character that we input will just get processed by the application, and it will retrieve this same page back to us. So, does that mean that it's not vulnerable? Well, it could be, but there is also blind SQL injection, which means it's not giving us any error back, but it's still vulnerable to the SQL injection. Okay, but how can we figure out whether the SQL injection is present in this application? Well, let's try specifying the correct input first. So if I just type 1 and click on submit, it will give me an ID of admin. It will give me its first name and last name. If I type, for example, 2, I will get Gordon Brown, and so on and so on. So we can select one user ID right here, and we get one output back. Same goes if we, for example, try 1, single quote, or 1 equals 1, or 1 equals 2. Let's try it like that. So we only get admin back, but it could be due to 2 reasons. Reason number 1, it's not vulnerable to SQL injection, or reason number 2, that only this argument is satisfied. ID number 1 exists, but 1 is not equal to 2, so this part is not satisfied, therefore we only get the output for admin. But if we were to type 1, single quote, or single quote 1, single quote equals single quote 1, press enter, we get all the users from the application. Now, we don't get their usernames or passwords, however, we do get all of them outputted right here. And this would be a good indication that there is a possible SQL injection in the application. Why? Well, because this application is not meant to output 20 users, it's only meant to output 1. And with this statement, we told the application we want the ID number 1, or if 1 equals to 1, and it gave us all the other IDs. And that is one of the ways that we can discover whether it has some vulnerabilities in the application. Now, how can you exploit this? Well, here is where the problem occurs. Exploiting blind SQL injection is much longer and harder than exploiting an error-based SQL injection. For example, here we can't really output the database name. We need to guess it, because we're not getting any output back or any error back. So, how can we go about guessing the database name, the table name, the column name, and all of that? First of all, to keep in mind is that it takes a lot of time to do that, so for the purposes of this tutorial, we will only show how we can guess the database name. To guess the database name, we can use an SQL-like operator. And you can find it on this page. It describes what exactly does it do. The like operator is used in a where clause to search for a specified pattern in a column. Since we don't really know how the database is called, or we do actually know how it is called, but only because we exploited it in the previous lecture. We know that the database name is DVWA. this is the name of the database. But let's pretend that we don't know it. We want to discover it by exploiting blind SQL injection. We could do it like this. We could type one single quote for the ID and database, since we know SQL has this database function, and then this like operator, which has the syntax of open single quote, then the letter that we want to use, let's go with letter A, and then the %sign. What does this mean? Well, this line simply says that we're checking whether the database name starts with A, and this %sign simply replaces all the other characters that could come after. So we're only checking whether the first letter of the database is A. Let's press enter. We get nothing back. Why is that? Well, it's because the first letter of database is not A, therefore it didn't give us any output back. If we were to type something like this, and database, and then we switch A with D, because our database does start with D, and we click submit, now we get output back. And now we would know that the database name starts with letter D. As you can already imagine, this can take a lot of time to guess. And we could use the help of Burp Suite to do this. So let's go to Burp Suite. Let's turn on the intercept. Let's type 1. And, oops, let me just type it in first, and then I'm going to intercept. So 1 and database like A. Let's start with A once again, just for the purposes of showing how this would work in Burp Suite, and then we intercept the request. Now we want to send this request to Intruder. Let's click on that. We can turn off the intercept and go back to the Intruder. We want to select the positions, and here we want to clear all of these positions. Find the letter A, which is right here, and then add a position to it, since that is the only thing that we want to use as our payload. Once we do that, we want to go to payloads, and here we want to load all of the letters possible. So let's just go A, B, C, D, E, F, G. And here I loaded all of the possible letters that could be the first letter of the database. So once we load all the letters, we want to go to options. And here in the grep match, we can clear everything and add, for example, admin. So if we find the word admin in the page, then we're going to assume that we found the correct letter. Why is that? Well, if we get the correct output, it will output this that has admin right here. Or matter of fact, just so we can get even clearer response, let's copy this entire string, which is first name admin, and let's paste it right here. Then we add it right here, and if our response finds this string inside of the HTML code, that means we found the correct letter. All we need to do right now is start the attack. And here it is. We already get our response. Letter D is checked. It has first name admin in the HTML response. It also has a different length of the response than all the other letters, as we can see right here. Now that we guessed the first letter, we would cancel this. We would go back to the positions, and we would first of all clear this, remove the A, and type D. After we type D, we once again type A. Then we select A once again as the second letter, since we already guessed first. And now our command looks something like this. 1 and database like open single quote D A%. Now we're guessing the second letter. Okay. If I submit, this will once again not give any output back because A is not the second letter. So let's see which letter is the second one. We can start the attack. Let's wait for this to finish. And here it is. Letter V is the second letter. Now we can go on to the third letter. So the VA, we once again select A. We start the attack. And here it is. It appears that W is the next or third letter. Let's add it right here. And let's add A at the end. Select A and run the attack once again. And we get the response straight away. A is the fourth letter. Now we got the full name of the database. Now if we try to type like this, and database like dvwa, submit, now we get the response back. And here we can see that this is the name of our database. And you will have to do this for every database name, table name, and all of that. So now you notice why this is much longer to perform and much harder. Nonetheless, we covered it, we know how it works, we know that if we don't get any error once we specify the input, it doesn't mean that there is no SQL injection. We can also try something like making the application sleep for 3 seconds, which is also an indication that there could be an SQL injection if the application does sleep for 3 seconds after our command. Nonetheless, thank you for watching this lecture, and in the next video we're going to start off with XML XPath injection. See you there. Okay, let's discuss a new vulnerability called XML or XPath injection. And to demonstrate this, I want you to navigate to your Bebop application. Under here, we want to scroll a little bit down and find this right here. As it says, XML XPath injection. Let's click on this one first, which is search for. So let's click on that, click on hack, and it will load this application right here. Now, this vulnerability is kind of similar to SQL injection. The input that we send could be processed unfiltered through XPath. Now, since we don't really have any input right here that we can type in, we can assume that this button is our input. So we can select the movie genre, action, horror, and science fiction. If we go with science fiction and click on search, it will output all the science fiction movies. Okay. Now, let's try intercepting this request with Burp. Let's go right here. Let's turn on the intercept and let's click on search. So we can see our parameters are getting sent through this link. We get genre to be action and action equals search. Now, let's try a simple injection type. Let's try to see whether we can get error by specifying a single quote, the same way that we did with our SQL injection. So let's type action, single quote, and let's forward this packet. Let's go back here, and we do get some error. We get warning, simple XML element, XPath, invalid expression. Now, there is one thing that this application can do. We can check whether it requires entire name of genre, which is action, or can it determine which genre it is with just a first few letters from the name. For example, if we type ACT, can it determine that we want the action genre? Let's give it a try by intercepting the request once again. And instead of sending action, let's delete last 3 letters and just leave it on act. If we forward this, go back, it does actually load the action movies. So it can determine that we meant to search for action movies just by looking at first 3 letters that we specified from the genre name. Now, why did we check for this? Well, if we still get results like that, this could mean that the application uses a function called contains. And that function looks something like this. Let me just nano example.txt. This is the function that our application could possibly use. And since we're testing this as a black box, we won't be looking at the source code, but we can assume that the code to the application could look something like this. Open square brackets, contains, open normal brackets, genre, comma, and then single quote, $, and something like genre input. It doesn't have to be called like this, but let's just assume that the application could have a code that looks something like this. So if the genre input is contained in the genre name, then it will just load that genre. So let's also use this contains function ourselves to try to get everything outputted that the application offers. And to do that, we need to craft our payload. Since we assume that the application could potentially use a function like this, we need to escape it first. And we're going to escape it with closing off our brackets first and our single quote to our input. So we start like this. This is our first 3 characters. And then we must use this syntax, which is slash and then $, then pipe. Since we're piping another command, we use slash and again $, and now we use our own contains function, which we can access by opening square brackets and then contains. Then let's open normal brackets and specify 1, 1 inside of the single quotes. And the last single quote we're not specifying due to the same reasons as in the SQL injection. It's probably already specified inside of the application at the end of our genre input. So what we did right here is we pretty much closed off this code in the application by specifying these 3 signs. Then we added our own contains function, and the leftover signs that we closed off in the application code are getting added at the end right here. Therefore, we don't need to type it in twice. If we copy this code, and we go and intercept our request once again, we, instead of typing action, we can delete this and specify our code, which is this one right here. If we forward this, go back to the application, here it is. We get all the output right here. You can say the entire database drop, even though it's not a database drop, but we do get all of the movies that are in this application, just by exploiting the contains function and the unfiltered input through this genre tab. Awesome. In the next video, we're going to check another example of XPath injection that we have on BWAP, which will be really similar to SQL injection. Thank you for watching, and I will see you in the next lecture. Okay, let's cover another XPath injection. So let's navigate to our menu where we can choose our bugs, and let's go with the second XML XPath injection that we have available. Click on that and click on hack. So this application has a login form. We need to specify username and password. So let's give it a try. If you remember from the previous video, I mentioned that this will be rather similar to SQL injection attack. So let's go in that direction. Let's first of all specify normal username and password. So I'll specify test and test. Click on login and nothing really happens. Let's go down. It says invalid credentials. But what would happen if I type test, single quote, and test, single quote? Click on login. We do get invalid credentials, but up here we will have a warning or an error. Simple XML element, invalid predicate in this path. So we do get an error. The way that we can exploit this error is pretty much the same way that we exploit SQL injection. So all we have to do is type test or 1 = 1 with single quotes. And same thing for password or 1 = 1. We click on login. And here it is. We logged in as user Neo. Welcome Neo, your secret. Oh, why didn't I took that black pill? So we get the username and its secret. But there is more to this than just logging in as this user. We can try to log in as any user in case this application defines users with an ID. For example, Neo could be ID 0. A different user could be ID 1. Another user could be ID 2, and so on and so on. In case there is a parameter or variable ID that reflects on each user, then we can switch the user by changing the ID value. So we can try something like this. Test, single quote, to close off the normal input. And we type or ID equals, for example, 2. Remember not to close the single quote at the end because it's already getting closed by the application. Let's type the same thing as password, so test, single quote, or ID equals 2. Let's go down. And now we are a different user. Welcome Alice, your secret, there's a cure. We can go even more, so ID equals 3. And let's do the same right here. We are Thor now, and you can see where this goes. This application allows us to interact with the ID value, therefore allowing us to switch the username just by selecting test single quote or ID equals 2. And then it logs us in as that user, and we also get their secret. So this was rather easy to exploit. In the next lecture, we're going to take a look at a different type of vulnerability that we haven't encountered before, which is called XXE. See you in the next lecture. Welcome back. Let's discuss a vulnerability called XXE. Now, first of all, what does XXE stand for? It stands for XML Entity Injection. It happens once an application takes the user input in XML format and it processes external entities that are declared inside of it. If that happens, it could be vulnerable to XXE or XML Entity Injection. Let's take a look at the example of this vulnerability on our BWAP application. So let's go to choose our bug, scroll a little bit down till A7, and all the way down we have XML internal entity attacks, or in brackets XXE. Select that and click on hack. This will load this very simple application. There is no user input here, all we have is this reset your secret to any bugs. So this is a button. Let's see what happens once we click it. It appears that nothing really happens. Let's try intercepting this request inside of our Burp suite. So go up here, turn on the intercept, and let's click on any bugs. We get this request. And if we take a look at down here, we have the application processing some input in XML format. And remember what that means? If it also processes our external entities that we are going to inject, it could be vulnerable to XXE. But before we actually get to injecting anything, let's first send this request to the repeater. Let's go Action and Send to Repeater. We can turn off the intercept and navigate to the repeater. If we take a closer look, we're going to notice that this request is sending XML structure with our username, so this is our account on BWAP application, and with a secret. So let's try injecting a simple payload to see whether this is vulnerable to XXE. And the payload that we are going to inject will be this one. I'm just going to type it in payload.txt real quick, and then we're going to copy it to Burp suite. So this will be our payload. Doc type, test, let's call it test, Then we open square brackets and we create our own entity like this. We type capital entity. Let's call the entity internal-entity and let's name it boss. So close off all of the tags and this will be our payload. So essentially what we're doing right here is we're creating an entity called internal entity, which will have a value of boss. And boss will be a new user that we're going to try to switch inside of our payload. Now, how are we going to know whether this works? Well, if we go to our Burp suite and we send this simple request, in the response to this request, we get this sentence right here. It says B's secret has been reset. If our payload gets processed inside of this request, then here it will say boss secret has been reset. Let's give it a try. Let's go and copy our payload. Let's put it up here right above the XML code that they have. So let's paste it right here. And this is not the only thing that we must do. We must also change this part right here. Since we want to change the user, we also want to specify which user we want right here. And the user that we want is stored in this internal entity. So all we have to do is specify it right here. To do that, we use this sign, and then we specify the name of our entity, or in our case, internal-entity, and semicolon at the end. Once we send this payload, here it is. We get boss secret has been reset. It's no longer the user B. In this payload that we created, this internal entity that has a value of boss is used within the login structure and it got reflected right here in the response. This means that everything will load through this entity, the server will process and reflect. So let's try with even more dangerous payload. Let's try to cat the content of @c passwd. We can do that by typing this command or this payload doc type. Let's call it test and open square brackets. We want to create entity once again. And we can call it anything we want. We can call it XXE if we want, or we can just stick with internal entity. This is pretty much your choice how you're going to call it. And now we're going to call a parameter called system. Make sure to type it in capital, so capital system, which will take the value between the double quotes of file, column, 3 slashes, and then @c/passwd. This is the file that we want to get the contents from. Let's not forget to close off our tags, like this, and this will be our payload for the XXE. We are using this system parameter. We define it in order to get our external entity to load the file. In our case, the file that we're loading is @c/passwd. If this works correctly, once we load it, the server should show the content of this file in the response to our request. Let's copy this. Go back to our Burp suite. Let's delete this. Paste our new payload. And since we called it once again internal entity, there is nothing really to change right here. We can leave it to be internal entity, but if you were to call it differently in your payload, make sure you switch the name right here as well. Awesome. Let's send this. And here it is. We get the output of /@c/passwd file on the target system. And this is XXE vulnerability. Now that we covered that, we're going to take a look at a different type of vulnerability in the next lecture, which is called components with known vulnerabilities. See you there. Okay. Components with known vulnerabilities. This is a really interesting vulnerability because it's a really big one. We're going to take a look at the example of it in our Try Hack Me platform, so just navigate to your OWASP top 10 and you will have it under task 27 28, and task 29. So what exactly is this vulnerability? Well, applications can run on certain software. And this can be any software from Tomcat to WordPress, to using PHP, to using different types of databases, and all of that. And all of those softwares had some type of vulnerabilities in the previous versions of them. Now, what happens is that many websites and many companies don't regularly update their software. So a good example here is that it says, let's say that a company hasn't updated their version of WordPress for a few years. And using a tool such as VPScan, you find its version 4.6. Some quick research will reveal that WordPress 4.6 is vulnerable to an unauthenticated remote code execution exploit. So many of these softwares, well-known softwares, have known vulnerabilities for previous applications. And this vulnerability occurs once an application is running a software that is outdated and that has a known vulnerability. Now, this is a big topic that doesn't really have anything to do with bug bounty, but we're covering it nonetheless because this is also something that you want to search for. So in this example, I have already started my virtual machine, and you can start it on task number 29. The task that we have is how many characters are in /etc/passwd file. We can use this command to determine that. So let's give it a try. Let's copy the IP address of our machine and copy it straight into the browser. Okay, so it opens this application that's called Online CSE Bookstore. And since we already know what type of vulnerability this is, we would actually try to scan it for different technologies that this application runs. What web server it has, what programming languages does it use, and all of that. But particularly, we also want to check out the application name. So for example, this online bookstore could be something that is used widely and that actually has some known vulnerabilities. How can we determine whether it has known vulnerabilities? Well, we can just copy its name and try to find something on Google. Now, make sure that you don't confuse this vulnerability with the vulnerability where we covered with default credentials. Default credentials are something else. That is the mistake of the owner that they didn't really change their default credentials. It's not a software vulnerability. However, this might have a software vulnerability, and by the results that we get, it does indeed have them. We get 2 results, or even 3 results right here, but only the first 2 are on famous exploit website, which is called exploit-db.com. On this website, you will have a bunch of different exploits for a bunch of different outdated versions of software. Let's go with this first one first. It's called Online Bookstore, Unauthenticated Remote Code Execution. This is really a serious vulnerability. And how this website works is it gives us the code to the exploit. In this specific example, the code is written in Python. Now, we can download the code by clicking on this button, and what's good for us is that we don't really need to know what exactly this code does, even though that is something that you want to get used to. You want to get used to reading code, and even better would be if you were to learn some programming language, because you will need it sooner or later once you get into this field of ethical hacking and bug bounty. Nonetheless, we're not going to refer to this code that much because programming is not a topic for this course. However, we're going to download this code and run it and see what it does. And that is also another reason why you actually want to learn programming. You don't want to be running any type of exploits on your machine. If you don't know what this code does, then you won't really know what it will do on your machine. It might do something malicious, you never know. Especially when you're downloading exploits from some sketchy site. Nonetheless, this is exploitdatabase.com, and it should have a working exploit for us. So let's open the folder where we downloaded our Python code, and it's called 47887.py. to run it, we can open terminal in this folder, and we can simply type Python 3 and then the file name. Hopefully this will give us some help menu that will tell us how exactly can we run this program. In this case, the help menu says, error, the following arguments are required. URL, which is pretty common sense. We need to specify which target are we attacking with this exploit. And in our case, it will be this target. So let's copy the IP address to our online bookstore. And let's go back to our terminal and run our exploit like this. Let's paste the clipboard and press enter. Do you wish to launch a shell here? Let's specify Y for yes. And here it is. We opened a remote command shell, and now we can execute the commands on the target system. If I type who am I, it will give me the result. If I type ls, it will also give me the result. And now I'm pretty much on that machine. I can do whatever I want on it. And this is the power of exploiting outdated version of software. We got the remote code execution vulnerability, and now to finish it off, let's go right here. Let's copy the command that they tell us to run. Let's paste it right here and run it. And the output that we get is 1611. Let's copy that, specify it right here as our answer and submit. And it's the correct answer. So you saw how serious this can be. You can be protected by all of these bugs such as SQL injection, such as XSS, HTML injection, XXC, and all the others that we covered, but if you're running outdated software with a known vulnerability, there is most likely going to be a code out there online or an exploit out there online that we can just download and run and get straight into that machine. We pretty much gained access to it in 2 seconds from running this exploit. But even when you find something like this, that's not where you want to stop. There could be other vulnerability as well. For example, we did notice, let me go back, we did notice another link right here that is from exploit.db. Whoops, I have no idea where I went. Yeah, it's this link right here from exploit.db, and it could be another exploit. So we want to take a look at that one as well. And this one seems to be an HTTP request. Let's read through it. CSE Bookstore is vulnerable to an authentication bypass vulnerability on the admin panel. By default, the admin panel is located at /admin.php, and the administrator interface can be accessed by unauthorized users exploiting the SQL injection vulnerability. We're already familiar with SQL injection, so let's give it a try. Why not? Even though we found the vulnerability and we finished the task, we still want to discover all the other vulnerabilities. So let's see how can we access the admin panel without actually manually adding /admin. And here's the admin login page. Let's click on that. We get the login screen, so let's try with the basic SQL injection test single quote or 1 = 1 with single quotes, and we use the same thing in the query. Let's submit this. Oops, yeah, we're logging in as admin. We don't really want to use the SQL injection as the name. We only want to use it as the password. So here we're simply going to type single quote space or single quote 1 single quote equals single quote 1. Let's submit the query. And here it is. Our SQL injection worked and we found the second vulnerability, and now we're logged in as admin. How cool is that? We even used knowledge from some previous section to exploit another vulnerability on this page. Cool. Now that we covered this, we're only left to cover one more thing in the next lecture, which is called insufficient logging and monitoring. See you there. Okay. This is the last thing that we have left to cover. Now, this is not necessarily a bug, but it's something that could be useful for you to know. and that is insufficient logging and monitoring. Now, most of the websites and applications and all of that have their own logs. And log is something that is tracking different traffic, perhaps on the website, different HTTP requests, different form submissions, and all of that. It is a good skill to know how to read different logs, and it's rather easy most of the time. So let's take a look at this quick example right here. So if we click on insufficient logging and monitoring, which is task 30, I advise you to read through this to get a better grasp as to what this actually is. And now we're going to download the task files. So there is not a virtual machine that we must start. Here we are downloading files. In this specific case, it is a file login.txt. Let's click on save. And while that is downloading, let's go down to check out what are our challenges. So the first question is, what IP address is the attacker using? And the second question is, what kind of attack is being carried out? Let's go to our file. Let's open it. Double click login.txt and it will open this small logs file. By the first look, I can already see that it is a part of a log file from different users trying to get access on a website at /login directory. So they're most likely trying to log in with username and password. We have 200 code OK for first 6 users, and that means that they successfully logged in to the page. This is most likely their usernames right here, and this is the time when they performed the login request. Here we also have their IP address. So what is off right here? Well, these 401 requests that say unauthorized do look suspicious. Of course, it can be different users that mistyped their passwords, so they got unauthorized error. But we will notice that it's all coming from the same IP address. So all 4 requests are coming from the same IP address with different usernames. This could point to a brute force attack, for example. We can also see that the user is trying to authenticate as the admin, so that is also suspicious. So we can conclude that this user right here is trying to perform a brute force attack, for example. Let's answer the first question. What IP address is the attacker using? So let's copy the IP address like this, specify it right here, and for some reason it won't copy, so let's just type it 49991316. Let's click on submit, and that is the correct answer. What kind of the attack is being carried out? Well, we already mentioned that it's most likely a brute force attack. So let's specify that right here. Click on submit, and that's also the correct answer. So this was a quick example of how to read logs and how to find something that might look suspicious. Nonetheless, let's move on to the next lecture where we are going to cover how can we monetize bug bounty skills that we learned throughout this course. Alright, we came towards the end of the course and now is the time to discuss, well, how can we earn money with the skills that we learned? Is it something that we can monetize, or is it just additional knowledge that we gained? Well, let me tell you. You can monetize bug bounty, and you can monetize it really well depending on how good you get. But before we talk about where and how to do it, let's figure out what the next steps are before we get to earning money with the skills that we learned. Well, picture it like this. This arrow is your path. At the beginning of this arrow is you, a bug bounty hunter that just finished this course. And at the end is you earning money from bug bounty. The only thing that's in between is practice. There is a lot of practice waiting for you to really master this skill. The only way to get comfortable with bug bounty is to perform all the attacks that we covered numerous times on different applications. You might also discover some new vulnerabilities in the meantime that are also useful to know. You can learn more about bug bounty through various different websites, courses, books, and bug bounty programs. Once you do that, you're ready to hunt down your first bug. Okay, let's say you're ready and you practiced and feel comfortable doing bug hunting. Well, what now? Where can I submit my bugs and earn real money? Okay, have you noticed how I mentioned something called bug bounty program? Well, there is your answer. There are numerous online platforms that host different bug bounty programs that pay real money. How exactly does it work? Well, it's based on different companies applying on the platform for bug bounty programs regarding their website, their application, or software. On the other side, there are hackers that also applied for that same bug bounty program, and their goal is to find a bug on that company's product. First thing they do is accept terms and conditions and rules for that bug bounty program. After that, if they fulfill the requirements, they are allowed to explore for vulnerabilities on that website, for example. If they find the vulnerability, they are then rewarded with a payment which can be different depending on the vulnerability severity. Once the hunter gets paid, the company then patches the vulnerability and it is no longer vulnerable to that attack. It's simple as that. But listen, there are some important stuff here to mention. Remember when I said that hacker accepts terms and conditions and rules before he enters bug bounty program? Well, these terms and conditions are not something you want to skip like you skip them on every other website. Here they are really important. For example, in the bug bounty program rules, it could say that certain types of attacks are not allowed, or that certain domains are not for targeting. It could, for example, have a rule that DDoS attacks are not allowed, which is a common bug bounty program rule. If you don't bother reading those rules and you do what you're not supposed to do, like running a DDoS attack, for example, well, then you can get in trouble for doing something that you're not allowed to do. Nonetheless, I'm sure all of you will follow the rules and there will be no problems with that. Now that we covered how earning money with bug bounty works, let's mention a few platforms that are hosting bug bounty programs. We have HackerOne, Bugcrowd, Integrity, Synack, and there are others, of course. But these are one of the most famous ones. Let's go on one of these to see how the web page looks like. Okay, I've chosen to show you Bugcrowd. It's one of the biggest platforms for bug bounty programs, and you can find it at the link of bugcrowd.com, or you can simply just type Bugcrowd in your search bar. Once you do that, let's navigate to their webpage and see what they have to offer and how all of this stuff works. So the first page that it opens will be this one, where you will have this How It Works button. You can click on that and you can read more about bug bounty programs and all of that. Of course, we are not going to go through all of this. You have an explanation how it all works, but that is something I leave up to you to read. Another useful thing that you have and that you will notice in the upper right corner is this researcher portal and customer portal. What is that? Well, you can create an account for two different situations. Either you're a security researcher or a bug bounty hunter, or you're a customer or a company that wants their product to be tested for bugs. That's how you would register accordingly. As a bug bounty hunter, we would go to researcher, and we can also click right here on researchers to read more about that. If we scroll a little bit down, let's see if there is anything interesting here to say. So we have a few different programs: bug bounty, penetration testing, vulnerability disclosure, attack surface management. You can also learn even more and upgrade your skills with different programs, but that is also something that I will leave up to you. Now, let's get to the important stuff, and that is this programs. If you click on programs, it will open this page with all the different bug bounty programs that this platform offers. And you will notice there are some really big companies out here. We have Cash App, we have Upwork, we have, let's go all the way down, Indeed, Jora, and you get some of the information about certain bug bounty programs right here. For example, how much they pay. It says down here managed by Bugcrowd. So let's take a closer look at one of these programs. Let's go with Upwork. Now, Upwork is a big platform. It's a freelance platform. And let's see what do they have to offer us and how exactly does their bug bounty program look like. Remember, there are a few important stuff that we must take a look at before actually applying for any bug bounty program, and that is their terms and conditions and rules. So up here we will get that they're paying up to $5,000 per vulnerability, and it can also go up to $10,000 of maximum reward. Now, you will see later that the actual amount that you get paid is based on the severity of the vulnerability that you found. Let's go all the way down. We have special bonuses and rewards. You would actually want to read through all of this if you were to apply for this program. On the right side, we have how much vulnerabilities are rewarded. So 470. And the average payout was $648. Now, if we go even more down, here is the important stuff. Scope and rewards. Here you will have the description of what exactly are you going to, let's say, perform a penetration test on or try to discover bugs. They will tell you which application it is, which domain it is, what you're allowed to do, and up here we also get how much they're willing to pay per vulnerability. And you will notice these signs right here: green P4, orange P3, red P2, and, or is this orange? I'm not really sure. This could be yellow P3, orange P2, and red P1. Now, we'll discuss that in just a second, but let's scroll a little bit more down. And here is also important stuff: out of scope targets. These are the targets that you are not allowed to perform penetration tests on or discover bugs. If you do so, you can get in trouble and you can get removed from the program and not rewarded at all. And that is the easy way out. You can also get sued, but hopefully you will read through all of this information before applying for any bug bounty program. Down here we have ratings and rewards, and we also have requirements. So this is also important to read before applying. They want the user agent to participate in the Upwork bug bounty. Please configure your scanner to include Bugcrowd in the user agent string. Failure to do so may result in your IP being temporarily blocked from participation in the program. Access Upwork account. You can self-register for an Upwork account and Upwork API using your Bugcrowd ninja.com email address. Testing using any other account is out of scope. So this is also some important stuff. Down here we have target information, access and credentials, exclusions, and to really understand these vulnerabilities, you can scroll all the way down, and down here you will have program rules. This program does not offer financial or point-based reward for P5, informational findings, which is probably information gathering vulnerability or information disclosure. And here you will have the list of different vulnerabilities and also how they are rated by severity. So here you can take a look at what different vulnerabilities belong to P1 technical severity or the highest severity. So we have SQL injection, XXE, remote command execution, command injection, disclosure of secrets, and many more. You can read through all of these different vulnerabilities to understand what level each vulnerability is. Okay, awesome. And that is pretty much all you need to know to start with bug bounty. Nonetheless, we are at the end of the course. There is a lot of practice still awaiting you to really master this field, which I'm sure you will. Everything else is on you. If you have any additional questions, feel free to ask and we will be more than happy to answer. Thank you for watching and happy hacking.
Hello! That was a little bit excessive, but I'm very, very excited to start the course. So in this section, we're going to be talking about browsing the web. It's the first part in the how the internet works section. And some of you are thinking right now, whoa, Andre, like, come on. I know how the internet works. Let's get to the heavy, technical stuff. But this is something that actually took me quite a few years to learn. And I see a lot of people just skimming the surface of this stuff without fully understanding how everything works together. Without having those foundations, it's actually very, very difficult to think about performance, optimizing your site, and so on and so on. So we're going to start off very, very basic, and we're going to learn something that it took me many years to learn. And once I figured this out, everything clicked. So just hang in there. Trust me. I promise you'll learn something new in this section. And we're going to be talking about browsing the web. We have over here a laptop, and we have a web browser, let's say Google Chrome. And we typically like to say, go to Google, and we're going to visit Google. So we type in google.com, and well, what happens technically when we do that? When we enter google.com, we press enter on our keyboard. We ask a question. Who's this google.com fellow? And that question gets asked all the way down to our ISP. ISP is Internet Service Provider, and I put a $sign up here, just so you know those are the people that you pay so you can have internet. So if you're in the States, that's Cogeco, Verizon. If you're in Canada, that would be Bell or Rogers. Or, depending on your country, you have your big companies that make a lot of money from internet usage. So they get that request and they send that off to something called the DNS server, so domain name servers. And we'll get into that later on in the course. So don't worry too much about it, but essentially it's a phone book that has the list of all these URLs like google.com, and it has the addresses of them. So exactly like a phone book, they know where google.com is. So they say, hey, I don't know Mr. Google.com personally, but I do know his address. So you should go check him out. So they send off that request back through the ISP, and the website or the web browser, Google Chrome in this case, gets 172.217.723. All right, cool, but nothing's showing up yet. There's no google.com. I can't do any searches yet. Okay, we received what we call an IP address. So think of this as something that every single computer has one. Anything that's connected to the internet has its own address. So the laptop that I'm working on right now has an IP address. Your laptop or computer has an IP address. So this IP address allows the internet to work essentially. It knows our location, our address. So what we do now with google.com, we know this IP address. The browser sends off another request to the Google servers, and it knows where the Google servers are because we have this address. So we go seek it out, and you can think of servers as computers essentially. My laptop could be a server, your computer could be a server. Servers are essentially computers that are sometimes in basements or in huge server farms, and they have a piece of software running that, just like at a restaurant where a server brings you food, it knows how to send you files when you request for them. So we send this off, and the Google servers say, oh yeah, no problem. Let me give you my HTML, CSS, and JavaScript. And we'll get into what those are later on in the course, but think of them as just text files. There are text files that Google is going to send to the browser so we can have Google working. So let me just minimize this and show you what it's doing. So we're copying these files, and Google server is saying, yeah, no problem. Thanks for asking for Google. Here it is. And the web browser receives the HTML, CSS, and JavaScript. So if we go to the next section, boom, we have google.com, and everything's working. Now, that sounded like a whole bunch of stuff that happened in between. And when we're on the internet, everything is quite fast. But yeah, underneath the hood, all of that is happening. And it's crazy to think how fast everything works. Don't take my word for it. Let's just check this process that I'm not just making stuff up for you. If what we learned was correct, technically, we can skip this process, right? I mean, if we know the address of Google, can we just, go into this directly and just, instead of putting in google.com, just put in this in our search bar and it automatically goes to the Google servers? Well, let's try it out. Let's open up Google here. And, ooh, what a pretty picture. All right, so we go to google.com. Nothing crazy here. And that's great. But what if I, instead of that, I put in the IP address? So 172, there's no way I could remember this address. So I've done this before. And I press enter. Look at that, google.com. So as you can see, I'm not lying. It's what's happening. The IP address gets sent to the Google servers. Google servers send us a few files so that we can finally load google.com. In the next section, we're going to do something fun. We're going to break a bit of Google and toy around with the website again to show you how cool all of this technology is. See you in the next one. Bye-bye. Welcome back. In the last section, we talked about how we have google.com, and if we enter an IP address, we essentially get all these files from Google. So if we look back at the diagram that we had, we see here that the Google servers just send us a couple of files, which are HTML, CSS, and JavaScript. Again, something that we'll cover later on. But for now, based on that knowledge, we should be able to break Google. So let's play with something. If you open up Google Chrome and you go into View, then Developer, then Developer Tools, you're going to have a screen over here that pops up. You might want to move it up and down just so you can see better. Let me just scroll this down a bit so you can see. You'll see over here that there's a little icon on the left with a pointer and a window. If you click on that and now go to the website, you'll see it selects a bunch of different things. So it's just an element selector. So let's just click on this. So when I click on this, it takes me to the part of the HTML file that essentially tells Google to put in Google search here. So based on that, we can do something fun. We can get the value over here of Google search and let's change it to Andre search. Press enter. Look at that. We now just changed Google to have Andre search over here. That's very, very cool. I want you to play around with that and see what you can do. For example, if I now select this and I'm just like, I don't want this, I'm going to press the delete key and just delete it. Look at that. I can delete that. Okay, I don't like that either. I'm going to press delete on that as well. And let's see. You know what? I want the entire website. I want this entire body thing gone. Delete. Look at that. We just completely deleted Google. Now, you must be freaking out. What happened? Am I going to get sent to jail? I just deleted Google. Well, no, not really. Press enter and Google is back. Now, why is that? Well, if we go back to our diagram, we have Google servers and we were playing around with one of these files and we just modified it. We essentially just said delete, delete. So Google was gone. But when I made that request again, Google servers, no problem. We have these files. They send these files all over again back to the server. Hopefully that made sense to you. We see that the browser essentially is a tool, a piece of software that can receive files from servers and it knows how to read them so that, look at that, we get pretty Google and we can type in all the searches that we want in the world. All right, let's get to the next section where we talk about the internet backbone. See you in the next one. Bye-bye. Hey there, welcome back. All right, if you thought so far everything's been really, really cool, well, things are going to get a lot cooler. We're going to be talking about the internet backbone. So we recognize this because I've been talking about it for the last couple of lessons. But some of you may have had a question that is, what do the arrows mean? I mean, it's kind of like magic, right? I just told you that we send off the IP address to the servers. The server responds with some files, but this is just magic. Like, what do these arrows mean? So we're going to talk about that in this lesson. And we're going to do that with this really, really fuzzy diagram that I found online from this website. It's not the clearest picture, but it actually has some really important things. So I want to use that to demonstrate to you what the internet backbone is. So as some of you know, the way we connect in our homes, at a coffee shop, or at work is we usually have Wi-Fi, or maybe sometimes we still have people that are using Ethernet cables and connecting through those. But for now, let's just focus on the fact that we have a home and we have Wi-Fi, and this Wi-Fi essentially gives us internet from the router. You can see this little person over here working hard with a router next to him. And this router is connected all the way to something called a modem. And this is something that if you ever signed up for internet or changed providers, you most likely had somebody come to your house and install something. And that's this box over here that essentially allows the ISP, the internet service provider, this big building over here, we remember that, to connect to it. So this modem has these signal towers that transmit signals of, google.com, and it receives these messages. And then this is why I picked this image, just because I think it's incredible. You see this wire that is connected all the way to the ISP, and then the internet service provider, the ISP, is connected to this magical blue cable that is the internet backbone. And something that's really important in this image is the fact that there's Wi-Fi, which is over the air, but at the end of the day, everything is kind of connected through cables. So some of you, or many of you, or all of you might be wondering, what the hell is this internet backbone thing? Sounds cool, but this kind of vague. So I found a really, really cool thing that we can do together. I'll post this website in the notes after this lesson, but if you go over here, you actually see the internet backbone. So let's say we're in Brazil and we wanted to search google.com. Well, from Brazil, from our home, through Wi-Fi, it connects to our router, to our modem, and then all the way to our internet service provider. Let's say it's internet service providers over here. And then through cables, it connects all the way to, let's say, this point over here. And let's say for now that the Google servers are located somewhere in Portugal over here. Well, that signal of me looking for that IP address of Google and looking for those Google files is going to go through this submarine cable. Yeah, you heard that right. It's a physical cable that goes at the bottom of the seafloor from Brazil all the way to Portugal, where the Google servers are. And then the Google server says, yep, I got those files. Here they are. And sends it all the way back through the ISP, all the way back to our house. Like, isn't that cool that there's physical cables that are connecting and creating this internet? So, there are times where somebody destroys or something happens where these cable connections are cut off and you sometimes lose internet connection that way. But yeah, the internet backbone is literally just this network all over the world of connected cables so that we can transfer these files all over the world. And just to show you how insane this is, somebody from the Opti project over here, I got this off of Wikipedia, mapped out in, I believe this was in 2015, just 30% of the network. And you can see over here that each one of these dots is an IP address. So a computer that is connected to another computer, that is connected to another computer. And that's the internet. The internet is just all these connected computers that are just transferring files between each other. And as web developers, and this is the coolest thing, and that's why I just think everybody should be a web developer, because it's so cool. You're allowing this to happen. You're allowing this transferring of files from one computer to another, transferring knowledge from Brazil to Portugal and all over the world, and you get to be part of it. You get to be part of this network and you get to evolve. When this picture of the internet came to me, I knew that this was the career for me. So hopefully that gets you excited. In the next section, I'm going to show you something really cool, traceroute, before we finish up the lesson and we get into the next sections. So hope that was cool. See you in the next one. Bye-bye. Hello, welcome back. We mentioned in the last lesson that we're going to be talking about traceroute. What is that? Well, I just wanted to finally get the entire picture of the internet across, and I think this is the best way to do it. Now, if you're on a Mac, you're going to press Command Space and look for a program that comes with your Mac called Terminal, and you're going to press Enter and you're going to get this. So it's an application that all Macs have. If you're on a Windows machine, it's called Command Prompt, and in the exercise right after this lesson, I will show you instructions on how to access that as well. We're going to talk about traceroute. And if you remember, we spoke about this image of all these connected things happening and going to the internet backbone, and then Google.com finally sends us the files back to our house, and you can actually monitor how that's going to work using traceroute. So if we type in traceroute, and on Windows machine, it's actually traceRT, but for now, we'll just go traceroute, and you can request for whatever website you want. So let's go with Google.com. I press Enter, and yep, look at that. It gave me a whole bunch of hops that it did. So you can see 1 through 9 here. So it did 9 hops. So that means 9 stops to this address at 172.117.1.14. So again, that looks like the IP address. So again, let's always test our experiments here. If I put that in and press Enter, we should get Google.com. Let's see. Look at that, Google.com. So that's a fun little way of you to see where your requests go, and you can monitor. You can see all these IP addresses are different computers that are trying to locate the Google service. So go ahead in the next section. There's a little exercise. You can play around with this and just see where all your requests go all over the world. I think it's very, very cool. We're going to finish up in the next section with some fundamentals and what we can do with this knowledge that we have to actually become really good web developers. So see you in the next section. Bye-bye. And welcome back. In the last section, we talked about the World Wide Web and the internet and what the differences were. And then I promised you that we'll finally talk about some HTML, CSS, and JavaScript. So I've been vaguely referencing these files and just told you that they're simple text files for now, but what are they specifically? Well, initially, if you remember, we had Tim Berners-Lee who created the very first website. And this website uses HTML. And HTML, that's the first file over here, is a way for us to just write text on website. And these texts on websites can also have these things called hyperlinks that can link to other parts of the website. So that's what happened in 1991. 1991, we had a way for us to share documents. And this can link to another website, another file, another research paper. But as you can see, it wasn't the prettiest. So in 1995, 1996, 2 technologies came into being. One was CSS and one is JavaScript. Now, what did they allow you to do? Well, CSS solved the problem of, well, this is nice and all, but it wouldn't be nice if we had some visual aspects. We can toy around with this website and make it look pretty. And then JavaScript said, well, ideally we'll be able to have something like this website where, I can click over here, I can shop now, I can put in my credit card and get these fancy slippers, and I can do all this interactive things with my website. So let's play around with this and try and incorporate from this basic HTML file to add some CSS and JavaScript to this page. The way we're going to do that is we're going to go into View, Developer, and Developer Tools. So you might remember this from our previous lessons. So once you click on that, you'll get this pop up at the bottom of the screen. For some of you, it might be on the right side, but it doesn't matter. You'll get both things. And we've seen this before. And if you look at the top over here, it says HTML. And that's it. HTML is this. It's this file that has this weird syntax that describes how this web page should look in text. So you can see over here, it says the World Wide Web. These are just text. On the right side over here, you'll see something called styles. So styles will actually let you add styles to the website, as the name suggests, and that's what CSS is. If we click on HTML here, and actually let's click on body. Without knowing any CSS or anything, if we define something like color, semicolon, and then let's go blue, it changes the text color to blue. Chrome lets you play around with websites and actually injects some CSS into this HTML. Without knowing any CSS, we can kind of play around, type in a letter, and it will have a drop down. So let's see over here if we can do background color. Let's make it, I'm going to press tab, I'm going to do red. Make the website really, really, well, frankly, pretty ugly. But that's CSS right here. We've just added some CSS to this basic website. Let's turn this red color off because it is not pretty. Okay, so HTML, text and links, CSS, pretty colors. Now, how can we add some JavaScript? So remember, we have 3 files over here. JavaScript came along and said, these are great. You know, we have these beautiful text websites that link to other pages, and we have CSS that can make websites really, really pretty. But would it be nice to have some interactivity, to have drop-down menus to make websites like they are now, interactive? We can actually do this, again, with the developer tools. If you click on console over here, without knowing any bit of JavaScript, for now we're just going to show you a simple JavaScript line. And we're going to type in alert, and let's say, hi there, exclamation marks. And I press enter. And look at that. We just made the very first website ever made interactive with JavaScript. Now, obviously, this doesn't do anything, but hopefully this shows you where we were before in 1991 to where we are now. Websites that are interactive, full of JavaScript, CSS, and of course, HTML. See you in the next one. Bye-bye. Hello, and welcome back to a very exciting section. Why is it exciting? Well, we finally get to code, and we're going to start off by learning HTML and then finally building our very first website. In order for us to get started, we need to set up our environment, and we do that by, let's open up Google Chrome, and we're going to search for Sublime Text. This is a text editor that a lot of developers use. I myself have used it for years, absolutely love it. In your day-to-day job, you'll use something like this. I highly recommend Sublime Text. If you have a Mac, the version over here. If you have a PC running Windows, you'll have the download link for Windows. So for me, I'm going to download for the Mac. And you can see here it's downloaded, and I can drag it to my applications folder if I want. And we can double click. And if this is your first time downloading Sublime Text, you'll get something like this to give it permission to load. And there you go. We have Sublime Text. Now, what is a text editor? A text editor is a program that allows us to write code. You can see over here on the right-hand side of Sublime Text that it just says plain text. So I can type anything that I want, and there's nothing much different than if you wrote this in Word or a text file. But the power with a text editor, especially with something like Sublime that's geared towards coding, if you click on plain text here, you'll have a whole bunch of options of what type of code you're writing. So in our case, we're doing HTML. So if I click on HTML, nothing changes except for the bottom part over here. But now, if I type something, well, everything looks the same. But if I start typing HTML, it'll actually recognize it and help with syntax. So here, now, if I write HTML, look at that. We get a nice little color completion. So for us, for now, we're going to be writing HTML. You can see over here that there's different options. There's, where is it? There's CSS, JavaScript, which we'll learn later. So we're going to be using Sublime Text for this. For now, click on HTML. and let's write our very first web page. In order for us to have a web page, we write HTML, which stands for Hypertext Markup Language. So bear with me here. This is going to be new, but keep in mind that this is exactly what every single HTML page has. These are the set of rules that all HTML files must follow. And it goes like this. We define a doc type, and don't worry, I'll get into what that means in the next video. Then we have HTML, and we close these tags, HTML. The second part, we have a head and a closing head. You can see over here some patterns forming. Don't worry, I'll get back to these tags and explaining what they do in a bit. And then we also have body and then closing tags. And finally, here in the head, we have something called a title tag. Okay, so this over here is the rule that every single HTML file must follow. Just looking at this right now without knowing any HTML, you can get an idea of what everything means. So HTML, we're defining that this is an HTML. We're saying that this is the head of the HTML with the title. And we're saying that this is the body of the HTML. So let's try something here. Let's save this file. And we're going to save it. Let's do desktop. And we're going to call it index.html. You can see that it's already completed the HTML syntax for us. Save. And we have an index.html file here. Let's drag this all the way down to our Google Chrome and open it up. And well, nothing happens. But let's add a bit of text to it. So in the title, I'm going to say my first website, exclamation mark. And then in the body, I'm just going to put hello there. Okay, so if I save this, and just to show you from now on, I'm going to be doing Command S to save, just because it'll be faster. And now, if I refresh this page, I have hello there. And you can see the power over here of what we just did. We have hello there as the text, which is in the body. And then we also have my first website as the title. And you can see over here in the file that we're referencing index.html on my desktop. So we can see here that we have HTML, we have the head, which we haven't really talked about yet, but we see that the title's in the head, kind of like a header. And then we have the body, which by looking at this, we can assume that it's whatever shows up onto the web page. Before we expand on this and make it a little bit, well, prettier, because now it's just simple text, I want to reiterate the fact that what we've just done is very similar to what a server does. If we go back to our mockups here, you remember that when we enter google.com, the servers send us an HTML file back. When we move the index.html file all the way down to Google Chrome, that's what we just did. We mimicked a server and we gave it to the browser to load up the HTML file. And because browsers are built to know what HTML files are, it can read the syntax and say, okay, yeah, this is an HTML. Okay, you want my title to be my first website, and you want my body to say hello there. That's perfect. These are the default HTML rules that you'll see all the time. It is a little bit confusing at first, but this is it. You just have to remember that there is a tag, so an HTML tag, a head tag, a title tag, a body tag. And these tags usually have an opening and a closing. There's some exception to this rule, and we'll get into that a little bit later on in the videos. But just remember this for now. So I want you to try creating your very first website and seeing how it works. And once you're done with that, I want to show you that Sublime Text actually has a nice shortcut, so you don't have to keep writing those tags over and over. So the way you do that is you type in HTML and then press the tab key. And it loads all this up for you. Okay, so now that we've done this, I want you to go off and create your very first website. I know it's very, very simple. You can put whatever you want in the title and you can put whatever you want in the body. And in the next video, we're going to start expanding on our first website. I'll see you in the next one. Bye-bye. Welcome back. In this video, we're going to expand on our knowledge and introduce you to a few more HTML tags and make this website look a little bit prettier than just hello there. To get started, I'm just going to move the screens around so you can see better. All right, so we have the left and right. And again, just to make sure everything works, if I change anything here to boo, and then I click save, and then I refresh the page, I have everything updating. Perfect. Now, these aren't the only HTML tags that you'll encounter. There's actually a ton of them. And if you go back to the w3schools.com, you'll see over here all the HTML tags that exist. There's a lot of them. We're only going to be going through, I would say maybe 10 or 15 or so, because those are the only ones that, well, technically that I've used in many years of development. There's a few things on here that I've never even heard of, I've never used. You can always look these up and learn them yourself, but I'll say that there's about 10 or 15 tags that are used 99% of the time, and those are the ones that you'll encounter. So we'll go through some of those most popular ones. And HTML doesn't really get any harder than this. This is the syntax. As long as you get used to these little signs and structure, you're pretty much a HTML developer. So the first tag that I want to introduce you to is the H1 tag. So the way that I have it here is actually not right. You want to make sure that everything is surrounded by a tag. So a web browser right now can see boo and just print out boo. But if you want to do it right, you'd want to put something like an H1. And an H1 tag, if I save this and I refresh, we get what we call a header. So that is a header and then 1. What does 1 mean? Well, it actually goes all the way up to 6. So if I change this to 2, and I'm not going to do every single one. Let's just do another one. H6, boo, H6. And if I save this and refresh the page, you can see that there's different sizes in the text. So that's the header tag. And again, if I scroll through the W3 schools and I go to the H, you see over here that there's the header tags explained here. And this website is really, really cool because you can actually click on try it yourself and you can play around with different things. Click run and it changes it for you. So again, this is a really, really good website for you to get familiar with all the tags. But again, we're going to stick to our website for now. Another thing that I want to introduce you to is something called a p tag or a paragraph tag. A paragraph tag lets you have paragraphs. So now if I refresh, well, there's not much different from what we had before, which was no tags and just saving it. Refresh. But you can see the difference when I copy and paste this and have a few paragraphs versus this. Let's see what happens. So I save this. You'll see over here that with Sublime Text, after, I don't know, I want to say about maybe like 20 saves, it'll ask you to make a purchase because technically this is an unregistered one. You can ignore it for now, just click cancel. Again, it's just one annoying thing that will pop up every now and then. I actually have a registered Sublime Text. I just wanted to show you this error so you're not surprised when you see it. Use Sublime Text for as long as you need it for free. When you start getting into the developer role and working full-time with it, I do recommend that you make a purchase. It's a great program and you still get everything through the unregistered. You just have this pop-up that shows up after a few saves. But anyway, from now on, I'm going to be using a registered Sublime account. I just wanted to show you that error. If I refresh the page here, you'll see that I have the paragraphs show up nicely, but these unstructured pieces of text, well, everything's kind of in line, and HTML doesn't really know what to do with it, so it puts everything on one line. I also want to show you one other quick trick in Sublime Text. So writing this gibberish is not very exciting and kind of takes a bit of time, and developers are lazy. We want to make sure that everything is done fast and efficient. So if you actually put lorem here and then press tab, you'll get lorem ipsum paragraphs. So let's do that. I'm going to delete that, lorem, tab, and then one more, lorem, tab. Perfect. Let's save that and refresh, and we have nice paragraphs. As you can see, we have some tags and what we call nested tags. So you can see that the body is the parent, and Sublime Text actually lets you close and open these. So you have the body tag, you have the header tags, which are children of the body tag, and then we have p tags. A lot of people get confused in the naming. I've mentioned these as tags, so essentially anything that has this syntax is a tag, but this is called an H1 element. So that's when it's an entire block of functionality with content inside it. So again, tags, and then this is an H1 element. Again, it's just naming, but you'll hear tags and elements kind of used interchangeably, but those are the specific differences. All right, let's get into some of the more exciting things. Let's say, for example, I really want to emphasize lorem ipsum here. Well, I can use another tag, b tag, and then we close it at lorem ipsum. And let's make the screen here a little bit bigger just so you can see. There you go. So we have the b tags over here, and if I click save, I refresh. Oops. No, we don't want to translate this page. We see that this is now bolded. Again, let's make it a little bit bigger. There you go. Now, this syntax is actually not used anymore, or it's not recommended. Obviously, it still works. But there was a problem that HTML was initially used for websites that ran on computers, on PCs, on Macs. And now we have things such as mobile phones and iPads. Although the bolded text, and we actually have another one, which was the italicized I. Although we had this, for most phones, some of them didn't have ability to bold the text and didn't have the ability to italicize. Or some screen readers, which people who are visually impaired use, didn't really understand the meaning behind italicize and bold. So now we use something called strong for bolded, and refresh. And then for italicized, we use EM for emphasis. And there you go. Now, the reason this change was made was a move towards something called semantic HTML, and we'll get into that into a later lesson. But just know that there's some tags that have evolved over the years, and it's part of why HTML5 exists. We'll get into that a little bit more, but just wanted to give you a quick note on that. All right, I think that's enough for now. We're going to get into more tags in the next video. For now, play around, and I'll see you in the next one. It's time to flaunt your inner designer because we're about to learn some CSS. To start off, I want to show you this website. If you look at it, well, it's quite pretty. Look at that. That's really nice. Now, hopefully, in the future, we can create something like this. But I want to show you what this website will look like without CSS. Here it is. Pretty impressive, right? With just CSS, you'll be able to create something like this. So let's get started, shall we? I've created here for us a simple website. Nothing that we haven't seen before. You can see that I have created semantic tags with header, nav, an unordered list that has some links, a p2 and a p tag that's wrapped in another semantic tag called section. Okay, so again, nothing crazy. If I go to the about page, it's the exact same thing except for the about li doesn't have an anchor tag. And then same with login. Okay, so let's talk about CSS. The way that we would add CSS to something like this is, well, we create a CSS file. So let's do that. I'm going to create a new file that I'm going to save. Let's call it style.css. If I save that, you'll see at the bottom over here that Sublime Text now has CSS as the file type. The rules with CSS are very simple. We essentially have a selector, and then we have these squiggly brackets, and within it, we put our property, semicolon, and then value. And then we have this special character as well at the end. And that is pretty much CSS. You know this, you can write CSS. Just like HTML, just a couple of syntactic rules, and once you get used to it, it's very, very simple. But obviously, this doesn't really mean anything, so let's write actual code here. I'm going to comment that out by, again, doing command/ in Sublime Text. You can see that the commenting is different than in HTML. And let's say that we want to make this home text red. The way we would do it is we want to select what's called the selector. So here we want to say that the H2, we want that to be red. So all I would say is H2, curly brackets, and then within here I want to say the property. I want to change the color to the value that is red. So if I save that and refresh, well, nothing happens, and that's obvious, right? Because how does this file know that this file exists? We have to link it somehow. And we do that in the head. And we haven't talked too much about the head tag element in the HTML section. But by now, you can probably tell that head just contains information about what the page needs. Maybe not the stuff that we see on a web page other than the title, but meta tags and information that we need for the website. Okay, so in here, we can actually link to this style sheet that we call style.css with a link tag. And this link tag allows us to link this HTML file to something else. And again, Sublime Text has something very useful here. If I hit tab, look at that. It autofills it for me. These are the standard attributes that you'll see to link to CSS. So you just have to get used to it and eventually it'll become second nature. So we have rel here, which is the added attribute for relation. It just specifies what relationship this link will have. And we have the default style sheet. And then for the type, this is the media type. We want to say that it's a text CSS file. We're essentially telling HTML, hey, just a heads up, we're linking to a CSS file here. And in the href, this should be familiar. We're going to link to style.css. So if I type in style.css and save, let's refresh, turns red. And just to let you know that index.html is in the same folder as style.css. We can check it over here. If I click on exercise, you see that, yep, I have style.css with index.html. Perfect. Okay, now what if we also want to make the paragraph over here a separate color as well? Well, again, we would do the selector, and then we'll do color, and let's do pink. I save, refresh, and it's pink. Hopefully you can see that. You also see here that Sublime Text does some really nice coloring for us. So if I, for example, I put a property that doesn't exist, like a misspelled color, well, you see that it doesn't highlight it properly with the blue color, and you know that you've made a mistake. Again, another great feature of Sublime Text. So CSS, what does it actually stand for? Well, it stands for Cascading Style Sheets. And style sheets, that makes sense that, we're creating style sheets, but what does cascading mean? Cascading means that it always takes the selector that is at the end. And that's simplified terms, but I want to demonstrate for you what that means. So let's say at the bottom over here, I do this again. Paragraph, I want color to be green. Well, if I save this, what do you think will happen? Let's refresh and see. It turns green. And why is that? Well, because it's cascading. It's saying, okay, I'll set H2 to red. Okay, I'll set paragraph to pink. And then it says, okay, I'll set P to green. So you can see here, as it trickles down and cascades, it takes the last input that it receives for a specific selector. We'll get more into the cascading effects of CSS in a later video, but I want you to understand the basic concept around it. Okay, I also wanted to show you something cool that you can do with Chrome. And we did this in the first couple of video series, but now you'll actually understand what it means. So again, View, Developer, Developer Tools. And from now on, I'll be using this shortcut to open it, and you'll be able to do it as well. And if you remember, we have our Style tab. And if we click on the Style tab, we have the HTML on the left, styles over here, and nothing for the styles. But if I now go into my home and I click on that, it'll show you color red. So Google Chrome allows us to see our CSS styles. So I can even add stuff here, and I could say background color, and let's do black. Look at that. So this is a really good way to play with your website and add colors. You can check and uncheck here. And also, if you see something on a website that you really, really like, you can go to that element. Let's try it off here. Let's go to waitbutwhy.com. And let's say that we really, really want to know how this was made. We can right-click, do inspect. It'll take us exactly to that element, and then we can see here some of the properties, the CSS properties that they've used. And same here, you can see that the background color is this, and so on and so forth. Okay, let's close that for now. The last thing I want to leave you with is, let's close this. What if I also want the About page to have styles? And same with the login page. As you can see, there's no style for these ones, but we want the same thing for the About and login page. Well, as you can imagine, we copy the link tag and we go to About, we link it onto here, and then login, we can again link it here. I save both of these files, and now if I refresh and go to About, look at that, we have our styles. And you may be wondering, well, what if I want different styles for maybe for the login? I want this to be blue instead. Well, we can actually create multiple style sheets. So I can say, for example, let's create a new file and we'll call it style2.css. I save that, and this time I'm going to say that I want my H2 to have color blue. I save that. I go into my login HTML, and now I'll make login reference the second style sheet instead of the first one. So now if I refresh, login is referencing our style2 CSS, but all the other ones are still referencing the old one. Okay, I lied. There is one last thing that I want to add, and that is that this is the common way of adding styles. But there's actually two other ways that you won't see as often, especially when you're starting off, but I wanted to show it to you so that you're not surprised. The first way of doing it is something called inline styles. And this was the original way that we incorporated styles into our HTML. And that is by specifying within the element, let's go with header over here. We want to say style, so it has a style attribute. And then within here, we can do background color. Let's do green. And refresh, and we're at the About page right now. We changed that for index.html, so let's go over here. And look at that, we have the green background. And if you want to add more, again, we do color red. Let's save and refresh. And look at that. The header has the color red. And you'll see here that these ones are still purple. Well, because they are link tags and they have the default linking. Okay, so that's one way. And third and last way is in the head, you can actually create style tags. And then within these style tags, you can enter CSS. So if you just refresh here, so we have a fresh, clean slate, I can now say, let's do li this time. So all the lists, I want the lists to have background color of purple. So if I now save this and refresh, everything is purple, and that looks pretty yucky. We can keep adding stuff on here, and I can say color white, save, refresh, and it changed the color to white. Now you may be wondering, why don't we just do it like this? This seems a lot simpler than linking to another CSS file. Well, the reason is that for this website, everything is fairly small. It's just a couple lines of CSS, but you can imagine with websites, as they get bigger and bigger, you'll have hundreds and hundreds of lines of CSS, and having one massive file will be very, very challenging to maintain. You can also think of it as if you were working on an HTML and you also had a team of designers that were working on a CSS file. You want to have a separation where you have some team members working on the CSS and then some team members working on the HTML. And that is a concept called separation of concerns. And it's a fancy way of saying that everybody just worry about what they're good at. So HTML, just worry about text, and CSS, just worry about styles. This phrase, separation of concerns, is something that we'll encounter throughout later videos when we get into JavaScript and React. And it's a very, very important concept in web development and computer science in general. So we will get back to that. It'll be a phrase that will keep coming up. So for now, let's delete this. Let's keep things the way that we have it. Let's refresh. And in the next video, I'm going to show you a couple of CSS properties that are more exciting than just color and background. I'll see you in that one. Bye-bye. Welcome back. JavaScript was created in 1995 by the Netscape web browser, right over here. It was a way for them to be able to add actions to websites. Think of JavaScript as the verb in anything you do on a website. You tweet, you play a YouTube video, you sign up for a username. These are all actions we take on websites, made possible through JavaScript. In 1995, it was a way for this browser, Netscape, to beat the competition, which were other browsers at the time. Because at the time Netscape was the most popular, other browsers started adopting their own version of JavaScript so that websites will work on their browsers as well, and thus let people switch over to their browsers. Can you guess what happened next? Well, every browser had their own idea of what JavaScript was. So there was no standard. Eventually, a standard had to be created to make sure that everyone had the same idea what JavaScript was, so that web developers can build one website and have it work on all browsers. This standard was called ECMAScript. So yes, JavaScript and ECMAScript can be used interchangeably, and you will hear both of these a lot. But it's the same language. Now, this browser compatibility issue. Browsers having their own teams, their own schedule, and their own code. Sound familiar? Yep. If you remember, it's the same thing that happened with HTML and CSS. It's the same issue that we keep having over and over. We covered this topic in Web Developer Fundamental Part 2. You see, it's always a big problem. Make sure that all browsers have the same understanding of what a real HTML, CSS, and JavaScript should be, so that when we send each one of those files, we don't have to write one specific for each browser. And just like HTML and CSS, JavaScript is evolving. So there are new things that we can do now that you weren't able to do in 1995 with JavaScript. In the ES6 video section, later on in the course, we will talk about these new features, so don't worry. Now, let's take a look at what JavaScript does. We can open up the browser, and I have Udemy over here. Well, Udemy uses a lot of JavaScript. I mean, clicking on a course, adding it to cart, liking a post. All these things, well, they're all JavaScript. Even if you open categories over here, you see this drop down and I can select things and there's actions constantly happening throughout the website. That's all JavaScript. But it's not just the web that you can use JavaScript on. Instagram? Well, Instagram uses JavaScript. What about something else? Maybe virtual reality? Yeah, you can do that too. You can do VR games, VR apps with JavaScript. Okay, that's pretty cool. What else can JavaScript do? Well, you can actually program drones with JavaScript and control them from your Wii remote if you wanted to. What about robotics? Yeah, this guy built a robot that he can control from his web browser. How cool is that? Now, remember Node.js? We talked about this slide at the beginning of the course and how we're going to learn these topics. Well, some of this is able to be done because of it. But Node.js is pretty much JavaScript. It is JavaScript. So you learn JavaScript, you can pick up backend stuff very easily, and the Node.js section of this course will be a breeze. It's not a new language that you'll learn. So is Express, so is React. So this is why JavaScript is so important. What we will learn here will take you very far in the rest of your career. This is one skill that really opens up a lot of possibilities. Here's the beauty of JavaScript though, and any other programming languages. Because what is JavaScript really? It's a file. A file that you can write instructions to a computer. In the example of a robot arm, all you had to do is write, if I press this button, move arm to the right. If I press this button, move arm to the left. It all looks extremely complicated, but as you will see, no matter how complex a program, let's say an online game like World of Warcraft, well, everything is built one block at a time, one simple logic at a time. In the next section, we're going to start writing our first JavaScript and our first simple pieces of logic. Don't let it fool you though. Although it may look simple, these are the building blocks that allow you to build big web apps like Facebook or Google. Exciting things are going to happen with your newfound power. So, I'll see you in the next one. Bye-bye. Hello! Let's learn some JavaScript. We're going to open up Google Chrome here, and we're going to go to View, Developer, and this time, JavaScript Console. So you can do Command Option J as well. And it opens up this console, which is, if you remember Elements, you've seen it before. That's your HTML. Console is where we can write JavaScript. On the right, you'll see the outline of what we'll talk about in this JavaScript segment. We'll go one by one, and some of them we'll come back to. But don't worry, by the end, you'll know everything in here. So let's talk JavaScript. JavaScript has 7 types. You can think of types as values that JavaScript can have. Let's start with the first one, and that is number. So the number type. Well, in JavaScript, you can do something like this. Look at that. The console allows us to write JavaScript as much as we want. So by writing this and the console giving us an answer, it means that, yep, this is valid JavaScript. Okay, what else can we do? Well, we can do 3 times 5, 15, 12 divided by 4, 3. That's awesome. What else can we do? 12 minus 4, 8. Can we do this? Can we do 3 plus 4? close the bracket, times 2. So that's 7 times 2, 14. Yeah, it works. And we can even do this. And this is a special character that you might have not seen before. It's called modulo. And let's see what happens. It gives me 0. What if I do 12 modulo 5? It gives me 2. What this symbol does, and let's make this bigger so you can see clearly. And I'm going to clear this just so you can see it better. And I can do clear here with these brackets and it'll clean up everything for me. So one more time, what I did was 12 modulo 5, and that gives me 2. And what modulo does is it gives me their remainder. So 12 divided by 5 is, well, it gives me a remainder of 2 because 5 can only go to 10 and then you have 2 remainder. So if I do, let's say, 12 modulo 5, or let's do 9, I get a remainder of 3. And you're thinking, oh God, you're just teaching me math. But don't worry, this is only a small part of it. I just want to show you that the first JavaScript type is a number, and we can do operations on them, just like a calculator can. The second type in JavaScript is a string. So a string is just text. And all you need to do to let JavaScript know that you're writing a piece of text is double quotes. So I can just say Bob, I can say my name, and you can also use single quotes. And that is a string. But what else can we do with the string? Let me clear this. Well, you can also do this. You can say hello plus there. What do you think will happen here? Let's see. Hello there. But it is one word. We need a space. So we would have to do hello space plus there. And there we have the space. Okay, so we can add things. So add 2 sentences together. What if we do something like this? This isn't very nice. I hit enter and okay, that works. That's good. But what if I use single quotes here? What if I go like this? And remember I said that I can use single quotes in JavaScript. Well, you see the syntax changes? And I get a little error. Well, because I'm using a single quote and then inside the string, I'm trying to use a single quote. And that would happen as well if I use double quotes. So if we go back to the example before and I add another quote in here, well, again, I get an error. So let me clear that. How can we avoid this problem? Well, with the string in JavaScript, we can do something like this. Let's use single quotes. This isn't, and watch this. This isn't very nice. And this backslash has a special meaning. The backslash says, hey, whatever comes after this, it's a special meaning. It means just ignore it. Don't say that this is a piece of string. I just want the backtick. So if I run like this, oh, oops, I made the syntax over here wrong. Obviously the quotes need to match. So let's try that again. There you go. This isn't very nice. Okay, I have another question. What happens here? 10 plus string of 34. So that's number 10 plus string of 34. Let's see what happens. Weird. So JavaScript automatically looked at this and said, he's adding a number and a string. He's probably trying to add strings together. So JavaScript converts the number 10 into a string 10 and does 1034. That's kind of weird, right? It's one of the quirks of JavaScript. There's a few of them. You just have to get used to it. Let's try something else. What about if I do 10 minus 3? Press enter. I get 7. What is going on here? And because with the string, you can't really subtract the string. I mean, let's see if I go hello minus bye. I get this weird symbol, which we'll get back to, but that doesn't work. So now JavaScript says, I'm going to, because he's subtracting, I'm just going to assume that he means the number 3. So he's trying to help you out. But sometimes it can have unexpected behavior. So ideally, you never do things like this. Ideally, you keep numbers with numbers and strings with strings, and you keep the actions between the like types. So let's go back to this. What just happened when I say hello minus bye? Well, NaN stands for not a number, and it's technically in JavaScript, you can see the blue highlighting here, it's part of the number type. So numbers can range from 1 to 10 to 567, but there's also the NaN when it's saying, hey, whatever you just wrote is not a number. So that's the case as well. I know it's really, really confusing, but don't worry, it's just the quirks of the language that we're learning. Okay, I'm going to show you one other JavaScript type before we get to some fun things in the next video. So the next one is Boolean. And the Boolean type is very simple. Boolean just means true or false. That's it. And sometimes that could be represented as ones and zeros. And for those that know a lot about computers, you might know that computers pretty much runs on ones and zeros. And that's where it comes from. But Booleans are very, very useful because now we can do something like 3 is greater than 2. And I'll say true. 3 is greater than 2. If I do 5 is greater than 10, we'll say false. 5 is not greater than 10. We can also do 5 is greater than or equal to 5. So we'll say true because I can do greater than and equal to. And I can also do 5 is smaller than or equal to 5. Now, what if I want to say, does 3 equal 3? I get an error. Why is that? Well, because in JavaScript, if you want to say something is equal to something, you have to say 3 equals 3 sign 3. And I get true. And in the next video, I'll tell you why that's the case. It's very, very interesting. But for now, just remember that's always a tricky point that a lot of beginners get confused about. Just remember, if you're comparing two things, 3 equal signs. The last one I wanted to show you is this. 3 doesn't equal 3. Isn't that confusing? So this is saying, does 3 not equal 3? False, because 3 equals 3. I know it can get really, really confusing, but think of this as the opposite of the equal sign. So for example, if I do 4 doesn't equal 5, I'll get true because you're right, 4 doesn't equal 5. So what we just learned are JavaScript comparisons. And they're the things right over here. That's it. You just have to remember these. Whew. Well, that was fun, right? But we're just getting started. After this video, I have left an exercise sheet for you. Try to find the answers to the problems and then copy and paste them, each of the questions, each of the line, into the JavaScript console. So for example, if I said, evaluate 3 plus 5, you'll copy this, put it in the console, and just press enter. And I want you to get comfortable working with the console and playing around with it, experimenting around. And like I said, really try and work on the next problem sets. I haven't given you a lot because I don't want you to get overwhelmed. There's a lot more interesting things happening in JavaScript than this, and you can pick this up fairly easily. But I do encourage you to make sure you do the exercises. Now, can you get all of them? Good luck. I'll see you in the next video. Bye-bye. And welcome back. We're going to take a quick break from learning JavaScript syntax to show you how JavaScript gets implemented in the browser. We're going to go back to this image that we've seen many times before in this course. And we have a pretty good idea of what HTML and CSS does. If you remember, HTML gets sent to the browser, then it sees the link tag, and the CSS gets sent to the browser. But what about our new friend JavaScript over here? What happens with him? Well, in this video, we're going to learn exactly that. So I have over here an index.html file. I'm going to open it with Google Chrome. It's completely empty now. And I'm also going to drag it to my Sublime Text so that we can add something to it. So I have Sublime Text in the browser, and we're going to use our little short command to create a quick HTML file, JavaScript, and let's just have a simple header that says JavaScript in HTML. Save and refresh. Perfect. We're masters at this already. We all know what's going on. So how do we add JavaScript to this? I mean, with CSS, we had the link tag, right? And we had this href where we tell it where it is. Well, if you remember, JavaScript, again, just like HTML and CSS, is just a file. So let's create one first. In Sublime Text, I'm going to create a new file. I'm going to save it, and I'm going to say script.js. See the .js at the end? That means JavaScript. Notice what happens when I click save. At the bottom, Sublime Text now converted the syntax to JavaScript. So now I can write something like 4 plus 3, and I get the cool JavaScript colors. I can write if 4 plus 3 equals 7. I can alert you're smart. So you can see that it does the syntax for me. Okay, perfect. I'm going to just save that. Let's see if we can add this to, I forgot the semicolon here. I always forget it too. Let's add this to our HTML. If it works, we'll get an alert saying you're smart. So how can we do this? Well, there's an HTML tag called script tag. So link tag for style sheet, script tag for JavaScript. And all we do is this. We have the type text JavaScript. You see over here how with CSS we have text CSS. Well, we're telling it that this is JavaScript. And in here, JavaScript can be written right over here. If I go alert hello, and you might remember this because it's kind of like the style tag for CSS. Let's see what happens. I'm going to refresh, and I get hello. Look at that. We just added JavaScript to our HTML. But I really want to use this file. As we know with CSS, we don't necessarily want our JavaScript to live on HTML. We want separation of concerns. We want the JavaScript in the JavaScript file. Well, the way we do that is through a source file. So all we do is source. You might remember this from images. So instead of href and link, we have source, and we say script.js. I save, and I refresh, and I get you're smart. Now, again, we can say script.js because, well, it's in the same folder. It's in the desktop folder. If it wasn't, then let's say this HTML wasn't in the desktop folder, we'd have to do something like desktop. Okay. So that's very interesting. What if I have multiple JavaScript files? We might have seen that in, remember Bootstrap? In Bootstrap, we had like 3 script tags. Well, yeah, you can just like you can with Link, you can have multiple script tags. And you can just say script 2, script 3. And again, each one gets executed one at a time. Okay. Now, one question you might have is, why did I just put the script tag at the bottom here, at the bottom of the body? Why didn't we, and let me just remove this for now, why didn't we just put it at the top like we do with the CSS file? Well, let me show you something. Let's put it up here. Let's see what happens. I'm going to refresh. Okay, I get you're smart. I don't know if you saw that. Did you see the JavaScript go? Let's change this quickly. Let's say our website is now fresh and new, and I'm going to say, waiting for JavaScript. I'm going to save. Notice what happens to the header. I refresh. It hasn't changed yet. I have to click You're Smart. Do you see it? It's completely gone. Click OK. And only then it shows up. Because the browser reads the file, goes and gets the CSS file, and then sees the script tag and says, ooh, I'm going to go read what's over here. And here is an alert. And what an alert does, it waits for us to click OK. So the browser can't display waiting for JavaScript. So you will see in older websites people that put the script tags in here, but that actually delays what gets seen by the user. Instead, if we put it down here and change the text again to not waiting, I'm going to save. Let's see what happens. Not waiting for JavaScript. That got changed. So we ideally want to put our script tags at the bottom of the body. What that means is that the website gets displayed, gets rendered, and then we have to still wait for the JavaScript to load. Let's say we had a cool animation. It will have to wait until that loads, but to a user, it appears like the website loads a lot faster because they might not click on a drop-down menu or see the animation right away and notice that there's a lag, but they will see a delay if they don't see anything on the page. So script tags at the bottom. One last thing. How do we get that console to print stuff out? It would be nice if instead of alert all the time, I can get something in the console. Well, in JavaScript, you can do something called console.log. And here I can say, hello. So this syntax is a little bit weird. I'll explain later on what is going on here, but console.log is a special little syntax that we can use. And now if I refresh the page, I get logging over here. So I can write as much as I want here, kind of like alert, but without getting that annoying pop-up over and over. And refresh, and I get hello. And we'll be using console log a lot in the next couple of videos. You can see here that it's a nice way for us to print something to the console before we learn how to change our HTML. So I'll see you in the next one. Bye-bye. In 1989, Tim Berners-Lee invented the HTML that changed the world. But HTML wouldn't really do much if we couldn't fetch documents from around the world and different computers. For that to happen, Tim built the Hypertext Transfer Protocol, or HTTP for short. Now, remember these arrows from the diagrams that we've had? We told you that these arrows were simply the connected wires and cables that connected the World Wide Web. This, right? You remember the diagram. But you see, these are just wires. There are no instructions on how to do things. For that, you need something called a protocol. Think of it as a standard that everyone follows. If everyone agrees, then the protocol works and can be used by everyone. HTTP that I have here is a protocol which allows the fetching of resources such as HTML documents. I mean, it's in the name, right? Hypertext Transfer Protocol. Now, with the use of HTML and HTTP, we now have the World Wide Web. We can grab HTML files and receive them. If we go to google.com/about, we go to the About HTML page, we grab it and receive it. So HTTP is the protocol or the rules that we use over the wires. It is the foundation of any data exchange on the web. And it paved the way for something called a client-server protocol, which means requests are initiated by the recipient, which in our case is the web browser. So they send out a request using HTTP. The server now understands what the web browser is saying because it's speaking in HTTP. And the server can now respond with HTML, and the browser understands it because it's speaking through HTTP once again. So you should think of HTTP as a common language that a client and a server can use to communicate. They're simply saying, hey, can you give me this document? And the server can say, yep, no problem, here it is. And up until this point, we haven't really spoken to a server in our app, have we? We built the front-end applications or the client-facing applications using HTML, CSS, JavaScript, and React. But we lived in our own world, no communications with another computer. HTTP allows us now to communicate with servers, with the outside world. So let's go over the terminology one more time. Clients and servers can communicate by exchanging individual messages. The messages sent by the client, usually a web browser, are called requests, and the messages sent by the server are usually called responses. So if HTTP is the language that allows us to communicate between these two, teach me some of the words, right? I mean, that's a good question. And lucky for you, HTTP is quite easy to learn because you only have a few words. And I'm going to show you what they are right now. You have get, you have post, you have put, and finally you have delete. And now you're thinking, that's it? And yeah, HTTP is beautiful because it's just simple. You don't need to overcomplicate things. You learn these 4 words and these languages, and you can build the app of your dreams. So let's go through it one by one. Get means, well, I want to get an HTML file. So you ask to get something, and the server responds with that request. A post says, I want to post something. So that is, I'm going to send over some data to Google servers, and I want you to post. I want you to add it to your servers or your database. Put is, I'm going to send you some data, and I want you to update some data that already exists in Google servers and just update it with this new information. And then delete means, well, delete a piece of data on the backend, on the servers or on the database. So if we use Twitter as an example, get will be to receive the Twitter feed with all the tweets from today. Post would be if you created a new user and you want to add that user to the Twitter servers. Put would be if you made a tweet but you want to make a change or an edit, so you edit that tweet. And delete will mean, well, you either delete your user account or delete a tweet. And don't worry, we're going to use these when we get to the backend section and we build our final project. Now, over the years, HTTP was extended to not only worry about text, not only fetch hypertext documents like HTML, but also images and videos and post content to servers like with HTML form results. And HTTP can also be used to fetch part of documents to update web pages on demand, which is called AJAX. And we have a video coming up talking about this. But the main idea still stands. Using these 4 verbs we just learned, we can now communicate with servers. All right, so we know that this arrow over here at the top uses HTTP to make requests using one of these 4 verbs. Okay, so I think you get the request part. Now, what does the server respond with? What about response here? The server sends you 2 main things. One is an HTTP message that is something that you've definitely seen before. And I'll link to this W3 Schools resources. A 200 message means successful. You probably have seen 200 OK before. You might have seen 404 messages, which means not found. If you enter a URL that doesn't exist, you'll get a 404. And maybe sometimes you'll get a 500 error message that is, well, there's something wrong with the server. So this is just a number code that comes with every response that tells you the response of the server. So that's the first one. The second one is usually some sort of data, like HTML. And so far, that's what we've been doing, HTML. But in the next videos, I'll show you that it can send other things other than just simple HTML. So let's add to this diagram now. We want to say that this also has a status code, and we'll say 200 for now, that everything was fine. And in the response, we give the status code plus the new HTML file. All right, let's actually demonstrate this online and see how you can watch this action take place. I have over here a great website called example.com, and it's a simple website. You can go visit it right now. But the cool part about it is if you open up your developer console, up to this point, we've looked at the Elements tab and then the Console tab. I want to show you the Network tab that we have here. Now, the Network tab, you might have to click on some of these icons, and you'll see that different things will pop up. Make sure that the filter is gone. Everything is unclicked. And now at example.com, while this is open, just simply refresh. And look at that. I'm going to click on this icon, which makes it a little bit bigger. This is a plugin, so don't worry about this JavaScript. But the top thing, it says example.com, status 200 OK, and type document. And it even tells me the size, the time that it took to get this, which is 53 milliseconds. That's pretty fast. So that means the server responded with 200. If I click on this, I get a whole bunch of things that we don't really need to worry about, but a few things. Request URL, this is what we requested. We get a status code of 200 from the server. And if we click on the response, there's the response message. We received the HTML document from the server. If we go back to headers, we also see that our request method was a GET. We did a GET request. Let's close this and refresh again. I now get a 304 status. A 304, if we look over here, means not modified. Indicates the request page has not been modified since the last requested. Because I've already requested this now, Google is smart enough to say, oh, I'm not going to worry about the server and requesting the same thing over and over. I already have it memorized, so here it is. Very cool. So Network tab is really, really useful for that. All right, so you can go ahead and play with example.com and see for yourself how HTTP works. And by the way, yes, this HTTP that you see here, that's what it means. When you do an HTTP request, it says, hey, do HTTP. We're using the World Wide Web and go request this from the server. Very cool. And if you're wondering about the S, don't worry. I'll let you know at the end of this video what that means as well. All right, now what if I want to send data? If we go back to our diagram, I'm just doing a GET request, but what if I want to actually send some information to the server other than some URL saying I want this information? Well, there's two ways that you can do it. One is something called query string, and then the second one is through the body of the request. So I'm going to show you how both of those work. I have over here the form that we created in our first advanced HTML section when we only knew HTML. Let's open this file up. I have it over here. If I double click, you remember this, don't you? We've come a long, long way. In this form, if you remember, we had a form method get. And now you might understand what this get means. It's saying, with this form, I want you to do a GET request. Let's see what happens when I click register while opening the network tab. I'm going to click register. All right, so we have this request. We see that we have made a request and it has created these things called query strings, the first way of sending data to the server. With a GET request, if you want to send information through a form, it adds it to the URL using this question mark, which says, hey, I'm about to send you some query strings, and it's going to have a key and a value. In this case, first name, last name, everything's empty, so there's no information, but otherwise it'll say first name equals Andre. If I click on this, we see that there's query string parameters that we've sent. We have first name, last name, email, password, and birthday, which is blank. But if we scroll down, in cars, default is Volvo, so that we have cars Volvo. So this information now is sent to the server. That's query string parameters using GET. And we did mention one thing though. We see that we have password in here. That's not very secure, is it? If I went back to the form and I type in secret and I click register again, well, now I have my password out in the open, sent over the wire, and I even have it up here, my URL bar. All right, we'll get back to that. So that is one way. The second way is through the body of the request. Let me show you how that works. The way we send information to the body is we use a post request. And this is something that you'll more often see than a GET request, is that we want to add some form data to the server. So we want to post something. If I change this over here, I'm going to save this. And let's open up a new tab with the new saved data. This one is a post form. If I open it up here and I type in password secret and I click on register, I get register.html, but no query strings. If I click on this, I see that now instead of query strings, it's form data. And it even says content type, application, XWW form URL encoded. And this is just an HTML way of saying that this is a form and this is the body, but not displaying here. So now the server can access it not from the query params, and don't worry, I'll show you how servers do that when we get to the backend section. Instead of accessing it through the query params, I can now access it through the form data. So let's go back to the diagram. We now understand that we can do HTTP requests using get, post, put, delete. I can use query strings, which are at the top of the URL, to send the data, or the body of the request. And then the server responds with a status code based on how my request was, and it returns that with a response. But the one issue we saw was that Well, the password was visible in both cases, wasn't it? And what if I have a scary looking person over here? There you go. What if we had a person who was watching our communication, our HTTP requests, and monitoring it? If I used query strings to put my password in there, well, he can just look over my shoulders and see, oh, Andre's password is secret. I can now log into his Google account. Or if I use the body way of sending data, well, he can find a way to get this request to come over to him first and just look at the form data and see that my password is secret. That's not very good, is it? Well, one solution to this was the idea of HTTPS. Now, HTTPS means Hypertext Transfer Protocol Secure. And you can see over here that W3C uses the secure version of HTTPS. The communication between the browser and the websites are now encrypted. And what does that mean? Encrypted just means that it's jumbled up so only the client and the server know the secret pass or secret key to read the message. And this S part, the secret, uses a technology called Transport Layer Security, or its predecessor, Secure Sockets Layer, or TLS and SSL for short. So now, even with HTTPS, if the attacker, or what we call a man in the middle, the person who's just monitoring our requests, even if they get our password, it's going to be just complete gibberish. It's going to have something similar to this, and well, that's not our password, so it's going to be meaningless. It avoids that attack. This is just a tip as a developer that you should tell all your friends. If you're ever sending sensitive information, maybe logging into a bank account, make sure that there's HTTPS out there. If there's no HTTPS when you're sending maybe your login with your password, well, that's not secure. All right, let's review. Your web browser is a HTTP client sending requests to the server machines. When the browser user enters file requests by either opening a file or typing a URL or clicking on a hypertext link, an anchor tag, the browser builds an HTTP request and sends it to communicate with the server. Now the server can get information back to us. The earliest version, we could use URL parameters such as google.com/about and just specifically get HTML. That was it. Then came the form. So we can now actually send more data other than just the URL saying we want to go to this HTML file. Now we can use get or post to send data, either through a body or a query string. And a server can take action based on that data and return a new page. And this is the foundation of the web and how the World Wide Web we have now was made possible through client-server communication. In the next few videos, we're going to learn even more to really understand this power. I'll see you in the next one. Bye-bye. All companies store data. From a simple record book of a small business, maybe even on a journal or a piece of paper, to massive companies like Amazon that need computers to store petabytes of data. Now, in order to store this information, pretty much every company, and sometimes individuals too, need something called a database. We saw in the last section how hard it was to have our server remember a new user. Every time the server crashed, the variable would get reset and then it would start all over. Or if we wanted to do a login or a sign-in check and iterate through the emails and passwords, doing a loop through JavaScript, that's inefficient. That's where databases come to the rescue. So let's ask ourselves, what is a database? A database is a collection of data. And what we mean by data, there are many forms of them, right? There can be numbers, there can be dates, there could be password hashes, there could be user information. Databases allow us to organize this data in a way that is useful to us, and it makes data management easy. And something came out of that, and it's called Database Management System, or DBMS for short. It's a collection of programs which allows us to access databases and work with data. And it also allows control access to database users. So a DBMS is something in this box. Something that allows us, a tool, a piece of software that allows us to communicate with the database, store information that's useful for us, and also allows us to update, insert, delete, look up whatever is in the database. And this idea of a DBMS really started to take shape in 1960s. And now it is at the forefront of many exciting things. There's an entire industry of engineers that just work with databases because it is so important. Now, there are two types of DBMS that are really popular right now and that we're going to talk about in this course. And these two types are represented really well by Postgres and MongoDB. Let's talk about the first one, which is relational database. And this is probably the most popular. As you can see on the right-hand side, you see that all of these are relational databases. Postgres, Oracle, SQL Server, you may have heard of MySQL, SQLite. These are all types of databases that have this relational database tag to them. And the beauty with them is that they're all pretty much similar. They all follow a same standard format. Relational databases consist of two or more tables with columns and rows. So in this case, users is a table, and full name, username, text created at are columns, and whatever values they have here are rows. Each row represents an entry, and each column sorts a very specific type of information, like name, address, or phone numbers. And then the relation between tables and fields is called a schema. In a relational database, the schema must be clearly defined before any information can be added. And if this is confusing right now, don't worry, we're actually going to create these databases so it makes sense to you. If we had Twitter, for example, you can see over here the types of tables that we would have and how we would organize it. We would have a users table, a tweets table, a following table. And we can connect all these information, for example, by connecting different pieces of the table. For example, the username will be the same in the users table as it is in the tweets table. That way, we can say that the username in the tweets table is the foreign key of the username in the users table. And then from user will be the foreign key of username in the following table. Now, things like full name or ID, something that identifies each row in a table, is called a primary key. And we'll go through that later on in this section. All right, so all these databases, we're going to learn about PostgreSQL, but they're all pretty much the same. So once you know one, it's fairly easy to pick up the other ones. How do they actually communicate with a server, with the backend? Well, all relational databases use something called SQL. And SQL allows us to communicate, just like HTTP did, between the front end and the back end. With SQL, we're able to communicate with the database and modify or get or update however we want. And we'll have a video on this topic as well. All right, so that's relational databases. What about the second type? The second type is called a non-relational database or a NoSQL database. And once again, there are many, many different types of databases with some cool names like CouchDB and Hypertable. Now, a MongoDB or a non-relational database lets you build an application without having to define the schema first, unlike a relational database. If we go back to relational database, this schema or these tables have to kind of be predefined, right? We need to know how our app is going to look, make these tables so that once the app is public, we can start entering user information and tweets and followers. With a NoSQL or non-relational database, we can just define it as we go. And they all have different ways of storing this information. So each one is very, very different. And this is another powerful reason to use a non-relational database is that if your data requirements aren't clear at the outset of your project, and maybe you have a massive amount of unstructured data, you may not have the luxury of developing a relational database with a clearly defined schema. They offer instead a greater flexibility in that a non-relational database are more like folders, just assembling related information of all types. Now, MongoDB is something called document-oriented. It stores information as documents. Let me illustrate this point to you. I have my desktop here with two folders. One is a relational database, and here I have users, tweets, profile, following. And you can think of relational databases with this type of storage, where this folder lives somewhere on a computer that stores this information. And anytime we need to ask a database for something, well, we grab the users. And if we also want to grab the tweets of the user, we find the user that we're interested in, then find the tweets of the user that we're also interested in with the foreign key that links to the users. And we can also find however many followers that user has. We grab that information and display it on our web app. MongoDB, on the other hand, will actually have each user as a document. So if I wanted to grab the first user, well, I just grab this document and it has all the followers, the tweets, the profile, everything is in this one document. And you might be thinking, MongoDB looks like a better choice than having this way of doing things, right? Well, it depends on your need. And that's why databases is such a complex topic. It really, really depends on your situation. You can see this MongoDB way being very useful if you had something like a profile, maybe a LinkedIn profile. But if you needed something where you're working with just following data or just tweets data, maybe with the tweets, you want to see what is the average tweet size. Well, it's really easy to just grab this file and calculate that versus this way where you might have to extract it from each one of the users. So it really depends on your needs. Let me show you another diagram that might be useful. When we look at relational versus non-relational databases, you can think of relational as each table has a blog post, a blog tag, a blog comment, and it links these tables to give you the blog information. Versus a non-relational that stores this entire blog post in an entry and has comments, tags, categories, and all other related data just in one single place. So what does MongoDB use to communicate? If we go back to our example here, we had SQL for relational databases such as Postgres. Well, MongoDB has its own what we call query language. And it is just the MongoDB query language. But they both aim to do the same thing. That is to communicate with the database, provide an easy way for the server to communicate with the database. And in this section, we're going to be talking about that. And we're going to finally connect the dots and show you the power of databases once they're connected to a server. I'll see you in the next one. Bye-bye. All right, so let's create a table. If you remember to go to our Postgres database, we simply write PSQL and then our database name, and we'll enter the database. And now we can communicate with it using SQL. Now let's create a table. How can we do that? Again, SQL comes with some language syntax that we can use. And to create a table, we can use something like this. We say create table, which is an SQL command. We enter a table name, followed by brackets. And then we say what we want the column 1 to say with the data type, column 2 with the data type, column 3 with the data type, and then ending it with semicolon. Let me just press enter and see what happens here. I get an error. Data type does not exist. And that is because data type is referring to what Postgres or our relational database knows. We have to say ahead of time what type of data column 1, column 2, and column 3 hold. If we go back to our Chrome browser, we see that for Postgres, we have a few data types that we can hold. String data types, numeric data types, and date and time data types. And each one of them have different things. For a numeric data type, we have integer, which is a 4-byte integer. We have big int, which allows for a bigger number. And all these different things, we have even money, which is currency value. And the reason we have to give this data type is because of the way databases work. They're optimized to make sure that as long as everything is the same in their column, they're able to work really, really fast to perform actions. In our case, let's use some of the most common ones. We can use text for the first column. So let's do that. I'm going to press the up arrow and get create table. I'm also going to name this table. Let's call it users. And column 1 will be name. Data type can be text. Column 2, we can say that is age. And data type for an age, well, if we look down here, we look at numeric types, we want to use something like small int, which is a 2-byte signed integer. It means that a max for a small int, if I go to small int max, we see that the max range is 32,762. Well, nobody's going to be that old, right? So we can use small int for now. Let's do that. I'm going to say age is small int. And finally, the third column will just have birthday. And birthday can be a date data type. And we can just have date. Let's press enter. And I get create table. Let's look at our PSQL here. I'm going to minimize this. And if I click refresh here, I see that we have users. Look at that. And we have columns for the table users, that is name, age, birthday. It tells us the type and the length. So now we have our table. Awesome. There's also a way to do it here. If we do \d, I get list of relations. And look at that. We have our users table and the owner, which is me. Very cool. There you go. We've created our first table. Now that we have this, we can start entering some information. And by the way, you might be asking, how many times do we run these commands? Well, ideally, once you create your database and it lives somewhere on a computer, somewhere in the world, you only run this once, right? You create a table of what you want your database to look like, and the rest is just filling in and inserting information and reading information off of it. So this is the command that we're going to set up when we create our own database to set up our schemas And then after that, it will just run on its own and it will be able to communicate with the backend. It's going to be very fun. By the way, before we get into the next video, I want to show you one more command. We learned the /d shows us our tables. If I do /q, we exit out of here and we're back to the terminal. All right, I'll see you in the next one. Bye-bye. Welcome back. Let's go back into our database. We've just created our users table, but now we want to actually insert some information. How can we do that? Again, using SQL, we have the insert into command that we're able to insert into whichever table name we want. We're going to specify the column and then the values of each of those respective columns, and always ending in a semicolon. I also want to emphasize that with SQL, the capitalization is just a standard, but if I made this lowercase, it will still work. It's case insensitive. So looking at our database, we have name, age, and birthday. Let's insert something. We'll say that we want to insert into users. Column 1 will be name. And then we have age, birthday. And no, you don't have to insert every time into every column. You can just change the name if you want. All right, name will be Andre. Value will be 31. And then birthday we'll say is, if you remember the day syntax, if I open up here, is this, year, month, day. So I simply do 19. I'm going to make myself really old. We'll say January 25th. Press enter. I get insert. Awesome. If I do /d again, I see my table. But how can I see the value that I just entered? Well, first let's check here. Let's check with our GUI. Click on content, select users, and look at that. Name, age, birthday. I have Andre, 31, with my birthday. Very cool. Now, how can we grab this information? Again, a SQL syntax is select, and we want to say what we want to select. In our case, we can say name, age, birthday, from, and then the table name. In our case, users. Semicolon, press enter, and look at that. I get Andre, age 31, birthday. If I want to just grab the entire columns without spelling out everything, imagine if we had tons of columns, we can use the wildcard symbol of star. That's Shift 8 to get star, and I get the same thing. Very cool. By the way, with PSQL, we can actually run these queries here. See how it already has select? I can say select star from users, and it even gives me nice coloring. Press enter or press semicolon and run query. And look at that. It gives me the table for me. And it also has the history, which is really, really nice. Let's add a few more users here. I'm going to insert, this time, somebody else. I'm just going to change a few things. 41 and Sally. Inserted. If I select star from users, I have Andre and Sally. Going back here, run query, I have Andre and Sally in the database. How cool is that? All right, we know how to create a table, we know how to insert into a table, and we know how to grab this information. We can already start picturing what powers we can have now with our final project. But there's still a few more things we want to learn. For that, I'll see you in the next video. Bye-bye.
Okay, so let's discuss PHP a little bit. Keep in mind that our aim is not to learn how to code in PHP, so we're not really interested in all the details. We just want to see what is it used for and how we can recognize it, and also where can we find it. So first of all, what is PHP? Well, PHP is a programming language, or also can be considered to be a widely used open source scripting language, and its main purpose is for web development. Another interesting thing for us is that, as it says right here, PHP can be embedded into HTML. What does this mean? Well, the same way that we can add JavaScript inside of HTML, we can do it with PHP too. A simple example would be the code that we can see at this page. As we can see, the code starts with open HTML tags. We got some HTML open headers, open head tags, open body tags, and inside of the body tag, we get PHP code, which is embedded inside of this HTML code. This is the most simple PHP code, but we can notice what actually distinguishes it and what allows us to notice that this indeed is a PHP code. First of all, it starts with these tags. We got this arrow pointing to the left, then we got question mark, and then PHP. This is opening tag for PHP script. Under that comes the code that we write in PHP, and in this case it is just a simple echo script that says, "Hi, I'm a PHP script." After you finish typing all of your PHP code, you simply just close the tags by typing question mark and arrow to the right. And after that, you can simply just continue with your HTML code. Okay, so PHP is used for web development, same as JavaScript. It can be included in HTML code, same as JavaScript, so what is the difference? Well, JavaScript is used for client side, while PHP is used for server side. The key is that client can't really view PHP code that is being ran by server, taking into consideration, of course, that everything is set properly and not misconfigured. Perhaps this is better said here in this paragraph, right here. So, as it says, what distinguishes PHP from something like client-side JavaScript is that the code is executed on the server, generating HTML, which is then sent to the client. The client would receive the results of running that script, but would not know what the underlying code was. You can even configure your web server to process all your HTML files with PHP, and then there's really no way that users can tell what you have up your sleeve, meaning that they can figure out what code you have in PHP. Another reason why PHP is good is, besides it being available on all major operating systems, it is good in command line scripting and server-side scripting, which we mentioned already. Server-side scripting is the main field for PHP. However, for this, we need three different things, and that is, we need to have the PHP parser, we need to have a web server, and a web browser. And in this case, to run the PHP code, you can just have the web server running with a connected PHP installation. Then you can access the PHP program with a web browser. How it exactly runs is explained really good in this image right here, or in this diagram, however you want to call it. As we can see, these are labeled as steps. We go from the device, as it says user requests some website. It goes to the Apache web server or any web server whatsoever. Then it processes back to the PHP interpreter, which is step number 5. Then it sends back to Apache web server, and then the web server processes the page and sends it back to the user. Now, another thing worth mentioning is that you can make PHP run without any server or browser. You could run it with command line, with just the PHP parser, and it will still work. Okay, nonetheless, this is the basic principle behind PHP. We just mentioned what it was used for, where can we find it, and how can we recognize PHP code. What is important to remember? Well, it's important to remember that PHP is used for server-side, it is mainly used for web development, and PHP can be embedded into HTML code. And we can see how to do that right here with a simple PHP script. Awesome. Everything else that we might need, we will cover as we go. For now, this will be enough, so that's about it, and I will see you guys in the next video. One of the things that we as penetration testers need to know is navigating through the system with the help of a command line. Now, this is a prerequisite that we're going to cover, so if you're already familiar with Linux and terminal commands, feel free to skip these few lectures that we will devote to it. Okay, now, for those of you who are not familiar with terminal, you are probably wondering, why do we need to learn this? What is the purpose of using a command line? Well, terminal, as we already mentioned, is a command line interface that allows us to control and navigate through the system. It isn't a graphical user interface, so it's rather simple. You type in a command and you get the output. In Linux systems, it's called terminal, while in Windows systems, it's called command prompt. Now, one of the reasons why this is important for us is when you gain access to the target during your penetration test, you won't really get a desktop access to it. You won't be able to see all the icons, the programs, its desktop. None of those things will be visible to us. Instead, we will control their system with a command line tool by running different commands. With time, you will start using terminal more and more, and you will get better and better. But for the purposes of this course, we're just going to cover some basic commands in this section, and we will also learn a couple more advanced commands during the course. So let's start by checking how we can open the terminal inside of our Kali Linux machine. There are a couple of ways that we can do this. If we go up here, we're going to see a couple of icons, and this icon right here is actually terminal. As you can see right here, it says terminal emulator. If I click on it, it will open the terminal tool. Here it is. Now, there are a few things that we can see right here. We can see the name of our account that we created during the installation of Kali Linux, and we can see the path right here in the brackets, and this is the path in the system. Now, before we run any command right here, let me just explain this path a little bit more, just so we can fully understand it. So I'm going to close the terminal right here, and that path that you saw depends on where you open the terminal. For example, I can also go on my desktop, right-click, and go open terminal here. You will notice we will open everything that looks the same except this path. We open terminal in /desktop directory. And you can do this in any folder that you want. You can go in home directory, open terminal there. You can go in downloads directory, documents directory, and the path to that directory will be written in these square brackets right here. Okay, another way that you can check the full path to the directory that the terminal is opened in is by typing the command pwd. If I press enter, it will give me the full path to the desktop directory, which is /home, /Mr. Hacker, and /desktop. Now, to see the contents of the directory that you're inside, you can type the command ls. And you will notice once I type this command, it will be an empty list, since there are no files or folders in the desktop directory. But this doesn't mean that all the other directories are also empty. For example, we can also open another terminal, which will be in this directory right here and not in desktop directory. And if I type ls here, well, now we get some response back. We get a list of other subdirectories that are inside of this directory right here. And we also get the desktop directory. So we can conclude that this desktop directory that we are inside in this first terminal is actually a subdirectory of Mr. Hacker. Now, to navigate inside of one terminal between multiple directories, we can use a command cd. And let me just show you right here. So I'm going to close this one. Let's go back to the one that is in the desktop directory, and we can use the command cd and then, for example, /home. You will notice instantly that the path changes. We're no longer inside of /desktop, we are in /home. And we can prove it by typing pwd, which will tell us the directory name. By the way, if I didn't mention, pwd stands for print working directory. Now if we type ls here, well, we get only one response, which is Mr. Hacker. So how can we go to this Mr. Hacker directory? Well, we can also use cd and then Mr. Hacker. And we're back to Mr. Hacker directory. If I type ls, you will see an already familiar response. Okay, but how can we go one directory back, for example? Let's say we are currently in Mr. Hacker directory and we want to go back to /home directory without having to type cd and then /home. Let's say we don't know what is the directory name and we want to go one directory back. Well, we can do by typing cd and then 2 dots. If I press enter, you can see that we're currently back in /home directory. So the command cd and then 2 dots actually puts us one directory back. Okay, awesome. Now that we know these commands, let's navigate to /home, /Mr. Hacker, and then let's go to the desktop directory of Mr. Hacker. Now let's cover a new command, a command that will allow us to create files. That command is called touch. Now, touch creates empty files, and all we need to do to create an empty file is type touch and then the file name. Let's call it file1. If I type ls again, and remember ls is a command that will list all the files and directories inside of the current working directory, now we get a response. We have file1 inside of our desktop directory. And even if I go and lower this terminal, you will see the file1 on our desktop. So we successfully created it. Now, the same way that we can create files, we can also create folders. The command to create a folder would be mkdir, which stands for make directory, folder1. Now, keep in mind this file1 and folder1 you can name anything you like. This is just a name that you give to your file /directory. And if I type mkdir folder1, I lower my terminal. Now we have folder1 on our desktop. And we will also see it if I type ls. As we can see, we have file1 and folder1. Another useful command would be to copy files. So let's say we want to copy this file1 inside of folder1. How can we do that? Well, we use the command cp. And it works like this. We type cp and then the file that we want to copy and then the location where we want to copy it. In our case, we can specify cp file1 to folder1. Now, we don't need to specify the full path to folder1 because the folder1 is already in /desktop directory. But if folder1 was in some other directory, we will have to specify the full path to it in order for this file to be copied to the correct location. So let's press enter. If I type ls, we will still have file1 in our desktop directory, but if we also cd to folder1 directory and type ls, well, we have file1 in folder1 directory as well. So we successfully copied it. Now, compared to the copy command, we also have the move command. It does the same thing, just it doesn't copy, it simply just moves the file from one location to another. So once you use the move command, the file will no longer be in the first location that it was at, rather it will be in the location that you moved it to. So let's see how that works. Let's say now we want to move the file1 from the folder1 to the home directory. We can do that by typing mv, which stands for move, file1, and then to /home directory. If I press enter, it gives me permission denied. Now, permission denied is something that we will talk about in the next lecture. For now on, let's just forget it and we will get to it in the next lecture. Let's just change the path where we want to move our file1, so we can type move file1 to /home /Mr. Hacker. Okay, this one worked. We didn't get any error that says permission denied. So now let's see whether we first have the file inside of folder1. If I type ls, you will notice that our file is no longer here. So we moved it. Now let's see whether we moved it to the correct location. We can copy this location and type cd and then /home/Mr. Hacker. If I type ls here, well, here is our file1. We successfully moved it to the /home/Mr. Hacker directory. Now, another interesting command that we can use is called echo. If I type echo and I type, for example, hello world, like this, so echo, open double quotes, hello world, and then close double quotes, it will just print out hello world inside of our terminal. But if I do something like this, echo, hello world, and then I use double arrow to the right, and then our file1, well, we don't really get anything printed out. But what did we do right here? Well, in this command, we actually used this string and we put it inside of file1. So now file1 is no longer an empty file. It contains this text. How can we check it out? Well, we can check out what are the contents of file1 with the help of another command. And that command is called cat. So cat file1 will print out the contents of that file. If I press it, here it is. We can see the content of file1, which says hello world. Now, you can also check the contents by going and visiting file1, like this, even though it will be empty because we actually inputted our string in file1 in /home/Mr. Hacker directory and not in /desktop directory. But nonetheless, you can also enter something here if you want. But it's important that we get used to using terminal instead to do these simple tasks. So now that we learned how we can create empty files, how we can write things in empty files, and how we can actually switch between different directories, how we can copy files, move files, and all of that, let's also see how we can delete files. For example, we're in our /home/Mr. Hacker directory, and we can confirm that once again by typing pwd. And let's say we want to remove this file1. We no longer need it, so let's just remove it. We can use the command rm. And after the rm command comes the file name. So if I type rm file1, press enter, and then ls again, we no longer have file1 in this directory. However, we do still have it inside of our desktop directory. So let's delete it here as well. To go to desktop directory, I can type cd /home/Mr. Hacker /desktop. If I type ls, we have file1 and folder1, and I can type remove file1 or rm file1. Let's also try to do that with folder1. If I type remove folder1, we get an error. Cannot remove folder1, it is a directory. So how can we remove directories? Well, instead of just typing rm and then the directory name, we can type rm folder1 and then at the end we add -r. With this command, we can remove a directory. If you notice, when I type ls, we no longer have file1 or folder1. Okay, I hope you understood all of this. Now don't worry if this seems a little bit confusing to you. Make sure that you practice these commands. Make sure that you practice navigating with cd command, creating files, deleting files, copying files, and all of that. And in the next video, we'll continue with some new commands that we can use inside of our terminal. Okay, awesome. See you in the next video. Okay, so we have covered a few commands in the last video. Let's learn a little bit more just so we can feel confident when we get to use our terminal later in the course. Another important command that you will use a lot is called sudo. Now, sudo allows us to run certain commands as root account, or in other words, as an administrator account. For those of you who don't know, root account on Linux is something similar as administrator on Windows. So let's check sudo command by running it with another familiar command that we already covered, which is touch command. So if I type sudo and then touch and then file1, let's see what will happen. So I'm just going to press enter. it asks for password, which makes sense because we're actually trying to create a file with elevated privileges. So the actual password that you want to type here is the same password that you used once you created an account during the installation of Kali Linux. So I'm just going to type mine right here, and the file has been created. We can check it by typing ls, and now that we created file 1 with elevated privileges, you will also notice that on desktop, if I lower my terminal, this file 1 has a lock on its icon, as we can see right here. This means we cannot change content of that file as a regular user. Let me show you what I mean. If I also go and create a file as our Mr. Hacker account, just by typing touch and then file 2. Here, if we take a look, this file 2 won't have any locks on its icon. This is a file that we created as a regular user. Okay, we'll get back to this in just a second. For now, another useful command that I want to show you is called nano. Nano is a text editor. Once you open a file with nano, you will be able to write text there, or even code if you're creating a program. Let me show you how it works. So if I go to my terminal and I type nano file2, which is the file that we just created, it will open a window that looks like this. Here we can write anything we want. Let's say we want to write hello world. How is your day going? Okay, just a simple sentence. We can save this and then we can see whether we managed to write it using the cat command. So to save a file in a nano editor, you type Ctrl-O. Then once this pops up, you press enter, and then you can press Ctrl-X to exit out of nano editor. To make sure that we typed something inside of our file, we can cat it like this, so cat file2, and here we have our sentence. Hello world, how is your day going? Okay, awesome. But if we try to do the same thing with file 1, it will open this window, but as you can see, it won't work. It will tell us down below that this file is unwritable, as we can see right here. Why is this? Well, this is because we don't have enough privileges to change the contents of this file, or to write any new content. Remember, we created it with sudo command. So how can we write to it? Well, we can run nano with sudo command. Let me show you what I mean. If I type sudo nano and then file 1, now it works. We don't get the error down here, and we can also type something like today is Tuesday. We can save it with Ctrl-O, press enter, and then Ctrl-X to exit. If we cat file 1, now we also have the content written inside of our sudo file. So this is a way that we can actually create a file that cannot be accessed by a regular user. You would need sudo privileges to open and write to that file. Okay, but there is also another command that we can run to elevate our privileges, and this command is called sudo su. If I type sudo su, this command, instead of elevating our privileges for just one single command that we want to run, this will give us root account terminal. As you can see right now we have Mr. Hacker terminal, but if we run sudo su, now we get root terminal. We see it's not really the same. We have Mr. Hacker right here, while as here we have root name and we get this cool skull icon right here. But be careful while using root terminal, because with this terminal you can actually delete any file that might be crucial for the operating system, or you can make any changes whatsoever. There is no limitation. You can delete the entire operating system if you want. So only use this when you know what you're doing and when there are a lot of commands that you need to run with sudo, so in that case you can open a root terminal and run those commands and then exit out of the root terminal. Now you might be asking, well, how can I exit once I entered? Well, it's simple as that. Simple as typing exit. and we get back Mr. Hacker account. And let's also mention the last command for this video, probably the one that you will use more than any other command, and that is clear. Now, clear simply does as it says. It clears our terminal window. Perhaps you ran too many commands and you're looking at a lot of output that you no longer want to read, or you no longer need it at all. Well, simply by typing clear and pressing enter, we can get rid of all of that and get fresh and clean terminal window. Awesome. You're starting to get a hang of this. As you can see, terminal is not that hard to use. It will take some time for you to get used to these commands, but eventually it will become second nature for you. Okay, so there's one more video to cover for terminal, and we're left to cover some other commands aimed at networking and discovering our IP address, and so on and so on. So practice a little bit with these commands that we already learned in past two videos, and I will see you in the next one. Welcome back. So we can say that we covered some of the most known commands that are commonly used inside of a terminal. But what is important for us as penetration testers are also the commands that are more aimed at networking. For example, throughout the course, we'll constantly be checking IP addresses. Whether it being our IP address or target IP address, it doesn't matter. We will check it through terminal. The most important command that we use to do this is called ifconfig. Now, ifconfig gives us an output of all our networking interfaces as well as their IP addresses if they have one. Let's give it a try. So if I open my terminal and I type ifconfig, usually most of you will get rather the same output. Now, some of you might have an interface more or less, but usually in Kali Linux we will have these two main interfaces, ETH0 and loopback interface. Now, ETH0 is where I connect over the internet, and we can actually find our IP address under the INET tab. It's usually going to be in the second row, and we can see that my local IP address is 192.168.1.10. Now, more about IP addresses you can read from our networking PDF file, where we actually explain different types of IP addresses, how they look like, and between which ranges do they go. But if you want to check your own IP address or your Kali Linux machine, you can just type ifconfig command and it will be under one of the interfaces. Usually it will be under ETH0. And this is how we actually discover the IP address of our own device. However, to discover an IP address of another device, such as for example an IP address of a website, well, we can use different tools for this. One of the most known one is called DNS Lookup. But for some of you, the DNS Lookup tool might not be installed, and this is a perfect moment to show you how you can install different missing packages or tools with the help of terminal. So let's first clear our screen and install our DNS Lookup tool. The command that we usually use to install a package or a tool is called apt-get install. After apt-get install comes the tool name. In this case, since we want DNS Lookup, and DNS Lookup comes in a package called DNS utils, we want to type apt-get install DNS utils. Now, keep in mind that these commands must be ran with sudo privileges, at least in this current version of Kali Linux, so let's add sudo before the entire command. And let's press enter. It will ask us for our password, we will just input it right here, and it has finished. Now there are two outputs that you will get. Either it will install the tool, or you will get the similar output to mine right here, in case the tool is already installed, which in my case it is already installed. So now that we have it installed, let's try to run it. Let's say we want to discover one of the IP addresses of Google. We can type ns lookup and then google.com. We press enter, and in less than a second we will get an output. You can try this on any website in order to get their IP addresses, or one of their IP addresses, which is the case that we got right here. So we performed DNS Lookup on google.com. It gave us the output that the name that we searched for is google.com and that the IPv4 address is this one right here. Now, this is not the only Google address, this is just one of them, so you might get a different response. It might be that if you scan this multiple times during the day that you will be getting a different IP address for Google. You can also do something like this for Facebook or any other site whatsoever, and you will be getting their IP address as well as their IPv6 address that we can see right here. Okay, awesome. Now, same thing that we did right here, we can do with the command called host. For example, if I type host, but let me just clear the screen first, host google.com, it will give me a slightly different output, but more or less it gives us the same thing. As we can see, it gives us the IP address of Google, and we can already see that it is different than the previous one. This is the IPv4 address that we got for Google. The IPv6 address that we got for Google is this one. And we also get by which domain our mailing services handled. Okay, this is how we can discover an IP address of a website. But let's say that you want to, for example, discover IP addresses of all the devices that are online inside of your network. For this, we're going to go a little bit more advanced and touch on a tool called NetDiscover. Now, this tool we will also mention during the course, but let's just take a peek at it right now. It should be installed in Cal Linux by default, but if it isn't, you can use the previous command that we covered, which is apt-get install, to install NetDiscover tool. Now, in order to run it, after you have it installed, all you have to do is type NetDiscover. But once again, this being a tool that requires sudo, we must add sudo prefix to our command. If I press enter, well, that's it. Now we just leave it for a couple of minutes. It will scan all ranges of local IP addresses until it gets to your network range. Once it gets there, it will output all active IP addresses that are on your local network. Awesome, right? You can say that we just covered our first useful tool. Nonetheless, you get the point. We have many useful commands and tools that we can run inside of a terminal. And during the course, we will discover much more that you will use a lot. My advice would be that you spend a couple minutes every day practicing these commands that we covered, as well as researching some new commands that might interest you. For example, you can say, I wonder how I can discover what version of Linux am I running. Then you Google that exact question and you should find the command uname-r for discovering Linux kernel version. And let's just give it a try just for fun. You can see these are all the active devices on my network, so we can Control-C this. We no longer need it to scan the network. And to discover the kernel version of Linux, we type the command uname-r and we get the output. And this is how you learn. Anyway, if you have any questions regarding terminal or the commands that we covered, feel free to ask. In the meantime, we are one step closer to our goal of becoming a penetration tester. Let's continue to the next lecture. Congratulations, you did it. You went through the entire course and now you can proudly call yourself a bug bounty hunter. Of course, there's still a big road ahead of you. Everything we covered and beyond will require a lot of practice in order to really master it. But you're on a good way. In this course, we covered some of the most important bugs out there, but there are many more to discover, and for this, you will have to combine your knowledge that you gained with creativity in order to find them. If you enjoy the course, one helpful thing you can do is perhaps drop a kind word about the course to your friend, as you never know, they might also want to become a bug bounty hunter. A kind review also helps us out, as it tells us that you found the course useful. Nonetheless, once again, good job. You did it till the end. Your journey starts here. I'm sure that you will become a great bug bounty hunter. Thank you for watching and happy hacking.